the Earth isn't rotation, it's like there's no mechanism to make the stars move the pendulum, or the stars move the gyroscope or gyrocompass to precess.
Yep. So we're just gonna skip on by the incoherent experiment you guys tried to give us 2 minutes ago, and
I don't think
bring it
it's
on to that the stars
incoherent.
can't move.
I think there's a misunderstanding of the experiment, and I can't explain it like 17 times over the same way, so you can misconstrue it. So
No,
that's
nobody's
on you.
misconstruing anything. No, it's not on me. No one's misconstruing anything. You guys just are doing wishy-washy, incoherent science that doesn't even make sense.
Because you can't make sense of it.
You
it's
guys
wrong.
just don't know how to science, bro.
Yeah, do
You
you even
guys don't know how to
science?
science.
Do you even
It's all
science,
good.
bro?
Do you even science, bro?
Yeah, it's been
Dude,
repeated.
the thing you're varying, right? So,
observable.
no, man, like your heat knob or the pressure knob, that which you're varying will cause the effect that you're looking for. And when you manipulate that, the effect should be manipulated too. And you log that data, right? So you can figure out what the hell is going on here. So you guys are saying your independent variable was latitude, right? So that caused precession. That has to be it. There's nothing else we can deduce from here. Change of latitude causes precession. Okay.
Change of pressure increases heat, but you didn't. Did you notice that it also increases pressure? So you didn't make the thing independent.
No. I was boiling water. The effect for me was boiling water. Okay. And I decreased the pressure to boil it. I didn't use heat. So decreasing the pressure at room temperature will boil and freeze water. I can freeze water at room temp all day long in a vacuum chamber. Right? So by decreasing the pressure so much, just turn it straight to ice. Right? So, but anyways, that's not what we're talking about.
What's that called? Sublimation, or what's the word for that?
Sublimation. Yeah, when it'll go to ice, then from ice straight to gas, and it will just skip the boiling phase. It'll go from ice to gas. Sublimation. Yeah.
Yeah, that's I like that word. That's a good word.
Yeah.
You don't get to use that every day.
Yeah, the whole thing about like trying to figure out whether it's the stars rotating or the Earth rotating is to trying to figure out like how clockwise and counterclockwise rotation is measurably affected by changing the variable of location.
I have a question for you then. I think for me, I would like you to shed some light on that. So I've heard the claims also with stationary pendulum that it will also precess without changing of latitudes. So in that situation, what caused the precession here? Because there's nothing that was varied, not the speed of the nothing. They just set it into motion and it's running at steady state, but it's precessing.
I'm unfamiliar with that experiment. Will continue to do my research.
Well, Syrus, let me ask you this: if we had weight change, or sorry, if things fell at a different rate in the same location, like let's pretend that happens. They actually have a lab that's measured that, but let's just pretend that actually happens. Would that change the precession rate of a pendulum? Anyone? Does anyone know?
I don't know. Let's experiment and see. I've got no idea, man. I do not know what causes the pendulum to precess. There's
Would it change
many.
the rate? No, I'm saying would that change the rate of
The rate of precession.
Yeah.
Well,
Like
I would say,
go ahead.
If you're going from 9.8 meters per second to 9.75 meters per second, I think like a metronome, the timing of its back and forth rock would be different, but maybe minusculely the precession. I'd have to look into it.
Yeah, I would think it would change if you got things dropping at a different rate. I feel like the precession would change the precession also. I'm surprised they're not doing more stuff. Wouldn't you want to do more stuff at that? We're at the lab. I think it's in Spain. It's somewhere in Europe. It's not the one in Germany. It's not the one that begins with a B. Bremen. It's not the Bremen one. It's a different one. They just drop something, the same thing nonstop, and they've noticed that it changes rates. Now, once you start doing other shit with that, like set up a pendulum, set up a gyroscope, set up
Yeah,
try to change it, like put a heavier weight on top or something, like
yeah.
I don't know.
They may like rock back and forth in precession. They're roughly the same time. It's like it's an interesting question because you can take something like a gravimeter, which may have a measurement of the acceleration of, let's just call it gravity for simplicity's sake, and you can go, okay, the accelerometer has detected 9.801 at this pendulum, and if we go around the same line of or circle of latitude, you could find set up the same pendulum again, and you could take your gravimeter, and it might be 9.79. So you could definitely double check if that is a compounding factor. So it's researchable, definitely. I'd encourage people to give it a go. I'd like to try it personally if I could. Yeah.
If you look into the work of Gerard Polak, he tells us that the amount of shards build up in between elements is guided by the source light. And if you look at our sun in our world being our source light or point of origin, then it should matter the position or the amount of radiation that comes from that sun.
Yeah, that will. Yeah, how would you measure the radiation difference during the
Voltage.
experiment? Yeah, you could probably shield it from some.
All surfaces have an amount of voltage in them by their own, and they also have an amount of discharge on the surface. Everything has that, and special aqueous surfaces like the ocean floors, the land. You have an exclusion zone at the border, a transition zone.
Right. So these small, minuscule things are like trying to reduce the noise as much as possible, but overall
Everything is guided by charge.
Yeah, it depends on what scale they affect other things at what distances. So it's an interesting thing to notice the small amount of noise.
It's
in
for
the
the small
system.
and the big. It's for all. It's for all things. It's how things connect.
Maybe I'll look into it.
I got my coffee now, bro. Now we're gonna get serious. So so the precession in your gyro. I'm gonna go back to the work thing. What did the work? What force, right? Work is F times distance. Force times distance, right? The force applied multiplied by the distance it was moved, however long you applied that for, equals work in joules. So if you try to analyze this now, you're saying gravity imparted a force into this to cause the precession. Thus, I'm going to calculate the work of the pendulum of the precession was due to gravity. But then I'm going to ask you, how come it can't do it when it's stationary?
I'm not sure if gravity is causing any precession because even if flat Earth were true, mass would kind of attract mass in that sort of downward direction generally. So
yeah, but that causes an oscillation. We discovered from Cavendish when he hung two masses that they oscillate. So there's an oscillation in correlation with two masses. You always have a precession.
Yeah.
Angular precession.
When the mass moves the other mass towards one place, it will move the bar. And when you move it the other way, it'll move the bar the opposite way. it will eventually come to rest. Because
Eventually.
yeah, there's no perpetual
Right.
motion.
No, obviously not. No, it's going to get eaten up by
Yeah.
the friction. So in the gyroscope, it's a similar apparatus, sort of. Just the other mass, M2 would
It's
be Earth, essentially, and the thing is
a
just
flywheel. Yeah.
traveling. Yeah. So you can go that way, or if you go with the change of latitude, now I don't know what to plug in the equations like for force. I was going to give you the so-called force of gravity bumped the pendulum a little bit, but now change of latitude is like, bro, I don't know what to add in my equations now. Like I'm screwed.
Yeah.
I can't calculate the work. I need a force. F times distance.
To be fair, like if you had a rotating ball that was separate to the pendulum, the the or even rotated the pendulum around a stationary ball, it's apparent when you draw the line, it is like not a. I'm trying to think of the name. I'll have to come back. It's really too early in the morning after an hour and a half at 4 a.m. for me, buddy.
No
But
worries, man. Like you talked about, like the pattern it would draw.
inertial force. So I would say that the input for the pendulum was dropping it along the and the work was the swinging. I don't know what else to tell you from that. That the precession is an inertial force, or some people give it the poorly phrased name of a pseudo/fictitious force, but that doesn't really mean that.
Yeah,
It's a reference frame issue again, and
the
so like
Coriolis.
it's yeah, so
You look for
yeah,
Coriolis. Coriolis.
yeah. So you got the, even though it might be a inertial force, fictitious force, or pseudo force, it still has enough like real consequences of water rising up the edges of the Newton's bucket, cyclones, hurricanes, precession in gyroscopes and Foucault's pendulums.
What's water crawling up the edge of Newton's bucket? Is that like an electrified apparatus? Or
No,
naturally
basically it's a bucket, say like 1/3 full of water. The handle is pulled upward to the ceiling by a string, and you simply twist and twist and twist the bucket, and you'd place like a camera or something. So you'd have a reference frame inside the bucket, and you'd have a camera outside the bucket looking at the whole thing. So as soon as you let that bucket go, it will start rotating, and from the inside view, the water will appear to rise up the edge. And so you have to try and figure out, the person inside that might think the water is sort of got this inertial force, this fictitious force that I can't really figure out why it's rising up the bucket, because the camera is rotating inside that reference frame, but the other camera can see the whole picture, and that real force is the rotation of the bucket, which drives that centrifugal water up the sides.
Okay. Well, you picked up the bucket, right? So if you're going to model this like just basic physics, the potential energy, right? If you picked it up off the ground, there it is. There's the work. The work, you did it physically to pick up the bucket. So you exerted a certain amount of force to move this mass this amount of distance. And by doing that, this object is now charged with joules.
No.
Kind of.
Okay.
Kind of, but
Go
also
ahead.
the twist in the string was work. So when you release that work that you put into the string, so it's unwind, that's the unwinding work.
Sure. But you
Yeah.
like if you started the pendulum, let's just say, or bucket, pendulum, whatever. If I have a sphere in my hand attached with a rope to the ceiling, like a pendulum, and I let it go, right? At that point, right before I let it go, all the work I'm holding it with my muscles. I'm holding it physically up. I'm exerting energy to keep it in this position. Once I let go, it's not doing work. right?
No.
Now it has, it's got a certain amount of joules, right, that I have in there. Now that's going to dissipate over time due to losses.
Yes. Yeah.
I
And if you
charge the
cut the
system,
string,
or
yeah,
yeah,
that's right.
same shit.
So,
Yeah, same thing. The string is that. Yep, you charged up the potential energy in the string until you cut it. Now it's turning into kinetic energy as it's
Absolutely
going to
not.
the bottom.
Absolutely not. Nothing like that. No. Gravity takes
Really?
over the minute you let it go. Absolutely not.
Bro,
Gravity
this is
takes
physics
over when-
101. This is global or science 101. Like, what do you mean?
No, sir. No, sir. Absolutely not. You taking
Okay,
it up.
explain it to me.
You taking it up and holding
Oh.
it. That is not charging the pendulum. That is not doing anything to the pendulum. All you're doing is holding it. You are doing nothing to it. No
What's the
charging.
equation? What's the
You're not
equation for
giving it-
potential?
You're not
Yo,
giving it any
what's
force. Nothing.
I got you. I think you're not
I would
educated in
say,
physics well enough. What's
No,
the
sir.
equation for potential energy, sir?
Sir, you, sir, are not educated in physics because when you let it go, sir, when you let it go, something
Uh-huh.
has to pull it or move it.
Nope.
Something
No.
does.
Get the fuck out of here.
Yes, sir.
You
Yes,
picked
sir.
it up
Gravity
off the
does.
fucking ground. You changed its height.
Yes, sir. No, you
What's
don't.
the
No,
equation? Bro, what's
no,
the
sir.
equation for potential energy? Let's stop
No,
doing that
sir.
bullshit.
No, it has
No,
nothing to do with
sir.
the equation.
That's wrong equation.
Sir.
You're not doing
Sir.
equations. Oh, fuck your globe science then.
Sir.
We do
No,
equations
sir.
around here.
Sir. Screw your flat
Uh,
earth nonsense, sir.
We do math, we do science, and
Garbage.
we do equations.
Sir, that's foolishness. You holding it, sir, does nothing. Does nothing to the pendulum, charging it in order for it to go and do work. Nothing.
this is Newton's bucket we've moved on to, I think. Yeah.
Basic physics is the gravity. That's the basic physics. That when you let it go, gravity is what then moves it, sir. That's the basic fundamental physics, sir. Not you holding it, charging it up. That's garbage.
You know, it's the change of height because gravity's constant, whether you're on the surface or 1,000 feet in the fucking air. So it's the change in height would change your potential energy, not the gravity, because it doesn't fucking
No,
change. It's always 9.81 meters per
no,
second
sir.
square.
Sir, nothing. No, you taking it off the ground, sir. There's nothing
No,
in the
sir.
way. Sir,
Well, you
sir.
can't just keep saying no, sir, bro. You're just
Yeah, because,
absolutely
sir, you're
fucking
talking
wrong.
foolishness.
Physics
You're talking
101, like
don't talk
let's grab a
foolishness, sir.
physics book and let's end this debate. Grab a fucking physics book, potential energy. Let's see if it's related to height, change in height, delta H.
So,
Let's go. Let's go.
so
He's
What the
also
fuck is
talking
this,
through
man?
me, so mute him sometimes, please.
so
Bro,
I'm just
I
going to say,
mute
Cyrus,
myself in between here. What's up,
Cyrus,
Abel?
thank you for the convo, man. I enjoyed our camaraderie throughout the debate. I think it's been amicable. Got a bit feisty in between, but I'm not sure
Yeah,
if I
man.
100% agree with whatever Pac's going to go with. But I appreciate you contemplating the Newton's bucket, the
Yeah, man.
change in location for the Foucault's pendulum and the gyroscope. I think it was been a long debate, but thanks for sticking by. I've really got to go. It's quarter to
Thanks,
5
man.
a.m. for me in
It's
Australia.
been a
So
great conversation, man. I enjoyed
I
it.
look forward
Thanks,
to
bro.
more. They've been more enjoyable than I've had with a certain electric man.
Thanks, man. Appreciate it. Hey, see you next time, dude. All right, back to fighting. Put my mean face on. Let's go. Where's the physics book?
Yeah, bring out the physics book.
Go for it. You're saying I'm wrong. You should bring it out.
You're not charging something by lifting it. You're not charging it up to do anything. You're simply just lifting it up. It's all in your
Says your
muscle.
mom, not
So
the
when you
physics
let
book.
when you let it go, it's not because you have charged it up why it goes to the ground, sir. When you let it go, it goes to the ground because of basic Newtonian physics. Very, very basic. There's an
It
acceleration
goes to
rate
the
of
ground. It
9.81
goes to the
meters.
ground because of Isaac Newton. Sounds good. I like that.
Absolutely, sir. Yes, sir.
I'll
Don't
take
worry,
that. Yeah.
remember,
Isaac Newton pulls that shit down. You're right.
remember, you have been told over and over again to deny gravity, and therefore you're denying basic physics. Okay?
Bro, you are so boring. ruining my coffee.
No, sir.
That's
You
how
are
boring you
boring,
are.
sir. Sir, you're saying me taking up something off the ground, I'm charging it up. When I let it go, it's going to do some work now. That's garbage.
It's a very short chapter about potential energy and kinetic energy.
I
Like,
know potential
potential
energy.
energy is maximum at maximum height and the least at h equals 0, and this is where kinetic energy equals the most. So it's like, shut up. Shut up.
Please.
I'm
Oh yeah,
reciting the physics book.
So, sir.
I'm just
Sir,
reading
what
the
about
fucking pamphlet and you're telling me I'm wrong. It's like,
please, you're
okay,
wrong.
bro.
You're absolutely wrong. Then
Go.
there is a constant gravitational pull towards the ground, 9.81
Sounds
meters
good.
per second. It is always acting on you and on all objects, sir. All things, sir. So please, please take your nonsense away from this man.
So he recites the book and you tell him no. Okay, it's funny.
No,
All you
he's,
elbow. I'm
he's
giving up, bro. I'm
yeah, but
tapping out already.
Okay.
I'm gonna tap out
misapplying,
of this shit.
That's
misapplying
fine.
physics. Misapplying physics. Oh, I'm lifting up something. I'm charging it. Garbage. Full-fledged garbage.
All right, man. Let's do it. Let's take a 1 kilogram object, okay, on the floor, and then lift it up 10 meters in the air. How much potential energy does it have at height equals 0 and at height equals 10 meters? I
Sir,
gave
sir,
you everything you need.
sir. Irrelevant, sir.
Give me a fucking number in joules.
No, that's
Otherwise, I don't want to
irrelevant.
listen, bro.
No, brother, you need to listen. It's why it goes to the ground, sir. It goes to the ground because of gravity, sir. Not because you lift it up a height of 10 meters or 2 feet. No, it goes to the ground because of 9.81 meters per second that's constantly acting on it, sir. Not because it's charged. No, absolutely not. Nowhere in any physics book. Nowhere. Just find me a citation that says, "Oh, I'm lifting up something and I'm giving it energy to move now." Nowhere.
Nowhere. You don't have to exert energy to take anything uphill. Nowhere. Think you lost your mind, bro.
I'm talking about going to the ground, sir. That's what I'm talking about. We're talking about why
I
it goes
think
to
your
the ground.
brain is all over the ground and it's got potential energy of
Yeah.
0. You pick that shit up, son.
Right.
Like
Well,
anything
we're
you
talking
push
about why.
uphill, you have to exert energy. It's like,
Oh,
what
yeah.
the fuck are you
What,
talking about?
dude, you're
Like,
exerting energy because
you're nuts.
you're resisting
Can't talk
gravity.
to a madman.
Brother, you are the madness. You are working because you're resisting gravity and friction. That's when you're pushing it up a mountain. Friction and gravity is making you work. You're working against those things. Okay, sir? Not because you're charging something up. I'm charging it up now. I'm pushing it. I'm giving it some energy. No, sir. Absolutely not. That energy that you're exerting on it is not being transferred to it now in order for it to take off into the air or shoot back to the ground. No, sir. Remember, you have been indoctrinated to resist gravity. Gravity is just a theory. It's foolishness. It's fictitious. It's pseudoscience. You have been told that nonsense over and over, and you believe it, right? Gravity is real. It's a real thing. There's a real reason why things go to the ground. It don't just happen because it just happens. It's not no God magic, dude. God probably created the rules, but God didn't say, "Oh, here is something coming down. I'm gonna move it. I'm gonna move it." The magic. Let me sprinkle
Man,
some
I
third
didn't
realm.
mention God or any of that, but it's okay. Keep on speaking. Come on.
Let, let,
Tell us
let,
the
let,
story. Tell us the story.
let me
Preach.
sprinkle some third realm magic on the apple to go to the ground. No, sir. There's a displacement of space and time around you at all times because of mass. Space and time are
Oh fuck.
fundamental to your universe.
Don't go to Einstein. You can't even handle physics math. You're gonna go to tensors. Okay, what's the Ricky tensor, bro? Unfoil the Ricky tensor in a fucking Einstein field equation. Since you brought it up, motherfucker, let's go. What is the Ricky tensor? Explain it to me. Like, I don't know anything about it. I'm
We
just gonna
don't have to
pretend
go
like I
that
don't.
far. We don't have to
You're
go
the
that
expert. No, yeah, we do. You said mass and fucking time is warping and shit. Oh, okay, explain it to me. No,
far. Yes, sir.
equation. Break down the equation for me. I want you to solve the equation. I don't just not with words. Post it. Start up a fucking live stream or whatever. I'll watch your screen. Walk me through Einstein's shit. Since at all times we have what space and time bending around time, or whatever the fuck you just said. But yeah, go ahead, explain to me. What's the Ricke tensor, bro? What's the energy momentum tensor, bro? And what's the value of it? Shut up. I'll tell you what you need to Google if you're gonna Google shit. This is called the Einstein field equation. Look it up, study, learn how to use it, and come back spit that nonsense. Then we'll talk. Anyone out there? Hello.
He ran away from the tensors.
Yeah, I didn't know that was gonna shut him up, bro. I thought he was just gonna keep on rambling. To be honest,
He's part of the
work.
Gullah witness.
Yeah, he's pretty bad. I don't think I've talked to him before, and I don't want to talk to him again. I'm good.
Yeah, he always comes in. Oh, so annoying. Dude's like we called Dunning Kruger, like times 10.
Right? Yeah. I enjoyed his story though. It was kind of just shut up and let him like unwind, and he brought God into this. I'm like, bro, nobody here said God in like the past like at least 20 minutes or half an hour. So it's like I don't know what you're talking about. I've got no idea. But it's okay, man. We're gravity deniers. Whatever.
Took a phone call there. Yes, gravity is fundamental, basic physics, fundamental to everything that we do. It is built in, the calculation is built into everything that is roller coasters, buildings. Like, like you have buildings that are vaulted ceilings, too tall. You have to put a column there because there's too much gravitational, too much weight, right? Which is a direct link to gravity. Yeah, man. Come on now. Fundamental physics.
Fundamental physics. That's not how we measure weight, man. I think you're lying about the fundamental physics a little bit. Well, okay. How about this? I got you. Using Newtonian mechanics. Okay. What's the weight of a 1 kilogram object?
1 kilogram.
How'd you know that?
Because you told me.
Correct. Now weigh it with Newtonian mechanics.
No, you weight with a scale. Sorry. I mean, are you not, you not know about scales?
Ah, yeah. Do you know that scales don't work that way? A scale is worked by Hooke's law, negative kx. It's called spring deflection,
Of course it's spring
right?
deflection,
Multiply. Oh my God! Oh
yes, uh-huh.
my
Yes,
God! So,
yes. The skin,
uh
yes, because what
huh.
happens is, the spring has a pull back, right? So what pulls the spring down is the weight of the mass caused by gravity, right? So the spring has a recoil effect, right? So it oscillates till it settles on what exactly gravity is acting on the mass of 1 kilogram.
Where is gravity in the equation here? The equation is negative kx. Hooke's law.
No, that's just
Where
a
is
spring.
gravity?
Gravity is 1 kilogram.
That's I know, yeah, but that's how we actually measure stuff, right? Because we came down to I was like, how do you know? You said, yeah, I told you correct. I asked you weight. Then we went to spring deflection. Where's
No,
gravity in the spring deflection?
we went to a scale. Yes.
Yeah, because you don't need gravity in spring deflection. You need a calibrated
Of course
mass.
you do.
Something
Of
we're
course
gonna
you do.
call 1 kilogram, and we're gonna stick to that. And then we
Sure.
just go off of that. This thing,
No,
right?
what we
Deflects
call
this spring with this spring constant, this distance. Yeah?
springs don't move.
Thus it weighs 1 kilogram.
Springs don't move by themselves. Sorry,
Of
something
course not.
causes it. Okay, thank you.
Of course
The
not. You have
gravity does that.
to
Gravity,
impart energy to the
gravity.
spring, and the spring gets charged with energy. No, of course not. It doesn't have to. You can pull the string. The spring. It's not gravity. Gravity with your arm.
Gravity.
Force. Gravitational force doesn't have to be.
It has to be because
You can
it,
grab that spring and pull it
because
horizontally. You know what I mean?
I'm sorry.
No, you don't. It doesn't have to be.
Well. Thank you. Fourth. Now you're proving our point. So you need a fourth
No, I'm not.
to pull it
I'm
horizontally.
not.
Thank
Of
you.
course, yeah.
Yes, thank
Forces are
you.
great. Now,
Yes,
okay.
thank you.
Let's keep going. Okay. Thank you. What?
No. When the minute you mention I can pull it horizontally, pull it, pull it means you have exerted a force. So when it is vertical,
Yeah,
what is
yeah.
so
We
what
already
is it?
agreed that force
So when it is
is going to
vertical,
deflect the spring,
what
right?
is doing the pulling? What is vertical? What is doing the pulling? Gravity.
No, I thought it was the mass of the fucking object. Gravity. What the fuck is this now?
Gravity.
Isn't it the mass of the object?
The gravitational
All I
ratio.
did is I varied the mass of the object, and the spring deflected more as I increased the mass. I grabbed one stone, it deflected this much. I grabbed two stones, it deflected twice as much as one stone. Now, where the fuck is gravity in this? Mass, I'm with you. It was the mass of
Okay,
the
so
object,
it's weird. Yes,
right?
the mass of the object. Gravity acts on the mass. Gravitational force, Fg, equals
Okay.
gravitational constant times the product of the mass. Mass one, which is
Yes.
the object you put in the scale, plus plus the mass of the
What
Earth,
is this?
right?
Explain to
Times
me. I
you
want.
take,
Wait.
so you take the
I'm
product.
already
So
lost because
you take the product,
I need
divide
to
by
understand what is this gravitational constant. Well, yeah,
oh, you don't know what
yeah.
the
What is this
gravitational constant?
gravitational constant you
Oh,
mentioned?
you didn't
Explain
know.
it to me.
Okay, the
I don't.
gravitational
Tell me what that
the
is.
rate of
Yeah,
action between the mass. It's a rate. It's a constant rate. 6.6
and
times
and
kilogram.
I observed that deflecting the spring.
Uh,
That
of course,
deflected the spring.
yes. That is the rate of
Did
attraction between
holy shit
it is the rate of attraction between the
of
1 kilogram.
attraction between
The rate,
M1 and
the rate,
M2 divided by R squared. I have this shit
right?
memorized, but it's okay.
The rate of
Anyways,
attraction.
the rate of what?
The rate of attraction between the 1 kilogram mass and the Earth.
How did you measure that rate to plug it into your
Easy.
equations?
Okay,
You just like
okay,
easily.
okay.
Holy fuck. Okay.
We have much more sophisticated
Ye-
methods these days. But let's go back to the basic Cavendish. The basic Cavendish experiment, which
Okay.
I did the Cavendish experiment, which was really really cool.
Awesome.
And of course we calculated that rate of attraction of virtually 6.6 times 10 to the minus 11. We calculated that over a period of
Huh?
time. Thank you very much.
Okay. How did you do the calculation? What did you measure? The balls, the deflection, and the oscillation of the balls. What did you measure here? Because you are gonna get the big G out of it. So I want you to work me through how to get big G out of it. Like you got the
Okay,
floor.
this is
How you did it,
let's get to school.
especially because you did it.
You're gonna have to let's enroll in yourself
Oh yeah,
into a university,
yeah,
UCLA.
yeah. You're teaching me right now.
No.
Correct. We
You
are
need
in
to be.
your university now. Walk
You
me
come
through
to
it.
me.
You did the Cavendish fucking experiment, man.
No
Just
words,
walk me
please.
through it.
This is a talking app.
Oh, okay. Okay. Oh well, fine. We can stop talking.
That's why I always tell flat earthers, go back to school. I tell them all the time, but they get up, they get mad. They're like, oh, hey, you don't tell me what to do. What you gonna give us, dude? Go back to school. That's what you do. That's how you become me. Great.
I didn't get mad. I asked you and how you derived it, and then you just told me to go back to school. So at this point, yeah, the conversation is pretty much over. There's nothing for me to add.
Yes,
I
sir.
asked you
Because
to explain it. You're like, go back to school. I'm
no,
like,
no,
okay,
no.
I didn't get mad. You're
Yeah, no,
mad because I was like, okay,
my knowledge costs a
I
lot
can
of
keep
money.
arguing. But
My
at this
knowledge.
point, I can't argue with you. You're not giving me data. Give me some data.
I don't get, brother. I have an aversion to giving away free knowledge. You know, we paid a lot of money for our knowledge. Me and Bacon up there. We didn't. We worked hard, a lot of long hours at night, staying up, going through the information, doing the experiments in labs. I did Foucault's pendulum. I did Cavendish.
Crimea
All of
River.
it, brother. Yeah. I know. It's sad. It's sad, but it was worth it. Yes, sir. Because that's why we understand that the Earth is not no stupid flat plane. That's dumb, right? It's the dumbest thing anybody could believe. Period.
Because two balls oscillated on your desk. See? Four. But two of them were oscillating. Two were
I like
stationary masses. And you measured the rate of oscillation. And now I want to see the derivation to get G. You can always look this shit up and cheat, man. It's like so easy to Google. You're lazy.
No. I like the way you framed it. Oh, because two balls oscillated on your table. You see that? You're joking. You're playing around. You're not serious. You're not doing science. You're doing gotcha. Come on, man. Back to school.
You did science when you oscillated the balls?
When I oscillated the ball or gravity, which one?
Well, if you said, did you do science? I mean, that was my question. If you said, if you're going to say yes, I have a follow-up question. If it was no,
The
then
Cavendish experiment
we're good.
is science. Yes, sir. Yes, that's science. Did you
You-
know that?
What
Did
was
you know that?
what was your independent
Did you
variable?
know that
What did you
experiment? Did you know
vary?
that experiment?
Wait, what did you manipulate? You have to manipulate a
Yes,
variable. It's called the independent
yes, the math.
variable. And the dependent depends on that one, yeah. What did you manipulate to change the effect?
Okay, did you know that experiments are part of the scientific method?
Buddy, I'm into what an experiment is already. I'm asking you for your independent variable. And your dependent, please. Just list them out. These are yeah, we're already deep into this shit. Can't back out of it now.
No, you're not deep. No, dude. If you are here questioning the Cavendish experiment, you're not deep. If you're telling people that when you lift up,
Man, I'm questioning your experiment. You said you did it, and I'm asking you what you varied, bro, on the desk. I want to do it too, right?
dude,
So I get two balls. Now what? What do I vary?
so
So I have from my
if you're
basic
telling,
understanding of science.
if you're
Like
running
it's pretty
around the
simple
world
shit.
telling people you're adding charge to something because you're lifting it up, you're not there. Sorry, no sir.
I mean, if do you know what a joule is? You're not adding joules to the object when you lift it up. I bet you are.
No,
You
no,
can
you're not.
convert it right back to
You're
joules
not
when you
adding,
drop it.
you're not
100%. The
adding
joules you
joules.
spent up are the
You're
joules it takes to come down,
expending joules. You're not adding joules.
plus losses.
You're not adding the joules. You're expending the joules. Your muscle energy is being expended. Your calories are being burnt. That is where the energy is transferred. Your calories are being burnt. It is not
Oh,
being.
transferred. Yeah,
It is not.
transferred into what? Where'd
It,
they go?
your body is burning the energy, the work from your
Then what?
muscle. Your calories are being eaten up. It is not
Yeah,
being
you're going
transferred.
uphill?
It is not being transferred
You
to
just
the
said
object.
it's being transferred.
It is
Okay,
not
what
being
happens when you drop the
transferred to the
object?
object. It's transferred to
Oh,
your
you're
calories.
crazy.
Your calories is
Oh,
transferred to
really?
your calories in your body. That's
Okay,
what it's.
how come when you drop the object now, right before it reaches the bottom, right?
Mhm.
It
Right.
has all the calories that you spent.
No, that's not
Minus
what
the
it.
losses,
No,
of
that's not what it has.
course.
No.
Oh, it
Gravity.
doesn't. Oh,
Gravity.
you
No,
crazy
no,
man.
dude. The
Oh,
gravity is what's causing that object to move to the ground. When you use your muscles in your arm, you are transferring that energy to the calories in your body. That is where the energy is being transferred and burnt up,
into the
right,
atmosphere.
into the atmosphere. Yeah,
But the ball
not the
hasn't. The
ball.
ball doesn't have more potential energy now.
No,
No joules into the sphere. No.
nope.
So if I kick it off the cliff, how come it's got kinetic energy now once it starts moving?
Oh, gravity.
Where'd that come from?
Gravity. Thank you.
No, the potential energy it has to equal zero, bro. Come on, man, it has to balance out. So
Gravity.
potential energy at
Gravity.
maximum height
Gravity.
equals kinetic energy at minimum height.
Gravity.
No, it's a balance of energy. You can't create or destroy energy, bro. Like this is fundamentals of physics.
Brother, the energy is your muscles, right? Your muscles, as your muscles work, the
I use the
calories in your
winch.
what the
I just
calories
used the winch. I used an
calories in
electrical
your
winch so I
body
could
is
measure
your
exactly how many
that is
joules
the
went
only
into it.
that is the only place energy
This guy.
transfers and breakdowns are happening, not to the bob. The bob is not. The bob is probably well. Your hands are warm, so you're probably adding some warmth to the bob, probably. But dude, that warmth is not what's dragging it to the ground. What's dragging it to the ground is the gravity from the center mass of your planet.
Okay. I don't know. You have to verify that for me. I'm
Uh,
willing to listen.
Seismology, yeah, do it. Look it up.
So what? Seismology? What? That's earthquake shit, isn't it? What about earthquakes?
You see, Bacon. You see, Bacon.
Man, you just scattergunning here. I'm so
I hope
confused.
you
No,
listen, Bacon.
earthquakes.
Dude,
Well, explain to me
you're telling
why the
me,
ball has potential energy. Mm,
Bacon.
My brain is cracking.
Bacon. I
I need
got
a smoke. I'll be back.
Bacon. You cussed me out last night. You hear how these people talking, brother?
And I hear how you talk.
Yeah, you hear. Okay, so who is right here, brother Bacon? When he's lifting the bob, is he adding energy to the bob to then go do work? Yes or no?
Who's Bob? And why are you lifting him?
Right. That's the pendulum, brother Bacon. It's a pendulum, the Foucault's pendulum, brother Bacon. Come on now.
Ah, okay. Yeah, I wasn't listening. Okay, so what about it?
No, I'm straightforward, Bacon. I don't play. So you can take over if you want to do this technical gyroscope with them. You can, but you're wasting your time.
I never got into gyroscopes. Oh, he left. That was intense.
No, I wasn't even talking about pendulums or gyroscopes, man. I was just talking about potential energy. Taking a bowling ball and lifting it above the ground.
Yeah, what about that?
Nothing. He wants to paint it in such a way where it's gravity doing everything. I was like, no, man. I spent energy in terms of joules to take it uphill, and then I get that back when I release it, minus the losses, of course, friction. And this is where he's just spiraled into his gravity thing, and he's just not. It's not a conversation. I was just listening. Whatever he wants to rant about.
Well, okay. Like if you move something up, you give it potential energy, right? You spend energy, but you give it potential energy. That doesn't happen if you do it
Yeah.
horizontally, right?
Yeah,
Like if you spend energy to move something to the left, you don't gain energy by moving it back to the right.
No, it does not. No.
Yeah, so there is a gain in potential if you do it vertically, but there is no gain if you
There's
do
no
it
delta
horizontally.
H, right?
Yeah, that So there's
Dude, that wasn't even the discussion. We never made it to that, bro.
I know, but I'm making it now.
Ask him. He's the one that's fine. He's got problems.
Yeah, he's horrible at
He's saying I'm resisting gravity as I'm going uphill, right? And I'm like, whatever. I'm spending work. I'm just attacking it from with joules, thermodynamically. Work. Just give me some energy, work, something I can work with, plugging the equations. And he just wants to run out of gravity. It's like, whatever. And I'm never denied the gravitational acceleration, by the way, ever. In the whole conversation.
I think your connection sucks right now because you're all
like
robotic.
whatever. The gravitational acceleration. Yeah, my connection does suck. Yeah,
it doesn't sound like it got any better. Last time I talked to you, Syrus, you said you never got into the navigation thing. Is that still the case?
Yeah, but it's not going to be for very long because, God willing, I intend on learning how to sail. Right, so
Nice.
I'm definitely going to take some courses, and yeah, so I know I'm going to have to get into So I'm just going to learn it the way it is, the way it's taught on a globe and all that. You know what I mean? And then as I gain hopefully experience and knowledge in the field, I'll be able to discuss stuff with you. Otherwise, I'll just tap out, man. I've got no idea. But yeah, I'm excited though. I've been stargazing a lot out here, so it's pretty cool.
Yeah. Yeah, the process of solving for your position is kind of independent from sailing.
Yeah, but I'm gonna have to learn about it, right?
Yeah.
No?
It's kind of designed
Yeah, okay.
around it. For example, if you want to solve for your position, use on an airplane, then the process is going to be slightly different. So it's a bit tweaked into around the fact that you're sailing. But
it shouldn't matter that I'm sailing. I can do it anywhere on Earth on the land. Yeah, right.
Yeah.
Cool. But yeah, I was just telling you why soon I'm gonna have to pick it up. No way around it. It's the ocean, right? It's all right. So no GPS. How do I navigate here? I have to use the celestial GPS.
Yep. You better carry a clock with you, a watch.
Okay, stopwatch.
Yep.
What else? What other tools?
Or something to measure angles, like a sextant.
Angles, like sextant. Okay.
Yeah. And you're gonna need a bunch of information.
Okay.
So usually those.
But that's all I would need to measure. Is just the angles to certain stars or whatever.
Exactly.
Okay, angle and time. Okay.
You measure those two, you're good.
Okay.
Other stuff helps, if you're moving, and you want to take that into account, then you can get a better result by accounting for how quickly you're moving and what's your bearing as you're moving.
Yeah. Okay.
But that's usually not that significant. If you skip that step, you can still
close enough. You'll be pretty close to.
Yeah, you won't be
plus or minus whatever. Yeah.
Exactly.
Okay.
There's a big tolerance.
I mean, you're probably one of these guys. I'll definitely hit you up first for wherever you chill. If you're gonna just run me through some basic celestial navigation stuff, how to do it, without arguing our differences flat or actually how people do it. I don't care what the shape is right now. It's irrelevant.
Yeah, I can fully explain how to fix your position without having to touch on your shape, because I can simply describe the step-by-step method without getting to the reason why that's the case. Which is why I know a flat earther could do celestial navigation if you wanted to. There's nothing preventing anybody from learning the step-by-step process.
Right. Yeah. Regardless of the shape, just apply the method that works, and off you go. Like if I'm trying to actually sail to get to the port, destination port that I'm going, like I just want to get there, man. So what actually works? What's the most accurate? Give me that. Plug in some
Yeah.
numbers and
Yeah, you can always
stuff.
treat it like a black box, right? You just plug in data, it spits out data, and
Yeah.
Yeah.
But I don't want to, of course. At some point, once I understand just the fundamentals of the black box, now it's like let's dig in, right? I need to have a fundamental understanding, though.
Yeah.
So I understand like basic stuff, imagination in the head, right? Either flat or globe, right? And that doesn't matter. As I move, what would it be? 1 degree every 69 miles if I'm moving north or south. That star, whatever star it would be, it would move. It should move 1 degree, right? Every 69 miles I traverse.
Yeah, you usually
Is
don't
that
deal with
correct?
miles. Yeah. We usually
Yeah.
work with nautical miles because a nautical mile is just the same thing as an arc minute. So if a star drops by 1 arc
Okay.
minute, that's 1
Angles.
nautical mile. Yeah.
Okay.
So you can use those interchangeably.
Yeah, it's fine. I can work it in radians until the end and give me a real mile. So, okay. So you use that arc from what? From like inches from the. Is it from like the core of the Earth? That arc distance, like the.
Yeah, it's that distance is like an arc length distance, right? So
Okay.
each nautical mile is an arc minute of the arc.
Okay.
And then that gives you a circle around the GP.
Right.
But I like what most folks
Okay.
say when they are discussing navigation. You're not going to draw the circles. That's the first step a lot of people get wrong when they're debating celestial navigation here on the topic of the shape of the Earth. There's two versions of celestial navigation. There's the version that people talk about when they're debating flat Earth versus globe Earth, and there's the real one. Right? Those are different. The way they describe in the debates doesn't match what's done in practice.
Oh, okay. The real ones, like there's like the charts or whatever, they have circles in them. They have like they're weird, not navigational charts, but like the stuff when they plug in the data for the stars and shit.
Yeah, tables. They have
tables. Yeah,
it's called psi reduction tables. So if you look for the circles on a fix, you're not gonna find any of them, but you're gonna see some straight lines, and they are actually like a small part of those circles.
Straight line. It must be flat bacon. Gotcha. No, I'm joking.
That's actually like a good point to respond back to anybody that says like if you're treating this as a straight line, it must be flat, because the circles of equal altitude are circles. That's agreed for both sides. Flat earthers and globe earthers are going to tell you circles of equal altitude are a circle, but we're still plotting them as straight lines, right? So you can sometimes treat a small section of a circle as a straight line.
Yeah, right. Infinite straight line segments.
Yeah.
Makes up a circle.
If it's a small enough section, then the difference between a straight line and an arc is not that significant.
Right. I know. Yeah. I can work with that.
Yeah. Like if you would actually do the analytical solution for your position, that would be like a very heavy mathematical process. Sailors 200 years ago couldn't use the Casio calculators, right? So they had to simplify it as much as possible. That's why they use tables. That's why
tables.
A lot of approximations. Yeah.
It's like, have you ever tried to solve a logarithm without your calculator? We can just put log. It's like, bro, you have to look all this stuff up in tables. The logarithmic tables, here we come. It's like, oh my god. It's like, you just have to look the stuff up. So I get it. But if you're in the middle of the sea, you can't use you don't have a calculator or whatever. Yeah, I do want some
I would be
tables
fucked
on me
up
for sure.
Like I've seen these tables. I'm not sure if I needed. I would know exactly what each column and row means. So maybe I would struggle a little bit trying to decipher that, because I usually just run the formulas. Like I know the formulas, I don't need the tables.
Okay.
But if I don't have a calculator, I just have the tables, I would have to take some time to try to understand how
So
they
you
are.
will need a scientific calculator for sure, right? You can't just do basic arithmetics.
Yeah, I definitely need trig functions.
Okay, it's got tricky.
Yeah, that's why the tables are so important if you don't have a calculator, because you can't even like solve things with just multiplying and adding. There's a lot of trigonometrical functions behind those tables.
Cool. I'm excited for it, man, because of the whole debate thing too. So it's like I just want to use it for practical purposes and understand it. Then let's see. So what's the difference if I assume the shape? Like if I assume flat versus globe, what's the margin of error looking like? Like plus or minus how many nautical miles at destination or some shit?
It depends. So
2,000 mile journey. So
yeah, it can go up to thousands of miles easily. But it depends.
Okay.
Like okay, on the globe there's a obvious way that the star angle and distance relate, and there's a known map already, right? So if I want to translate that to flat Earth, then I just have too many options. I'm not sure which one to pick. But whichever one you pick, you can easily get thousands of miles of error.
Okay.
I can't give you a solid answer.
It's just because of the map I would be using essentially. Or
Yeah, like the way latitude and longitude work on a globe is that they're spread around the sphere. If you want to use a flat Earth,
right.
you're going to spread latitude and longitude on a plane. Depending on how you spread latitude and longitude on a plane, you get different results. So you pick one way to spread latitude and longitude on a plane, and I'll tell you what the error is going to be at a certain scenario. But that's going to vary. Like if you pick
So
these two stars, that's one error. If you pick those other stars, that's another error.
So what if I use so if I use a sinusoidal projection as my base map,
Let me see that.
and I believe that's the most accurate one off of the globe, right? The sinusoidal projection. So, and I use it only for the sections, of course, that are there.
Is it the one that I'm looking at here? Like kind of a diamond shape, but with two ends, like two rounded.
That's stuck together, but you can look at it like a square, and it'll look like a sine wave, like a high frequency sine wave almost. That's why it's called a sinusoidal projection. I believe it is the most accurate projection we have. I could be wrong on that though. Usually.
Right.
But that's how I came across it. Okay. So because like if I go to NOAA and OAA.com and like get navigational charts, there'll be pretty much a section of a sphere, right? But you're so far in that it's almost square grids, right? But it is spherical in nature, if I'm not mistaken.
Yeah.
Okay.
But the issue
and that
is
one
like
gives you the most accurate results, right?
Yeah, but again, like we are not like drawing the circles, right? We are we're mathematically solving for in which direction they are and how far they are from us, and then we draw a straight line there. That's essentially how we get the circle.
Okay.
So yeah, if those maps are going to have different distances that the globe does, so how far those lines are from you are going to vary. So they're going to throw your position off.
Okay. It's gonna be interesting, man. I think I'll visit you in Brazil if you're Brazilian. I'm not sure. Portuguese
I am.
accent.
No,
Yeah,
Portuguese
so it's
accent is
like,
a bit different, but I'm Brazilian. I think
my
Portuguese
bad.
sound more like Russian than compared to Brazilians.
You sound Brazilian, so I was like, all right.
Yeah, yeah.
Yeah, I need to learn how to sail, bro. Like, yeah, sailing is badass. I'd like to get a sailboat, which means I have to learn how to sail first.
Yeah,
So
I never been on a
gotta go.
sailboat.
Yeah, it's free energy, man. I mean, not free, but like, it's wind powered
Yeah.
versus if you want to travel by, a motor, man, you just burn up so much fuel. It's crazy. It's like, it's insane versus
Yeah,
sailing. So
the way sailboats work with wind powers, it's very cool. Like you can go faster than the wind. That's insane.
yeah, dude. Yeah, it is insane. It's insane, dude. And you can sail upwind. It's
Yeah.
like, how does that work? But it's pretty badass.
Yeah, I have an
Being like
idea of how it works, which is what I
I've seen a
think makes
video
it
on it
more.
one time ago.
Yeah, I think it makes
Oh,
it
go ahead.
much more
Sorry.
interesting to look into how the sailboats work.
Yeah, it is pretty cool. The modern sails, right, where sailing upwind is not a problem. It's like, that is cool, man. So it's the distances between the lines on the map that's going to throw me off, essentially, right? Okay.
Yep.
Okay. So using a spherical section, essentially, right, would be the most accurate. Like a globe, just zoom in the globe, boom, spherical section.
Exactly.
There
So
you go.
like I
Cut that out.
have two different apps online. One does the, let's say, the real way. It just plots the lines, and the other one actually draws the circle on a sphere. If you use both with the same readings, if you zoom in into the sphere with the circles, it looks exactly like the plotted one. So the plotted one is essentially trying to replicate a picture of where the circles cross on the globe.
Okay, circles. So, okay. What's the other circle? So one of them that's the trajectory, right? Where you're going, right? That line. I understand
No.
how around a sphere would be a circle, right? No, wrong.
No, they're circles of position. Like, so you measure the angle to a star. That tells you how far you are
Okay.
from its geographical position. So if you know how far you are from a certain point, that's a circle. You know that you're somewhere along the circle, right? Because everywhere on the circle matches the same distance you just measured.
So you measure the angle of the star from the horizon, or where?
Yeah, how high it is above the horizon. Yeah, and that tells you how far you are
Does
from its geographical position.
the time matter?
Yes, because the
Because yeah,
geographical
of
position of the
course,
star
yeah.
keeps moving. So
Mhm.
you want to know
Yeah, it moves
where the
every day,
position
right?
was. Yeah, every second. So you
Yeah,
want to know.
slightly. So slightly. No, I mean, like, so let's say at 9 p.m. I'm looking at Sirius Alpha, whatever. Okay, cool.
Mhm.
And
Yeah.
this is the angle to it at this time, this date. If I go like 2 weeks later, it's not going to be in the same position because the whole picture moves right throughout the year. Like in the
Yeah,
summer here, I can't see Orion's belt. I
yeah,
can
but if
start
you
to see it. Yeah, go
if you
ahead.
wait just a couple seconds, you're already gonna measure a different angle. So like the distance between you and the GP of the stars move quite rapidly because the GP moves quite rapidly. Like
Okay. Okay.
if you think about the point right below a star, that's moving across the Earth, and it makes a full cycle in 24 hours. So that's pretty fast.
Right. It is. Yeah. When I observe it, it is pretty fast.
And that
Okay.
relates to the angle
Then
you
what?
mentioned.
So I would take that measurement. Just walk me through it. I'm trying to imagine this for the first time. So
Right.
Sorry if I stop you a lot and ask you questions because I'm
No,
just
that's good.
doing
That's
it for the
good.
first time. So,
I
okay,
yeah, mhm. I teach classes. I teach algorithms, and I actually invite the students to interrupt me as much as they want.
okay, awesome. So I have my horizon. I have picture of stars in front of me. Walk me through it. What do I do?
Okay, so you grab your sextant. You have two sights on the sextant, right? You can see like two things at the same time with the sextant. And you
Okay.
can tilt a mirror. Like one of the sights bounces between two mirrors. So you can tilt one of those mirrors to change that sight, while the other one is continues towards the same direction. So we can point at the horizon, then move the other mirror up till you find a star, or the other way around. You can find a star and then lower the other side down until you hit the horizon. At that point,
Okay.
the two sides are going to be one pointing at the star, the other pointing at the horizon, and you can now freeze your hand and look at the angle measurement on the sextant. So you can read the angle from the sextant. And also you want to know exactly when that was. You look at you stop the time, you note it down, then you notice the angle you just measured,
Okay.
and now you go for another star, and then you do the same, and then another star. And if you want to
Okay.
get a more accurate position, then you go another star. So you can go like from 2 to 4 stars.
More stars.
Yeah.
More resolution.
Yeah.
Okay.
Yeah, you can cancel more error, like you reduce noise, right? If you take more measurements.
Yeah. Yeah. Gotcha. More points of data.
Yeah. Okay. So now you're gonna convert those angles into distance. So, like, if the star is right overhead, then you are at the geographical position, right? That's what the geographical position is where the star is overhead. If you move away from the geographical position, the star is gonna drop in the sky. So that angle that the star is dropping relates to how far you are from the geographical position. So you can turn those angles into distances.
Geographical position is the point vertically above your head.
No, that's your zenith. Like the point vertically above,
Yeah.
that we call it
Zenith. Okay.
the zenith. Yeah. Geographical position is the opposite. You pick a
Z-axis.
star.
Yeah, okay. Z-axis would be zenith.
Yeah, that's the point overhead is
above
zenith.
you. Yeah, just take an axial like yeah. Okay. Okay.
Then
cool.
if you go to directly below the star, that's what we're calling the geographical position of the star. It's the point directly below the star.
Okay.
Okay. So the angle, like how
So
high
if I
the
was
star
to drop
is.
like a plumb bob from the star to the horizon.
Yeah, if you drop a plumb bob from the star,
Is that
the
it?
plumb bob is going to be hovering the GP, the geographical position.
Okay. Right on. Okay. Perfect. I understood that. Cool.
Okay. So that angle you just measured to the star tells you how far you are from that point. It tells you your distance to the geographical position of the star. That makes sense? So like if the star is 90 degrees above the horizon.
So that angle will tell me that.
Mhm.
Okay.
I think we have some latency on the voice channel.
Yeah, my signal is shit. Hold on. Let me. Okay. Angle between star and the horizon. The point on the horizon, that's a GP, correct? And that would correlate to the distance to the star, you said?
Correlates to the distance to the geographical position of the star. So if someone is below the star,
okay,
and you're not below the star, you're somewhere else, you can measure the angle between the horizon and the star, and you know how far you are from that person.
interesting. Okay. How? Just doing some SOHCAHTOA on it?
Oh no, basically no, you don't need actually to do SOHCAHTOA. That's where the so-called linear relationship comes into play. So each degree that the star is below your zenith, so let's say the star is 45 degrees in the sky, so you just multiply that by 60. That's how many nautical miles you are from that GP. You don't have to do any trig. It's a linear relationship.
Really? Oh, so that's okay. Oh, regardless of the star, any star, if it's this many degrees off the horizon, this many miles. What's the relationship again? What do I multiply by?
60. That tells you how many nautical miles. Or you don't multiply by anything. You just work with arc minutes. So how many arc minutes the star is?
Okay.
Yeah.
Away. Yeah.
Exactly.
Okay.
Just give me a minute. I have to help my dad here with something. I'll be right back.
Cool.
Yo, Syrus, you're still there? I'm back.
Yeah, man. I'm here.
Yeah, my father wanted to know how much to charge for a section of a 2x1 meters acrylic plate, given that the section was 56.5 per, let me see, 45.8 centimeters. So he was he didn't know how to do the math, so he asked for help.
Oh, okay. Nice. Is it what, cutting out acrylic plate for customers?
Yeah, he yeah, kind of.
Water jet, or what are you using?
No, I don't know.
Like
No, he doesn't have that kind of equipment.
intricate geometry? Oh, okay. Gotcha.
Yeah, that's not his main job. It's just like for his art, I think. He does some artistic job.
Nice.
Yeah, and he uses acrylic
Bro,
too.
like acrylic it's not cheap when it's like 1 inch or thicker, 25 millimeters or thicker. Yeah, it gets expensive pretty quick for a
It's not that
4 foot
thick.
by 8 foot sheet.
No, it's like it's probably like 3-4 millimeters thickness.
Okay, gotcha.
Yeah, so the point we were is that if like there's some, let's say there's someone right below a certain star. If you measure how high the star is in your sky, then you know how far you are from that person. Essentially, that's the idea.
Okay.
Right.
Well, so how? Okay, like how does that work though? So let's say I'm looking at that star and I got that GP, and what if the person, I'm in line with that person? What if the person starts walking towards me? Let's freeze time, right? Change his distance to me. Wouldn't he still be lined up with the GP of the star? Or am I totally off somehow?
No, I mean that person was just to try illustrate the point that is directly below the star. That person really doesn't do anything. It's just like
Yeah. You would never be able to see that person. Essentially, it's the point like on the horizon.
Oh, it's a point on Earth. Like it's not a point
On
you
Earth.
see. It's a point that is thousands of miles away from you. It's where you would have to be to see the star right overhead. That's usually thousands of miles away from you.
Okay. Gotcha.
Right. So
Understanding.
let's say you
Okay.
measured the angle to the star, and you worked out that you are 1,000 miles away from being directly below the star.
Cool.
Now, if you know where that point is, the point that is directly below the star, you just draw a circle around it on the Earth, and that circle has to be going through your position, right? Because that circle goes through every position that has the same distance that you have to that point, to that center point.
Okay.
So if you draw 1,000-mile radius circle around the position of the star on the ground, then that circle is going to go through you at some point.
Cool.
Okay. Now, so if you could see that circle on a map, then you know you're somewhere along that circumference, but not exactly where. So if you do that for a second star, then you get another circle. Now you know you're in both circles simultaneously. There are only 2 points where that can happen, right? It's where they intersect.
Okay.
So that's where you are.
At the intersection.
Exactly, the intersection of the circles, because you have to be on both circles at the same time.
And you have to have a map of Earth, obviously, when you're drawing these circles. So, because, like, let's say I don't know where I'm at. No.
Well,
I've
of
got
course,
no
like,
idea where I'm at.
you can get your latitude and longitude, but that's going to be meaningless, right? If you don't know where that is on a map. So yeah,
Right.
you're going to need a map to give meaning to your latitude and longitude. But you can get your latitude and longitude without a map.
Just based on the stars, essentially, right?
Exactly. They tell you, measure those angles. You have the time of the measurements. You can tell exactly what latitude and longitude you were, give it or take a couple miles. That's pretty valuable information. So if you miss, let's say you're trying to get to an island and you miss the island, you're gonna know that, okay, I missed it going, like, I missed it northwards, so I had to go back, let's say, southwestward, southeastwards. I don't know. It depends. Yeah, like,
yeah. Okay.
if you want to give meaning to that, you're gonna need a map. Yeah.
Right. Yeah, you have to. Absolutely. Yep. That's what I was thinking. I was like, all right, I'm drawing the circles now, but if I erase what I know about Earth, I'm screwed. I can't. I need to have a map.
Exactly. So, yeah, but like, if you can have, usually when, like, at least those races where people use celestial navigation, there are races where you cannot use GPS, right? You have a GPS, but it's sealed. It's just there for emergency. So you have to try to sail without the GPS. So they have to resort to celestial navigation. And usually the person who is, like, doing the sailing isn't the same as the person who is doing the navigation.
Right.
And so the person who's doing the navigation might get your latitude and longitude and not know where that is, because
how do you take that
process.
when the boat is moving? Like, how do you take that angular measurement accurately with the sextant? It's like, do you just approximate it, or like, what do you do?
That's a good
That's why
question.
I actually want to do it. That's how do you?
Yeah, the boat's like rocking.
What do they
right?
do? Right.
Okay, so here's the thing. The rocking of the boat, you can counter the rock of the boat with your body. So, for example, the boat is tilting back and forth by 5 degrees at a rate of, like, 2 seconds, for example.
Yeah, you counter a rock. I got you. You
exactly.
balance it out to keep it in
exactly. So you
steady.
keep your body kind of steady. So because the horizon is very far from your eye, then that's not really an issue. You can.
Bro, I'm just gonna I'm gonna grab a gyroscopic mount with me, bro. I'm just gonna put on a spinning gyro. There it is, done. Like, there is, or it's just gonna keep it steady, right? The boat rocks beneath it, but my sextant is absolutely dead steady, and I can just look now through it.
I think you're gonna have a harder time operating it like that.
We'll figure it out, but that should work. I mean,
yeah, like, I haven't sailed, but I've talked to people who did, and what they say is that it's pretty natural to counter the balance with your body. Like, if you're trying to aim at the horizon with the sextant, without even noticing, you're already going to start, like, countering the balance, like, naturally. That's
cool.
Yeah. So, and also there's the right time to do this. So, for example, if you do this in the middle of the day, there's no stars. If you do this on the middle of the night, there's no horizon, right? That's why there's something called the nautical twilight, right? It's called nautical because that's the perfect time for doing celestial navigation.
I see.
You start seeing the horizon.
Right. The sky and the sea are just blend into one, and like, no, in the middle of the night, like, your horizon is like, you just see stars, and then there's no stars here, and you approximate your horizon. Like,
the ocean gets as dark as the sky near the horizon, so it's pretty hard to see where the horizon is. But during twilight, you start seeing the stars, and the horizon isn't blended with the sky yet, so that's the perfect time.
Yeah, okay.
And if it's daylight, you see a very good horizon, but now you only have the sun and the moon, which are useful. You can do it with the sun and the moon. But if you don't have the moon, for example, then you only have the sun, so you only get a circle. So that doesn't help that much.
But let's say, It helps like basic trajectory, but not like pinpoint accuracy. Right?
Yeah.
Like in a general heading, it's like okay, cool.
Yeah, if you have only the sun, you can try to combine that with the bearing of the sun. But then in the middle of the day, you don't have a true north reference. You only have magnetic north reference. So you have to have good corrections for magnetic declination, that kind of stuff. So it gets harder
Right.
to work with just the sun. But during
Yeah.
nautical twilight,
Right.
then you can see a bunch of stars. You can see the horizon. You can take accurate measurements. That's like perfect time, perfect condition.
So what if I use the equatorial equidistant map and I do that? Would I be off too? Isn't it just a pretty much a flattened globe?
The AE?
Yeah, a
Yeah, you can like the best instance where I saw like circles being drawn there and intersecting not too far from where the observer actually was like 70 miles off. It's not
okay.
totally
AE is not
horrible.
good.
Yeah, but that was
70
the best. You can get thousands of miles of error in the A map. Like as I said before, you give me
Okay.
the map, I'll tell you where you're gonna have thousands of miles of error.
Okay, cool. Let me know what this if you find a good sinusoidal projection. Let me know what the error would be off of that one.
Oh, the error would vary a lot in any map.
In any map.
Yeah.
Even a globe?
No, that's not
Like-
a flat map.
No. Okay. Only when you skew. Gotcha.
As long as you're preserving the distances of the globe, you can. Then the circles are going to go through the right places.
Gotcha.
If you flatten it, then the circles are now going through different locations, so their intersections are going to move. And Earth is pretty big, so they move by thousands of miles easily. There is one flat Earth method that works, but that's confidential information for the moment.
Oh, okay. Is it just what's the difference? Is it the map or math or?
Yeah, there's some mathematical tricks, and it's a specific map. But I'm saving this for.
You're saving. Oh.
Yeah, no, don't worry. I'll drop it in the eventually. But for now, I'm
Cool.
saving for a specific goal, and then I'll share.
Sounds good. All right. Gotta share the map at least. Fine. I'll do my own.
Well, the map is already public. You just don't know which one it is.
Duh, there's a lot of maps.
Yeah. But the map alone doesn't solve it immediately. Like if you just pick any random map, you can try all maps. None of them are going to work if you just draw the circles around them without doing anything extra. So I found one map that with an extra step that is not that complicated, you can make it work.
Cool. Do some transform or something. So
yeah, something like that.
Something. Called the Bacon Magical Transform.
Yeah, I didn't give a name for it. Could be that.
It's a good name.
There is one flat Earth method that works, but that's confidential information for the moment.
Called the Bacon Magical Transform.
There's one flat Earth method that works, but that's confidential information for the moment. There is one flat Earth method that works, but that's confidential information for the moment.
Oh, okay. Is it just what's the difference? Is it the map or math or?
Yeah, there's some mathematical tricks, and it's a specific map. But I'm saving this for.
You're saving. Oh.
Yeah, no, don't worry. I'll drop it in the eventually. But for now, I'm
Cool.
saving for a specific goal, and then I'll
Okay.
share.
Sounds good. All right. Gotta share the map at least. Fine. I'll do my own.
Oh, the map is already public. You just don't know which one it is.
Duh, there's a lot of maps.
Yeah. But the map alone doesn't solve it immediately. Like if you just pick any random map, you can try all maps. None of them are gonna work if you just draw the circles around them without doing anything extra. So I found one map that with an extra step that is not that complicated, you can make it work.
Cool. Do some transform or something. So
yeah, something like that.
Something. Called the Bacon Magical Transform.
Yeah, I didn't give a name for it. Could be that.
It's a good name. Dude, I can't wait to try this. All right. Sounds exciting. Sounds simple enough where. So, what do I do with the time measurements that I jotted down, right? So I measure the star, right? The GP, yeah. And I write down what time that is.
With the time, you have to go to the tables on the almanac to figure out where the GP was. But those are simple tables. Like those are not like trig stuff.
What? I'm not afraid of tables. It's okay. It can't be worse than like it's just a table. Even the thermodynamic stuff, the steam tables and refrigerant stuff, whatever. Just look up the value.
Stars have two coordinates. One is called SHA, stands for sidereal hour angle. The other is declination. So those are pretty much the coordinates of the stars in the celestial sphere.
Okay.
Declination is how far the star is from the celestial equator, and the SHA is it's like the longitude of the star, but in the sky.
Yeah.
So declination and latitude translate 1-to-1. So whatever the declination of the star is, that's the same as the latitude of the GP. They are essentially synonymous. But the SHA, because the stars keep moving, then you have to figure out like how much rotated the celestial sphere is at this moment. And there's a table specifically for that. So the almanac lists what is the rotation of the celestial sphere for every hour, for every day, for the whole year.
Sidereal, right? The star year, star cycle.
Yeah.
The position of the star cycle. Yeah.
Okay. I'm getting a phone call. I'll be right back.
Cool.
Not much. Just taking a break. Tuned in and heard you and Bacon hashing something out. I was trying to make out what you guys were hashing out. I'm not sure.
He's telling me how to navigate using gravity, the gravitational field of the stars.
Using gravity? Really?
No, man.
I was getting ready to say that's a first. Can't wait to hear this one. Like, don't give him any ideas. That'll be the next thing.
I know, that's genius right there. They don't know about that. All you have to calculate is the difference between the gravity wells, the gravity well above you and the gravity well where you're going. And the force of the vector of the force of attraction between the two wells is your heading. Genius shit, I tell you. Einstein level.
They want top-notch physics, man.
That's as much physics as Einstein has, buddy. I think a bit more, actually.
No, you're not even close.
Yeah, dude.
Not even close.
Very close, dude.
Yeah,
right? Yeah. How much physics does Einstein have? What? E equals mc squared.
Yeah, you're on basic stuff.
What? I can't even hear you.
I say you're on basic stuff, my youth. You're on basic stuff. Einstein's physics origin is predicted. Is Einstein physics is GPS? That's it. GPS. Einstein fits the GPS,
Okay.
brother. Remember,
Wow.
brother, let me say this to you real quick.
Oh, radio. I didn't know that radio,
Radio,
man. That's
radio.
incredible.
Wow. Okay.
Radio.
We're-
Einstein invented radio.
radio. Einstein is radio. That's what you just said. Wow.
I mean, what's your GPS receiving? Better, I
Radio.
believe it's radio. If you
It's
think it's
receiving.
something else, hey man,
It's
let me
receiving
know what it is.
electromagnetic waves from relayed from somewhere. Right. Right.
Oh my goodness! At what frequency are these waves? We'll see which RF band they're in.
Right. So they're
They're
electromagnetic
RF.
waves
RF.
that originated from the ground up to satellites.
They're not photons?
In orbit, right?
That was photons.
No, electromagnetic waves.
Not
right?
photons?
Well, light is electromagnetic, correct? Come on now. Right?
I thought light was photons. What?
No, it's
Photons.
electromagnetic.
Light is photons. You can Google it.
Electromagnetic wave. Have you ever looked at how light propagates?
That's what people thought.
It propagates as waves.
Yeah, that's
right?
what people thought.
Right? No, that's not what people thought. That's what it is. I've seen it. You
And as a photon,
you need to,
doesn't it? Oh,
you need to see it. Well, photons is the fundamental particle of the electromagnetic spectrum, correct? Right. Everybody knows this.
So
brother.
the electromagnetic wave is emitting photons.
So electromagnetic waves are relayed from the ground to
Where's
the
Bacon
GPS
at?
satellite.
Bacon, hurry up and save me, Bacon. Let's get back to celestial navigation.
Then relays. No, celestial navigation. Yeah, it's the same thing. Yeah, they use electromagnetic waves. Right? That's what it is.
No, we're using a sextant and we're measuring angles to the horizon and stuff. No, we're not.
A 1925 instrument. Come on, brother.
Well, that's what Bacon was telling me to use. Blame Bacon, bro. How do you navigate in the middle of the sea with no GPS?
Yeah, Bacon is trying to make you take baby steps.
Yeah. Oh, okay, cool. So don't get lost in the baby steps. Why are you lost, bro?
The baby steps. Poor
lost
Bacon.
In the sauce
I
already.
warned Bacon about that. I warned him. I said, Bacon, you have to drop it hot, man.
About baby steps.
Yeah, you have to
we
drop
both
it hot.
agree there's parts in the ocean where you got no GPS signal. Your GPS doesn't work.
From the ground-based transmitter, it's transmitted to the GPS satellites in orbit. Those satellites relay the signals back to your phone, your Garmin, your TV, your all these kind of things. That's how the information travels. And these GPS satellites are located at a certain altitude, right? And at that altitude, their time.
Where is Bacon at? Hurry up, Bacon.
Their time differential is different from the ground, as predicted by Albert Einstein, right? Fact. Read it. Fact.
Right? Yeah, go ahead. Quote it from Einstein's work. Which paper?
Right.
Is this in the photoelectric effect, or which paper do I find this in?
Predicted.
Special relativity or general?
Listen to the word.
It has to be the photoelectric.
Because of where the satellites
I'll go read it and come back.
The satellite signals it was predicted that those signals would be delayed. Right? It's predicted. Einstein didn't create the satellites. It's just that general relativity tells you that when you position these objects at these altitudes, you're going to get that delay. Right? It's just predicted. He didn't have to make satellites. He didn't have to do that. His equations, as he thought about how light propagates and the electromagnetic spectrum, he said, this is what's happening with space and time. When energy and mass is within our world, right? Our universe.
It warps it. Yeah, it
Right.
warps space and time. How do you
Time.
measure warped space time now? I have a
That's right.
sextant and I have a star.
Right.
How do I measure the warped space time? And I'm trying to calculate the heading.
Okay, it's the
Walk me through this.
So,
Bacon was walking me through
here
this.
is something you didn't know.
Your turn.
Time is a fundamental physical quantity.
It's a
Did you know that?
fundamental, man.
Fundamental
Is it?
physical. Look, I want you.
Physical quantity, bro.
Yeah, physical. Are you close by Google?
Physical.
Are you
No,
close by
I'm
Google?
not. Physical
Okay,
quantity.
all right. So this is your homework. Time
My
is
homework.
a physical
Give me a jar of that
quantity.
shit.
Time
Oh,
is
okay.
a physical
Cool.
quantity. Do you know why it's a
Uh-huh.
physical quantity?
Yeah, you can say physical all you want. Physical means
Physical
what?
quantity because it's measurable, and it's measured in seconds. It's measured in seconds.
That's not.
So
That's not what
anything that
physical means.
can be measured, there is a possibility that it can be manipulated. You see that?
Go manipulate time and
Yes.
holler back, bro.
Right.
Yeah,
So
go manipulate it.
gravity manipulates time, speed, altitude. Time is manipulated. Yeah.
Man, what is this fucking storybook you're telling me? Come on, man. Just
It's
stop
all
reading.
no, brother. All of this
It's
stuff
boring,
is
dude.
basic physics. Basic,
Jeez,
very basic.
You haven't
Bacon-
worked out the math with me yet.
Yeah, Bacon
You gotta
can
walk
tell
me
you.
through the math.
Bacon can
No,
tell you.
Bacon. No, he can't. We were talking about real shit, angles and
Yeah,
stuff.
it's
You're talking
physics.
about Ben. All right, Bacon. I guess
Yeah,
he'll
yeah.
tell me
Or
when he
is
comes.
Bending.
We'll ask him.
everything.
We'll ask him.
So
All right, watch. He's gonna tap out of this
height,
shit too. Yeah, he's not gonna
height,
bring Einstein into this, bro. He's a lot
height,
smarter than that. Watch.
height, height.
I got 10 on it.
I guarantee Einstein is smarter than all of you. Height
Okay.
is a physical quantity. Length is a physical quantity. Depth is a physical quantity. Do you know why they are physical quantities? Because they are
This guy comes,
measurable
man.
and they have an SI unit of
He's
meters.
nuts.
Yeah.
Right.
It's not fantasy nonsense like ether and all this garbage. Nobody,
Why
they
are we
can't
talking-
make
Bro,
ether.
did you hear anybody say the word ether? Why
Yeah,
you
no, I
bringing
didn't.
ether?
No, I was just.
I said
just,
photons earlier, and you danced around it, but I can
was
give you
throwing that
paper
in.
after
I was
paper
throwing
that electromagnetic radiation is photonic
Yeah.
radiation.
Yes,
But
it's
anyway.
photons. It's photons. We all know that. Everybody
Oh,
knows
now
that.
it's photon. Okay.
Yeah, we know that. But it's it is called electromagnetic because of how the photons travel in a. How they travel? They travel in a what pattern? Wave.
Only when the path of the photon is not recorded. But once the path is recorded, they do not travel in a wave.
They travel in a wave from point A to point B.
No, some say it doesn't even travel. It just
What about
appears
the
from point
You
A
know,
to
like,
point B.
what about the UV catastrophe and Compton scattering? It can't be a wave because of those two things, right?
Scattering waves can be scattered. I'm not sure what we're talking about here.
Oh,
I don't think
Compton.
you know what he. I don't
It's
think you
called
know what he's talking
Compton
about.
scattering.
Yes, we know what that is, and it
And the
still is.
UV
Those
catastrophe.
electromagnetic pathways
That
are
means it can't be a
waves.
wave.
It's a wave. It's a wave. It travels in a wave-like pattern.
No. That's what people thought.
No, that's what people know.
No.
and
No.
and it
Once
is
you
not-
absolutely know, once you've recorded,
it is known.
right?
It's
Like a
recorded.
double slit with
Double
once you have detectors
Oh, no.
on the slit, and we know exactly which now it traveled in a fucking straight line. Only when the path is recorded. If the path is not recorded, okay, it appears to be a wave, but is it? But is
Boy,
it?
The fact
Oh
that
boy.
the double slit works
Let's go quantum
means it's
mechanics
wave.
and fuck
The
your
fact,
world up real
the fact
quick.
that the double slit experiment
You've
works,
opened this shit up.
that is
No.
that
Gravity.
is a fact. The double slit
Yeah, it's
experiment is
gravity.
telling you that it's a wave.
No, it's
And
not.
angle of incidence, these sort of things, wave, angle, right? See that? See that? See how that works?
The wave is it's called the probability distribution pattern
Right.
of the photons.
That's right.
But once you know exactly, right, you've recorded the path of the photon, it no longer has that wave distribution. Or does it? Right, by the delayed choice quantum eraser experiment. It is the knowledge of the path of the photon that collapses the wave function. So why are you saying it's a wave?
Oh yeah, same thing. It doesn't matter. It's the way as you just said, the wave function, right? So why are we applying the concept of wave function to the propagation of those photons? Why?
Because you do not know the path that it took. But if you do,
Oh, but
if it's a recorded path, then
irrelevant.
it did not take a wave distribution pattern. No, it took a
No,
straight line to the target.
it's irrelevant. It is
No, it is relevant. What do you mean it's
no, it's
irrelevant?
not,
Of
because
course
you're
it's
not
relevant.
you're not studying. We are not
No, it's
interested.
absolutely relevant. How does the coupled
Go ahead,
photon
brother.
know
Go ahead,
which way its sister
study
photon
your
is
life.
going? You're mad.
Go
You're
ahead,
mad,
brother.
man.
In other
Yes.
words, it doesn't
Breach,
matter what
breach.
you do. It's going to be equal to 339,000 meters per second, right? That's it. Doesn't matter what
No,
you
that's not
do.
what we're talking about.
So
No,
if you,
that's the speed
I
of
am just
light
saying,
is a function.
just
You know what? If
saying.
it's what's the equation of speed of light, bro? Do you even know it? Look it up. Why don't
Of
you just look
course.
it up? What is it?
Hold on.
What's
Why
epsilon?
are you?
What does
This is
epsilon
called.
equal?
This is
No,
this
man,
is
tell me.
called this is called concept stacking. I mean, why are you doing that? Because you
No,
don't
it's
want to.
not.
No,
No,
hold
it's
on, hold on, hold on.
like what?
This is because. Is it
Are you
because
gonna
you don't like
find an
you?
equation to square
Is
root of
it because
epsilon?
you don't like
No, we're
to
getting to the nitty gritty
debate?
here.
So every time we mention
This is
something,
not a debate,
every
bro.
time we mention, oh, it's a debate.
Scattergunning is
Trust
not a
me.
debate, dude.
Oh, no, brother, it's a
No,
debate. It's a debate. You
this
didn't
is
know.
not a debate.
You didn't
This is a
know.
debate.
You didn't
Oh, I
know that
didn't.
Einstein's
Don't sound like one,
equations predicted how GPS signals connect.
bro.
You
It
didn't
sounds like a
know that.
rap festival over here. I don't know what
Yeah,
you're
you
talking
did.
about.
Yeah, you didn't
This
know
ain't no
that.
debate.
So welcome. Why didn't you know
Oh
that?
yeah, sounds good.
You know why you didn't know? Because the flat Earth
What?
ideology
Hmm.
wants you to reject all mainstream science.
Okay.
That is the mission. What's his name played the
You
video
want to keep
earlier.
straw manning? So
Yeah,
yeah,
yeah.
this is why we're not talking
So
about the original point, right?
this is the
Because
foundation
you
of
tell
flat Earth.
stories a lot.
This is like that, you know. But I have a question for you though. Um, Whenever something is on the mainstream TV, do you believe it?
I can go out and verify it instead of believing it
Just say
because
no.
mommy told me to believe.
If you don't watch
Absolutely
TV,
not, sir. Fuck no.
Exactly.
Fuck no. One, I don't watch TV. Incorrect. If it's on TV, I need to go verify it. Someone told me. Why would I believe them? Because they own the fucking TV. They own the station. Like, what the fuck? They can peddle
Yeah,
me whatever
brother.
the fuck they want. I'm
Okay.
good, man. Thank you.
I know.
Of course not.
But here's the thing. This is what you don't know
Yes.
is that
It's my right as a man.
this is something you don't.
Like, yeah.
Whenever it hits mainstream, my friend, the whole entire verification apparatus is already in place. So
Good for you, man. But bad for me. No, I don't want to understand.
I have seen it. I've seen it work. Things don't just go mainstream. They have their own investigative reporting. They have their own investigative science experts that
who does?
spend
Wow.
hours, days, months
CNN.
in the
Who's that?
field with the people who are going to put the
I'm gonna
information
straw
out.
man his ass because he said
People who
CNN
are
earlier.
going to put the information out had to get consensus, peer reviewed, right?
Really?
So it goes, brother. It goes through.
The news anchors tell you
Goes
peer reviewed
through.
shit?
It goes through an entire ringer before it hits mainstream.
Wow.
Right.
Wow, amazing. I'm
Unlike
not part of
flat
that.
Earth. This is how flat Earth works. Hey, reject gravity. Okay, gravity sucks. It's just a theory. Yes. You guys are. That's how flat work. That's how flat Earth works. You get it? That's not science.
No, man.
Pseudo.
No,
That's
I just
garbage.
don't. I don't get you, bro. You, I cannot understand.
No.
I
It's
don't know
just
who you're talking to half the time.
It's just pseudo. That's how. Listen. YouTube. A guy, some obscure nobody comes on YouTube and say, "Hey, I have a video that show you the ISS guy. He's not really on the ISS." And you are going to be. You first of all, you're going to go, "Is this on the TV? No. Is this on the radio? No. I believe it
On YouTube. Because it's on YouTube?
I believe it. I accept it.
Why?
I accept it. I'm going to come
Isn't
to
that
Germany.
TV too?
Jeremy, check this
Bro,
video out on
comes at me.
YouTube.
It's from a
ISS
screen, bro. It's the same
Jeremy
shit.
goes,
Big
"Oh yeah,
TV,
man.
small TV, medium TV, isn't it? Just all TV. The screen? Display screen.
Dead giveaway. You know you're in a cult when you only believe
Okay.
very small pieces.
I
of
have to
information.
believe Call of Duty is real because it's on fucking TV. Okay. Cool. Sounds good to me, man.
That's how they
What the fuck?
teach. They're teaching kids this. They're teaching kids this.
Bro,
How
whatever,
to
man.
recognize a cult when
Somebody
the
save me.
information is not verified.
I'm just trying to keep the chat alive.
It's not peer reviewed.
I think I've
It's
done my
not
You
part
don't-
this morning.
Yeah,
I've
That
tolerated
is
this
a cult.
without exploding. Like this is, I'm improving. That's incredible.
what do you want people to call you? PAC or what does PAC stand for something? Because it's capitalized. That's why I'm asking. Your name, PAC. What's that
Oh,
mean?
He's got like 20 different accounts. He has like 20. He has like 20 different accounts, but generally people call him Robert. That was one of his first names.
Oh, okay. Robert, do you think it's possible that?
Yes.
I mean, I know you were saying that cult and projection, or no, I don't even think you said that. I just think you said cult and indoctrinated. Do you think it's possible that maybe you believe a lot of things just because you were told without verifying?
No, that's not true, because I've been through the education system and I've done experiments. I've done research. So that's how I know that is the reason why I stand by it. Because the results are as predicted. Right? It's like when I did the Cavendish experiment. The results are as predicted. Right? And so therefore, whenever you go through these processes, then you understand what people are saying. People are not trying to pull your leg. I'm not. You're not. I'm not in some back room dreaming up or cooking up. I think I'm not doing that, dude. I'm actually following scientific methodologies,
Right.
proven, tested. I have
I
the
remember
results.
that. I remember asking you when you brought up Cavendish. I just asked you what you varied in your experiment. That's it. And you told me go back to school. I remember your answer actually.
Yeah. You
Decent
have
memory
to,
today.
brother.
Enough caffeine in the system.
The joy, and the elated feeling that you get when you see things happening that
Okay,
is
I
just
see the
unusual.
balls
Like for
jiggling
example,
on the desk. What do I vary now to do an experiment? I'm with you, man. I understand the joy.
like
Just
for
walk
example,
me through it.
the Cavendish experiment is spectacular, right? Because here you have calibrated the apparatus. You have an oscillation rate, and you have to enter that into your calculation. You watch that over a very long period of time. So the ball that's on the torsion rod is oscillating within a, let's say, a 1.5 centimeter range, and it oscillates in that range in that room for a day. So you have to enter that in your calculation. Then you come in
Okay.
and you introduce the independent variable of the mass, right? And you see that oscillation change.
Of the math.
Right. So you
Of the
have
what? Hold on.
so you have
Mathematics.
you have two mass. You have two types of masses. Yet what they're same weight.
Oh, mass. My bad.
They are. We did it with lead and we did it with steel. All right. So when you introduce, for example, the lead ball, the oscillation went beyond the 1.5 range, and they moved towards that independent variable, which is the mass that you introduce. And you watch that over time. Because the reason why you watch that over time is because you want to make sure that when you came into the room, you didn't stir up any air, right? right. So you watch that over time, and then you'll see that it is a constant in which the ball and the torsion rod goes towards the independent mass that you introduce. And it is spectacular to watch. It's, you know what I'm saying? They bounces off of it, come off, and then it goes back to it and stays. Perfect. Right? And we did it with lead, we did it with steel.
So, okay, I'm following. So you have varied the mass. I'm building an Excel sheet here. So input different masses equals different oscillation rate, correct? Am I getting this right? Okay. What do I do with the oscillation rate now? So I've deduced that different masses give me different rates of oscillation. Now, next step. That's what I've proven now by doing this experiment correctly. If this works out, as you're saying, walk me through that. What do I do next? Got an oscillation greater than 1.5, like you said.
Remember, the control variable is the mass on the torsion rod. That's your control, because those two masses at the opposite ends of the torsion rod is what zeroes the downward gravitational influence,
While
because
you
it's
guys
balanced,
are
right?
while you guys are stepping through this, is it okay if I ask a question about this?
Sure, go ahead.
Because did you introduce different types of mass?
Yeah, we only did it with steel and lead, and other people
Okay.
wanted to do other materials, but we never had that. So the lead balls, we had to handle it with gloves and all these kind of things.
All right, that was my inquiry that I'm making little mental notes of. I'll digress now. I just want to have that one question. Y'all can continue.
Right. So I mean, nothing else in the room is causing those objects to come together, because you watch it over time, right? You see the
But would you
change,
agree?
right? And
Would you agree that
vacuum.
some mass? Would you agree that some mass, when it's near other mass, which what is mass? Resistance to acceleration. And so what you're saying that resistance to acceleration attracts resistance to acceleration. But anyway, aside from that, if you introduce different types of mass, they'll behave differently.
Yes, the attraction rate would be different. No, the
Well, some would repel. So it depends on what you put.
attraction
It
rate.
depends on what you introduce. Some will repel. Some mass will repel.
Yeah, the
Depends on what it
rate
is.
of attraction is is inversely proportional to the mass, the two masses, right? So when you do that mathematics, you will always have that gravitational constant. But you will have, if you introduce different types of mass, it would either move at a faster pace towards the independent mass or not, right? You will see these
Well,
things, and sometimes you get null results.
okay. Well, you're saying that you've got to include the gravitational constant, but then you're saying this is also supposed to, like in the mathematics, right? And you're saying that this is also supposed to prove gravity. So gravity's supposed to be the thing that you're varying, It's not really the thing you're varying. You're varying the mass, but if you put different masses in, some mass will repel. Wouldn't it be easy? Wouldn't it be more logical to conclude that the thing that you're varying is polar interchange between different types of masses? Like, wouldn't polarity be the key factor here? Because that's kind of like the polar interchange is what you're varying, not so much a gravity. You're not varying gravity because you've not isolated gravity. You've not identified the cause of gravity. All you're doing is you're seeing effects and you're trying to do an ad hoc test so that you can put your ad hoc explanation on it to point towards a cause of gravity. It's not really a cause of gravity. Because if you can introduce other mass and it behaves differently, the thing that's different that you can identify and you can actually manipulate that will cause these things to happen in real life, in reality, is polar interchange. Polarity.
No,
So how are you?
it's supposed to act differently if you introduce heavier or denser mass. It will. Now, if the mass are the same weight, same density, right? Different material. So the lead ball weighed the exact same as the steel ones. It weighed the exact same. And the rate of attraction was the same. That goes to show you that even the density of the mass, the material of the mass, right, is really the same, right? So gravity acts on that dense mass the same way. Doesn't matter if it's a steel or lead. That's the point I'm trying to make.
Right. Well, I think
But
he's putting like all
but
this information into an Excel sheet. He's going to like work it out and see, like I guess what your
I mean,
test. I'm not going to call it
I
an
just
experiment.
I got different masses give you different rate of oscillation, and then I still don't have a gravitational constant here. I think I have to do something else to get that. And he's not walking me through it, so, and I'm not sure how I know about it. I just saying through the grapevine. Someone told me I have to do something with it.
Did you hear what he said back? Or Robert?
you know what I'm okay. Do you know?
He's filling out his Excel sheet. He's got the two different masses. He's trying to figure out like where the gravitational constant comes in.
And he said
Okay,
sometimes you get a null
so do
result.
you so
I
do
need
you
to know,
know
what do I do with a null result?
do you know hold on, let's not get there for a second.
Okay,
But do you know the
back up.
formula? You know the formula, right? The force of gravity formula. Do you know it?
Force of gravity formula. Well, it doesn't have G yet. How do we know it?
Well,
That's not what Newton
it,
said. Newton said it's proportional. He never put an equal sign there. He said it's proportional to the m1, m2 divided by the distance between them. Now, there's no big G there in Newton's
yeah,
stuff.
there's a big G
We're
there.
talking about big G right here. Hey, well, no, because big G isn't going to come out of this either. So we're going to have to figure out where this shit comes from. Got to get your math straight. So we're trying to straighten out your math here. So you walk me through it. Different masses, different rate of oscillation. Okay, I'm with you. What do I do with that? Sounds good. Here's my apparatus. I've proved to myself. Different masses give me absolutely different oscillations. Sometimes
Right,
null result. I'll just cancel that. Okay,
right.
fine.
Remember,
Null result. Whatever.
the
Neglect
distance.
that shit.
Remember the distance between them. That is why you bring in the oscillation, right? That oscillation rate. So the distance between the two mass changes because of the background interference inside of your laboratory, right? So again, if it's oscillating within a 1 centimeter range, that 1 centimeter added on to the additional distance when you introduce the independent variable. You see that is how you now have the m1 times m2 divided by that distance, that difference, right? Now G that gravitational rate is in that formula, I equals to F. So if you
No, it's not.
transpose,
Not
so
yet.
so when you
Not in this
transpose
part
that
of history.
equation, when you
We're,
transpose
we're
that,
in. We're doing Cavendish, right?
right, we're doing Kevin.
Okay, so no, there's no big G here. I don't know where you got big G from.
No. There's
It's
no.
not Cavendish that works it
Well,
out.
well, well,
But
well,
anyways,
the Cavendish experiment it proves big G.
it proves big G. How so? His paper. The title of his paper was trying to figure out the density of the Earth. Essentially, he was trying to weigh the Earth. Right? We know the volume because of the sphere, and he was trying to get the density of the Earth, so he can multiply the two and figure out the weight of the Earth. So it's like, okay, so now big G, just enlighten me. I got oscillation rate, I got delta mass, delta oscillation, and my Excel sheets. Now what? What do I do with that? I got M1, M2. I got my
Okay,
radius. I don't have
you got
big
it.
G anywhere here. There's no big G. Where do we get that
You're
from?
good.
Doesn't
You have
exist
everything.
yet in time.
No, you have
Now
it
what?
all there. You have it. You
Yeah,
have
but
it.
now
You have
what?
it
I'm
all.
supposed to solve. I'm supposed to solve for big G.
Yes, you solve for big G. Yes, sir.
Well, it doesn't even exist in the equations. Like, why are you making it up?
No. There has to be a strength of the gravity,
Strength.
right? It's a strength.
The force. The strength or the force? I'm fucked up here on your terminology. Strength of gravity. So that's it. In what unit do we measure the strength of gravity? Is that delta what?
So well, it's the same. It's the
Muscle
same.
fiber force? What the fuck is
It's the rate. It's a constant. It's a constant. That strength
a
is a
constant?
constant. It's a 6.6 times 10 to the minus whatever 11
Yeah,
meters
we're trying to
per
get it right now.
meters per second per whatever. I think meters per second. I have to remember the units. But that's irrelevant.
It's irrelevant.
Yeah, but that's irrelevant.
Well,
I
if
mean,
you
the
don't
unit.
put that G in there, if you don't put that so-called constant, which is any constant in math is a correction factor. If you don't install that correction factor in your formula, your answer is off.
What
So it's
correction
like,
factor?
what's up with big G that we don't have yet? We're talking about Cavendish. There's no big G in Cavendish. What? Who's talking? Sorry, Truth. I wasn't trying to take over the conversation. Right back to you.
Oh, this is your conversation. You were having it
Fuck
with
no.
him before
I
I
don't
came
like
in. Well, you were having it with Bacon
Oh.
actually, but he's on a phone call with his girl, so he'll be back soon.
Oh, he's on it. I'll talk to him, girl.
You're trying to save me. That's the idea.
Yeah. It's again, it's something that will have to be demonstrated, right? So
Well,
this is why this is why I said to you. This is why I said to you, school.
Did you hear the last thing he said? He's like, we don't have big G.
Yes,
So
well, you don't have big G. You're going to solve for big G. You're going to measure big G from that formula, right? You're going to calculate solve for big G from that formula.
Why did you insert it in the formula? Why are we solving for it? I thought he was trying to weigh the Earth. It's not what the title of his paper says. The fuck is this?
No, the title of his paper.
Do you know who solved Big G?
No, he. Well,
you think it's Cavendish? These guys like you. It's not Cavendish.
Oh no.
But anyways, I'll pretend that it's Cavendish, and I'll play Isaac. Fuck you. It's not. It was not Isaac Newton.
Isaac Newton solved. He used in his equations found big G.
Ass.
Right. That's what he did. There's a strength of the gravitational attraction.
Okay. Good one. It was the rate.
How did Cavendish
the strength? And again, what strength and what unit? What unit? It's a constant doesn't have a unit, so it's like okay, number. It's a correction factor. So, in what unit is this strength of gravity you're talking about? Like, give me a unit. Do we have to mankind make up a unit? You know what a joule is? Like, that's, you know, a unit of thermal change, like energy. Like, so give me a unit for the strength of gravity shit you talk about. Gravitons and delta gravitons or what? The proper answer would be the delta curvature rate of space-time.
Delta.
Right? If it has a deep
that's
curvature in
Einstein's tensor
space-time,
equation. It's okay.
mass is strong.
Correct.
Or gravity strong, whichever one.
Correct. Gravity, strength of the gravity of gravity. Yes, that's what the gravitational constant is.
Man, I'm giving you free
9.81
today.
meters per
I'm
second.
feeling generous with science.
9.81 meters per second squared.
Is that what Einstein said? I thought we were doing Einstein stuff. But anyways, back to the 9.81. That's the acceleration of an object when you drop it. So
It's the unit.
that's not the
It's the
strength
unit
of gravity. That's called the
It's the unit.
gravitational acceleration rate.
Gravity is a
Yeah, but it's in meters per second. Meters per
Gravity is
second
an
squared,
accelerator.
which means per meters per second per second.
Yeah, I understand, but gravity is an accelerator. That's what it is. It acts as an accelerator.
So
just
gravity
like
can do work.
just like
F.
your
So if
yeah,
F equals ma, interesting.
yeah.
So if I have a mass and it starts accelerating, that means there's a force that pulled it. So work has been done. Correct?
It looks like work.
It looks like work. Yeah. Okay. So since work has been done, energy has been spent. Joules got spent. Now, what is upkeeping this gravitational force? It does work around stuff, satellites and shit all the time. Where's the energy coming from? I'm just trying to balance shit out.
What
If it's doing work, energy is being spent.
You know that
where did the energy? Is it burning up nuclear stuff in the center? Or
do you know
something?
Oh, that's okay. Different concept. Different concept. All we're trying to show and demonstrate is that attraction rate between mass, or that apparent. It's apparent, right? You see, what Einstein is telling you, it looks like an attraction rate. It's not really is. It behaves like one, but it not really is. So that's all we're trying to do is calculate that attraction rate, right?
So Einstein calculated big G. Shit. Okay.
Oh,
I didn't know this.
Yeah, he did.
So what did he? Yeah. What did he say? Yeah. What does it equal?
It's a constant.
I didn't see it in his equation, in the field equation. You want to point it out to me?
What? You didn't see
in the Einstein field equation? Yeah. Show me the gravity.
Gravitational constant is in there. Yes, sir.
Oh, okay. You're talking F equals big G, right? That's not Einstein. It's Newton. Or not Newton either. Somebody else.
I told Bacon, I said, look, man, I said, now's not the time for making babies. We're trying to win a Nobel Prize here for proving gravity. Got to get back to the combo.
Yeah, I mean, it's in there. Yeah, let's look it up. Look it up. It's in there. Einstein derived it himself. He basically started from scratch, and he ended up pretty much where Isaac Newton was. But it doesn't look like it's a quantum issue. That's what Einstein is saying. It doesn't look like a quantum, meaning there's not a particle inside mass that is doing this, because he is seeing, because of his mass, he's seeing variation in space and time. Right? He's seeing variation. there. So that's why he combines space and time into one value, and that's in his equations, as you will see as you break them down. And he was spot on because he predicted things. Electromagnetism is also a theory. Just want you to know that.
I was really hoping he would finish it out. And then maybe he would, maybe that's what happened. Maybe he saw where the issues were and it made him a little uncomfortable and he had to hop out and figure it out. I don't know. I highly doubt that, but we can hope,
Yeah,
I
okay.
guess.
It's going to take a lot longer than that. It's pretty long to solve that shit. There's no masses in there, but surprise, haha. He hasn't heard of the solutions. Like De Sitter, a Dutch guy, called De Sitter's universe, empty universe. Look it up. There's no masses in the universe. Due to Einstein's field equation.
How you spell it?
De Sitter, D-I, I don't know, Sitter. Absolutely not. But Google will correct you. De Sitter's empty universe. Once you go empty universe,
Okay.
Google will know who you're talking about. Dutch fellow. Wikipedia page, I'm pretty sure. It's like, just look up. How many masses do you see? More than one? Great. This shit don't work. It's a viable solution. And do you know where black holes come from, Truth? Like legit. Like
Well,
bullshit.
it didn't correct it properly. It corrected it as disasters in the universe, which brought
No,
up some
no.
interesting stuff.
Maybe D apostrophe Sitter. I don't know. I don't know how to spell his name. It's a Dutch guy.
D Sitter. It's Willem, Willem DE, middle name, and Sitter, last name, Sitter.
Okay. Nice.
I've
Read
never
about his
heard of
empty
him.
universe. Yeah, well, this is where Einstein, you start going to the legitimate solutions of Einstein field equations. Learn about Mr. De Sitter, learn about Mr. Hilbert, Hilbert's error. I think from MIT or some mainstream, university, where it's called Hilbert's error. He made a mistake in the math, and this is where we get black holes. Okay, and the mainstream knows about it. But there's pages on this shit. So from the Hilbert solution, which is the Schwarzschild solution, we call it, ripped off from Hilbert, and there's a mistake in there. And it gives you black holes as a solution.
Okay, but that wouldn't explain observations of black holes that we've made.
Observations of a mathematical error.
Observations of black holes.
Okay, of a mathematical error. Sounds good to me. That's the
Syrus.
shore I stand upon.
Syrus,
You stand on the other in the water. I don't care.
Syrus, you are aware that we can measure light, radio waves, gravitational waves.
I'm gonna tap out with the gravitational waves. Tapping out here. It's above my pay grade. I'm just gonna listen to Mr. De Sitter, and I'll listen to Hilbert, or what MIT says about his solution. So I'm good. I'm firmly standing on on the shore I stand upon. There's no way you can move me from here. Set in stone. You can pull up
Okay.
these articles yourself, read into it.
So you want
I'm
to
good.
be ignorant, is what you're.
No, I think you're ignorant of what I'm saying. Have you read this shit? Do you know about Hilbert's error? Do you know about the Schwarzschild solution? Do you know about de Sitter's empty universe, a viable solution to the Einstein field equation, which has zero fucking mass? Look on Earth. Oh no, it's not one mass. Fuck you. Look up. Oh, there's stars. Fuck you. So it's like no, but that's a viable solution. De Sitter's empty universe. Just Google it, read it, boom. You'll get a full picture. It's not the only solution, right? I'm giving you other
what
solutions.
I'm trying to say is that black holes still exist.
Cool. From a Big Bang universe, this black hole. Nope, you can't do that in an Einstein field equation. You have to identify which kind of black hole are you talking about? We're gonna get into Schwarzschild now for real. Which type? There's 3 types at least.
Which are what?
Rotating, non-rotating. I think there's charged rotating, and there's charged non-rotating might be 4. You can look it up yourself. And that solution is non-compatible with the black hole. The Big Bang. They're not coherent. You can't. That's one way you get black hole. To get Big Bang is another way. You're gonna have to show me how you work it out in the same math, because you have to identify which black hole universe. I believe from the K constant, you have to either define it. It's a charge plus 1, 0, or negative 1.
I didn't say our universe was a black hole. I said black holes exist.
Which type? Because they are a mathematical solution to the Einstein field. Schwarzschild solution, and there's different types.
Syrus, you can, we've seen them, like X-ray telescopes. The image I sent in the chat is from.
I'm aware, man. I am aware of the orange fucking circle. I am not. Sorry, bro. It's from a source I cannot trust. Look, we're not gonna go down that road. I told you. Where I stand, I'm pretty firm. I am not ignorant of all the fucking radio telescopes that they picture this with. Whatever. I'm neglecting the source. Source I do not trust.
So you're ignorant. What you are giving me is the definition of ignorance. You know
Whatever,
it
bro.
exists, but you are ignoring it. That is the definition of ignorant.
No, I don't know if it's legit or not. I'm standing neutral on that information. I'll go with the mathematical solutions until I can verify that this is absolutely legit.
Would these be the same mathematical solutions from the same people that say Earth is round, or?
No, so these are the consequences. So if we did actually observe it with our instrument, right, here's a picture of the black hole, then it's not a Big Bang universe, right? Automatically cancels all that out of physics, and nobody really pays attention to it. It's like,
yeah, I personally don't believe it's a Big Bang universe either.
Okay, cool. Okay, that would go fine with what you believe, then. It would work for you. That's fine. But this is, they use it, like, they coexist in the same universe when these guys use it, and it just makes no sense from the mathematics. So it's like, all right. So if they stick to, okay, there's no Big Bang, we have observed a black hole, Big Bang is just full of shit. Cool, okay, maybe I'll believe them. I'll start to.
Well, yeah, no, that's what it's starting to seem like with James Webb. It's starting to seem like that there isn't any start, quote unquote, to the universe.
So we'll see what else they find out. Do you know what the escape velocity of a black hole is?
Speed of light.
Okay. So how come light cannot escape it? Why is it black? Because the light cannot escape it. But what's the escape velocity? Speed of light.
Well, more than speed of light, I should say.
Yeah. Right. You're correct. You'd have to increase, but yeah. So, but what they say is the speed of light, which is like, wait, hold on, it's black because it absorbs all the light. Okay, it's not fast enough to escape it. I'm confused here myself until I get further clarification. Maybe you know. I don't know.
Well, here's the thing. Take Earth as an example. Earth's escape velocity is approximately 11.7 meters per second. But if you go exactly 11.7 meters per second, you will still be dragged back. So you have to exceed, or not meters, kilometers per second, sorry. Or is it meters? Dude, I'm American, so I don't know the metric system.
It's all good, man. I understand where you're going. Like, light needs more energy to escape it. Where's it getting it from and shit like that? Like, it's greater than the speed of light to escape it now. That's why it looms around it forever and creates a ring, supposedly.
Well,
but then it's like, okay, why is it black in the center?
Well, that ring is material that's falling into it.
No, that enters the material is too dense. We're talking just about photons. And they say how these photons hover around the ring, around the black hole. But now I don't understand, because they escape velocity, right? So they have escaped the black hole. But they're in that Goldilocks where the gravitational pull and whatever their speed, which is the speed of light, of course, in that ring right there, they can just hover around forever, supposedly. The photons at semi speed.
If you haven't hit the event horizon, then you can still, like, the event horizon is the point where
Right. You can escape. Right.
Right, and then past that. Also, I was wrong. It's 11.186 kilometers per second.
Yeah, that would get absorbed right into the black hole. That space shuttle.
Right.
Like any material object has no chance.
Yeah, well, unless we get.
So we went to photons and they hover in rings.
Hmm.
Well, like I said, this argument is older than that. This is Mr. Schwarzschild.
Well, that's actually his name is very much tied to black holes. The Schwarzschild radius, I forget what it is. I think it's the radius of the event horizon. So how big the black hole is. Sorry, my mouth hurts right now because my wisdom teeth are coming in, and yeah.
You're good. Well, at least you ditched the Big Bang universe. That's pretty good. So what caused Earth to spin?
Yeah. The
if I can see to okay,
the formation of the Earth, like the way it would come together.
But it wasn't this molten thing that exploded out, because we've ditched that now, because we've established black holes are real. This is the legitimate solution. It was not a mistake after all. So
well, that doesn't discredit the idea of how stars and the solar system would have formed. Right.
Well, stars are they have their own problems though. Stars are a little different, because stars essentially create a perpetual motion machine of the first type and second type, right? Because you have the gas expanding outwards, and then it's due to the mass of the gas, somehow it's going to become a lump and form a star. So this gravitational collapse, like, work has been done here, and this is where things start to become problematic thermodynamically, where it's like, okay, this is a perpetual motion machine now, because it was expanding, but now contracted and started like spinning around itself and shit. So it's like, it's interesting, but it kind of makes no sense. But this is why we're going to ditch that. We have to ditch that with black holes now. We just neglect all that garbage. It's not real.
Well, okay. The formation of the solar system can still be, because that didn't happen even in the Big Bang model. That didn't happen until ages after.
Yeah, so the ability to do work in the system would get reduced over time. It would not increase. It would decrease. So as the gases of the stars that collapse, it's increasing in distance from molecule to molecule over time. So the decrease now, see gravitational collapse. Gravity is going to do work on the molecules to bring them together. Here we go, perpetual motion machine, first type and the second type. Okay. Which first type violates the conservation of energy, and the second type entropy. So, and this is what's going on here. The ability to do work has increased now, all of a sudden. Just like this is where it's like, no. I am not a subscriber. I'll subscribe to thermodynamics, not this star formation stuff. I'm cool.
I just want to get something straight. You are a flat earther?
Indeed, sir. Yes.
Okay.
I'm cool with gravity, 9.81 gravitational acceleration. Depends on the conversation, right? Like, what are we talking about? So like that. And I like cosmology the most. Like what we're talking about here. This has interested me way before I was a flat earther. I was an anti-Einsteiner way before Electric Universe, right? From a young age. So I was already like seeing the flaws in the mathematics, let's just say. And these guys in the mainstream are holding on to it like it's religion. And I'm not saying that Electric Universe guys are right either, but they at least prove the mathematics to be incorrect, or parts of it. So it's like, okay, that's very interesting. And there's resistance right between them. So I was just open-minded to different cosmology, which interests me more than the topology of Earth. Like I'm interested in that too, but cosmology is pretty awesome.
Yeah, but I mean, the thing that gets me about flat earthers, and it's not you, but it's a lot of people. There are some in the server, some not, is ignorance of other things.
Like we can discuss.
Like going to space, going.
Fuck NASA shit. See, that is the establishment that I do not trust, man. It's like fuck, not
Okay,
NASA
and
or JAXA.
I mean, it would be a really big conspiracy considering there's what 70 space agencies.
Yeah. Not everybody has to know. Like, there's a lot of things that they're doing that really they're just doing their job. But I don't know. I'll just try to verify the data I was given, sort of thing. And since the moon landing footage and all that from way back when, the trust is just at zero.
You brought up other space agencies. Have you seen China's first moon landing? Their first one?
Oh yeah.
Like, do you think that's real? It's like an Atari video game. Actually, Atari looked better. But
Okay.
I digress.
Are we just? I don't like having to explain to people what an animation based on telemetry data is.
Animation. Okay. Well, I think when they first presented it, they were trying to present it as live feed, and I don't know if they were saying it was animation after that or what. But
No, it's
like,
it's
I wasn't wanting to.
animation.
I was
It's
just wondering if you
animation
saw it.
on. No, I've seen it. It's animation on the official live stream of the landing. It's not claimed to be
Okay. Gotcha.
real footage.
I wasn't trying to
Same thing.
obfuscate your all's convo.
No, you're
No,
good.
same thing with the Indian agency, with their Indian moon landing. It was also an animation of the telemetry.
Well, yeah,
So
I mean,
this is where
putting-
distrust. I have a feed. I have a live feed spitting out telemetry data. I can map it out, on something that I can what you call it, render, some graphics and display that data accurately. But that live feed now, the verification of that shit. This is where it's like, all right, I just have to take their word for it. There's no actual way for me to go and verify that somehow.
Actually, there
One,
is.
it's above my pay
You
grade
can,
for me. Oh, you can? Okay.
Yeah, you can.
The ones they give you.
No, if you have a powerful enough telescope and you know where it is based on
Okay.
that. Like,
That
you
would
can
be cool.
verify yourself that it is there.
That would be like if you did that, like I'll take your data over theirs, dude, for sure.
I mean, that's something that was done during the Apollo program. People with ham radios tracked the missions on their way.
Yeah. But the footage was taken in the studio here, so it's okay.
Yeah, I don't think that it was, honestly.
I never hear people talk about Pangea originating in flat Earth idea and why it would have originated on a ball idea, but I've never heard people talk about it on a flat Earth idea, because if it originated from a certain point, in one way, that certain point might be the center. Any ideas? If you don't mind talking about it.
What was that? I'm sorry, I didn't hear it. I can back up the live stream and catch it. Dr. Green, though. I don't know. Are you Realm? Did you used to be? Hold on, let me see. Yeah, you are Realm. I thought you sounded familiar.
Howdy,
But-
mate. Howdy. Yeah, it's me. Yeah, I just fancy the change.
I hear you.
Yeah.
Oh, what was it you said?
I
Don't
was
mind.
talking about Pangea. The idea that everything started off together is one way of saying it. I never hear it being mentioned in like a flat Earth conversations, because if that was the idea that they all started off at one area and split away from, let's say, a center point, let's say, where would that center point be?
Okay, so I've heard it over the years. I've heard it come up a few times, and I think that the issue with that is like no one knows where the story of, say, Pangea come from, and that all of them, all the continent, or I don't anyway. And the few people that I've talked to, they didn't claim to know where it came from, and I've not really done a lot of research on it. But the problem with that is, though, is it reifies another heliocentric claim that they have, that we have like this mantle or crust that is moving, and there's like, if someone were to measure, like, say, the shores of one continent and the shores of another continent, actually getting further apart, then there would be some evidence for it, right? That, well, if they're still moving in that direction, then maybe you can reverse engineer it and they would end up together. I don't know. It could have been all together, because I do think the Earth has. Well, I don't know if I should even mention it. I think the Earth grows, but not in the way, like, I don't think it moves the way they do. And I shouldn't even bring it up with this,
Yeah, but
right?
like
Because
if
that's a whole nother idea.
if
That-
you're in a flat Earth scenario and things are expanding out. So like so if I said to you, if you got Antarctica and you compare it to Australia, which do you think is bigger, just off the top of your head?
Well, I mean, I've never been to either one, and I really don't know. I know that the depiction of both of them, if they're saying Australia is bigger, or Antarctica is bigger than Australia.
Yeah, so it's like twice the size. And I just happened, I don't know where I got the idea from, but I fancied getting Antarctica, plotting it, and then getting the other land masses in the south, and then try and squeeze them somewhere into Antarctica. So I noticed Australia could easily have hugged around one side of Antarctica, and then I saw another bit where it looked like the bottom of another continent, and then another one. It depends on like what a continent actually looks like. If I said to you, what does South America look like? Is it going to be short, fat and stubby, or is it going to be long and slender? But the point being was that it kind of looks like you can do it, and you just get so basically what I'm trying to say is that if you to have the South as the center, the land masses on the outside could easily have fitted into Antarctica. So if there are a certain distance away from Antarctica, then maybe south-centered map with shorter distances type of idea. But anyway, it's just that Pangea thing. Naturally, if you were sort of south-centered flat Earth type of idea, and it was actually the actual flat Earth itself was turning, then you would get an outward force causing everything that started off in the middle that was loose. So Antarctica being not loose because it's frozen, but everything else thawing out would naturally drift northwards or outwards. Does it make sense?
Yeah, well, okay, so the problem that I see, here's why I would, for me anyway, like, if you want to, or if anyone else wants to, it's up to them, but for me, I wouldn't want to put a lot of time and effort into trying to derive something from them all looking like puzzle pieces that could fit together, because if you think about it, like, throughout the time, the land has changed, and if you've ever seen a beach, like, every time you get a storm and every time there's waves, it changes the beach line. And so the shapes of the continents, they should constantly be changing along the beach line, yet they remain looking and appearing like puzzle pieces that could fit together. And I suspect, this is what I suspect. I suspect they want them to look like that so that they can promote this idea that there's, like, continental drift going on, because
Yeah, but
it's a reification of the globe and the claims.
if you have things like like earthquakes, land splitting, so multiple ones of those deep down could split apart lands, or maybe it just happen in one go, but if we have things like Mariana Trenches and we have other bits and pieces that we possibly, whatever, if that's the case. But it was more the case of sorry.
There's a dude that was making a website, and he was trying to do a collaboration of, like, a collection of all of the different maps over time that he's found. And I'm going to make a note of it. And when I find that link, that guy's web, all of I think he's just got it on a Google Drive or something, but in
Oh,
Google Cloud.
there is an old map that really works well with lands and everything, and it's a Buckminster Fuller Diagonamian map, and it goes out with equilateral triangles. And even if you look at old ancient buildings, they are all made up of triangles, squares, or circles. So, and even if you look at the sun, how it moves through our sky, in the morning it comes up close to you and it moves away from you. But while it's moving away from you, it goes up in radius above, in the zenith above your head, and in the summer it comes up to 90 degrees above your head. So, I lost what I wanted to say.
Share that.
Oh, and even if you, yeah.
Can you share that map, please?
Yeah, I can share it. I shared it before.
I'd love to see it. By Donkey. But is that Oh, until I see it. Is that like north facing?
Yeah, it's more in a straight line basically. But if you look at the east-west, the west-east direction of the jet streams of that goes to the equator basically in our land. If you look at that map, you have just a straight line that airplanes are following and flying off to go with the flow of the winds in the sky.
I mean, it's not too far-fetched, I don't think, to say that if we were on a disk and we were actually moving, it would be causing friction against the outer bit, like a merry-go-round that you see down the children's playground, you know? So you're trying to build up that friction, therefore creating a field.
Yeah, but if it was rotating, you wouldn't have that straight line of that jet stream on both hemispheres going from west to east. That doesn't match with the globe.
Oh yeah, no, but I was just talking about like more of a merry-go-round, not a globe.
Yeah, I know what you get. That's what I always say. Everything in our nature grows from the inside out. So why wouldn't Earth do that?
Yes, exactly, and that's what I was saying. If you had a south center, then naturally it's the movement of the record player that's causing the marble that started out in the center or just off center to naturally go outwards. So if you slow down the record player, the marble will take a lot longer to get there. You know.
Yeah, but if you look at the tectonic plates movement, the tectonic plates of the North Americas has an anti-clockwise turning, just a few centimeters a year. But the Eurasian plate has a clockwise turning, and that's the same thing as you see in an electric circuit: two counter-rotating fields with a magnetic flow in between. And that's why you have that Southern Cross in our world with equator and the Greenwich line. But that's why I always say we're just on one part. We're on the side of the polar field because we only see everything passing by on both hemispheres from east to west. That means that we are next to each other, but not around each other.
Yeah, I guess if we keep on going on star rotations and you know, two of everything, that's where we start losing focus on the ground and the basics, you know, because I think these star rotations and stuff like that could be anything, but certainly if you get something down on paper, and like I was saying with the Antarctica, what apparently it looks like could actually originally everything was just tied into it as one.
Yeah, but if you look at Antarctica, there's even an old CIA document that states that I always learned in school that the North Pole had land beneath the ice, but that document states that the South Pole doesn't have land beneath the ice, and the North Pole does. So, and what we see these days is Antarctica with land beneath the ice, and the North Pole, where's the land gone?
Yeah, it's true. Depends on what the North looked like. If the North was the outside, and the measurements were less, then would anyone have verified anybody else's seas? They probably would have breached something trying to get around there. You don't really see any cables going through the North Pole, do you? Any no sub cables, nothing like that. Everything's around the edge. So trying to imagine what the North Pole, the area of the North Pole waters could be the other way around.
Yeah, but that's what I always say. I don't think we really have a polar field in our world. I think we're more in the dialectic of the total magnetic. Or what I mean is surrounding the dialectic, just at the center, and everything outside. Because if you have an inertia at the center, it will move slowly. But the farther you go out, the faster it will turn, just like we see with our stars.
The inertia being that sort of, I'm using disk, so the inertia comes from the disk moving, before that being the plane. So you would have to make the disk move just to create inertia. No, you wouldn't, because inertia is from any. It happens all the time in any angle, any situation. But if you're talking about fields and stuff like that, then you would only want one type of movement to create one type of inertia, to create one type of magnetic convection, if you want to call it that.
Yeah, that's why I always say light is nothing more than a rate of induction.
Well, I tell you what, if the human eye can only say the human eye can only what's the right word? Flicker rate. The human eye can only see the light bulb flashing until a certain amount of oscillations, right? Flashes. You know what I mean?
Yeah, that's what a LED light is. It's flickering light, but we don't see it.
Right. So if you've got light in general, your daylight and all that, if that was flickering, you know, I'd imagine Is that something that we pick up and we don't realize, and we just say it's this or it's that? But if we're recording everything in a maximum of so many flicker rates, whatever like that, it's indistinguishable to us. So I think kind of like if you're at about 100 flicker rates, your eye cannot distinguish slow or fast, and it's just a natural fact. So if you had daylight flickering at 100 hertz, would anything pick up on that?
No, I wouldn't think so, because we don't see the LED light flickering, which is a diode. Is on off?
Yeah, you see, they've got things, and they've seen thing where they get like moving plastic, and the plastic have got certain lights to them or something like that. Or maybe it's like a spinning propeller looking thing, and then it creates a motion picture, And
Yeah, but if you look at everything emitting electromagnetic radiation, what is in essential is just energy, heat, and if you know that light needs an object to reflect off, that tells me enough. When those lights disappear high up in the sky, that means those lights are coming from inside the world and not from outside.
Cool, man.
Even the star projection shows you that. I always say to people, you live in a world filled with magnetism and dielectric, and you're giving it all kind of real takes about it, because in essence, it's all pressure mediation. It's all controlled by pressure and temp. That's the same with magnetism. When you cool them, you levitate things. And that's the same with the density tower of the sky. It goes from solid to liquid to gas to a superfluid that even can solid out. And that's a density tower that builds up on the other side the same way back down as it does in ours. So I always say there is a barrier in between fields, and that is what they call the negative energy. That is what they are using in the field propulsion. That is what they are speeding up with high frequencies to generate an exclusion zone in the sky itself. All goes back to Tesla's counter-rotating fields and everything, with the longitudinal wavefronts to the ground, and with the plasma in the sky. That's the whole thing with Turkey, with that earthquake. That's just all Tesla technology they used. Just like electricity, it's a chain. It's connecting the positive and the negative. They are one and the same.
Hey, Grizzle, do you know where to find that document that you talked about, the ice fields and the land under the ice in the north?
Yeah, I can pull it up for you.
Yeah, I'd love to see that.
This, but then in their experiment, they won't be like having the cause in it. They'll have some different thing, independent variable, and they won't do the thing they said they were gonna was the actual cause. So it's kind of like they're trying to like do a switcheroo, a little switcheroo on you.
Yeah. Hey, Jeremy, I just want to let you know that what you're testing for still isn't a variable in your experiment.
Uh-oh. Sorry, what?
Let's see.
I don't know what does that mean?
Are you referring to a previous conversation that you had with Jeremy?
Yeah, it's the one he just mentioned.
There.
What did I mention?
The example you just mentioned apparently involves this person directly.
What was it? Well, earlier today, you're talking about the gyroscope, the Foucault pendulum, something familiar today?
Yeah.
Yeah, so they want to say Earth rotation is causing the precession of the pendulum or gyroscope, but then they'll do an experiment and they'll never have Earth rotating in the experiment. They'll have something else. They'll do other stuff, change latitudes.
Yeah, because what you're testing for isn't part of the experiment until the result, because that's how that works.
No, the way
What's
it works
the
is
independent variable in Foucault pendulum?
the way it works is you have. Or go ahead.
I just want to know what's the independent variable in the Foucault pendulum when you do a Foucault pendulum observation experiment. What's the independent variable?
What do you think the independent variable is?
He's trying to reverse the question. Just answer the question, bro. It's weird.
Because you're making it weird instantly.
Yeah, the effect, the dependent variable is precession change with latitude change. That's the dependent variable, the effect. All right.
Precession change with latitude change.
Yeah.
So then the cause would be the rotation of the Earth.
Okay, that's the
How
independent
are you going to
variable.
manipulate that independent variable?
Yeah.
How are you going to have a control group?
Yeah, now you guys know why he didn't say what the independent variable was.
You can control Earth's rotation, bro. That's crazy.
Who says they can control Earth's rotation? Who said that?
Dude, you have
What's the
another
independent
account.
variable?
How many accounts do you have, Robert?
Yeah,
Yeah,
because
welcome, Rob.
Yo, he has
independent variable.
I'm trying to make. I'm trying to make the
hold on,
voice.
real. He has a J trig amount of stock accounts.
Absolutely.
So what's the independent variable?
You can't like measure the independent variable without a control group where you do not apply the independent variable to see if the independent variable is what's actually causing the effect.
Well, our friend making the claim is talking about something that supposedly has an independent or dependent variable, or both.
Right.
Maybe it has both.
No, the independent variable is the location.
The independent variable is the
The
location.
location causes precession?
That's not how independent and dependent variables
Yes,
work.
it is. Yeah, because you're going to establish cause and effect using this method. The location would be the cause of the precession, but that's not what y'all claim.
No, independent variable is the thing that you can change.
That's what cause. That's the cause. But
No, that's not it.
yes, the independent variable would be whatever you manipulate to cause the dependent variable. This is how you establish cause and effect in science. So you're going to manipulate and remove the independent variable to see if there's a difference between the control group where the independent variable is not applied compared to the experimental group where the independent variable is applied to see if the independent variable is actually what's causing the dependent variable.
And so what would that control group be?
You'd have to go in a location where there is no Earth rotation.
Which is impossible.
Where you would get no precession.
If you say that you're assuming Earth's rotation before you do an experiment to prove Earth's rotation, if you're saying that's a given, then that's affirming the consequent.
Yeah, isn't it?
Yeah, it is.
It is.
Yes, all of their arguments, almost 99% of their arguments are affirming the consequent. Yes, it's
Grumman, you just
very
affirmed
thorough.
the consequent. You said Earth's rotation is a given, and if we assume that Earth's rotation is the case, then we do this thing that shows Earth's rotation, then Earth's rotation is the case. That's affirming the consequent. It's a logical fallacy.
Not what I said.
You just said that, yes.
No, I didn't. You said go
You
somewhere
said-
where there isn't. You said go somewhere where there isn't Earth rotation.
Correct.
And I said that you can't do that because there
So
isn't
therefore,
anywhere.
Earth's rotation is a given in your worldview.
It's an observation.
Meaning, you assume that before you do the experiment that supposedly proves that. That's an affirming the consequent logical fallacy.
How would you know the precession is not from something else? If
That's
you
not
can't
the
have a
scientific
control group?
method, brother. You're not being scientific at all.
It's an observation. So that's it.
Oh, so
But
then
you
there
can't
is no
establish-
independent. Wait, hang on. If you want to change it, fine. There's no dependent or independent variable, then, Robert. Is that what you're saying?
No, it's an observation. Observation is the pinnacle.
Please
is
answer the
pinnacle
question
of
that I
science. But yes, that is. But that's the answer to your question.
Please just answer. Is there no independent or dependent variable then?
That is an incoherent question. You need to
No, it's not.
restate your question. No. It does not apply. It's observed.
No, it's not.
Okay, so let me say this to you. I observe a tree. Let me go to a lab and let me see if I remember what I saw and create some independent variables to see if that was a tree.
No, you're
Right,
Okay, once again, you're saying
Hold on.
you take
Let me
the
finish.
thing
You're
and
an
you assume it to be the case. Robert, you're saying you take a thing, you assume it to be the case, and then you set out to prove what is a given precept what you guys are doing is affirming the consequent. This is
No, we're
equivalent to dogmatism. Hang on.
observe.
This is
Observation.
equivalent.
Observation.
This is equivalent.
You guys assume the
Let me
Earth
finish
is
speaking real
flat.
quick. Let me hang on. Let me
so-
just finish. Hang on, Grumman. I never said the Earth is flat, so please don't strawman me or lie about
I mean,
my
you
position.
also assume that rocket launches and stuff are all CGI.
he never
You're
said any of
strawmanning.
that.
I never said that either. Grumman, you have to stop lying about people and slandering them and strawmanning their position. So anyway, the thing you guys were talking about before is affirming the consequent, because you take something which is merely a precept that you repeat, you chant, it's dogmatism, and then you set out an experiment that presupposes that thing, but also proves that thing. It's like that saying God is good. How do I prove that God is good? Well, because God is good. That is dogmatism. Please stop censoring me. Both of you keep interrupting me while I'm trying to.
Gally,
I was
how
almost
do you
done
think a
speaking.
hypothesis works?
A hypothesis is not a presupposition. It is the thing you set out to.
Really, the point
Can
of
you
a
define
hypothesis,
presupposition, Grumman?
and it's the first step of the scientific method.
Let me explain.
A
You're not going to be
hypothesis
able
is
to
not a
attribute.
presupposition. A presupposition is a given that must be the case. That's not a hypothesis. The hypothesis is the thing you set out to prove.
To clear this up, you don't know if like the precession is from Earth's rotation or from anything else, unless you can manipulate the independent variable, which is what you're saying is Earth rotation that's causing the precession. So in order to test, does
No,
Earth
the independent
is that
variable
what's
is the
causing
location of the
precession? You have
pendulum.
to have a control group and experimental group. The experimental group would be the one with Earth rotating. The control group would be not rotating. And then you'd compare the precession in each to say, yeah, we can establish a cause and effect between Earth rotation and precession, and that's the only thing that's
Correct.
correct.
No,
Yeah, so there's one way that I think this could happen. Let's say if we have a roundabout, right? Remember what you've had at the childhood playgrounds? So you can make a platform that turns, and then you can maybe put that observation on that turning platform versus a stationary platform.
It's an observation. You don't need to do any of these. They're talking about independent variable, control variable. It's an observation. You're done.
That's
So
unscientific.
Grumman says that it's the observation too. Grumman, do you also agree with him that it's not an experiment, it's an observation, so there's no independent variable? Do you guys agree?
Yeah, observations is science, brother. Observation.
I was asking Grumman a question.
Why are you dragging me into this?
Because there's someone that is also debating in the same topic who's saying this is not an experiment, it's an observation. I was seeing if you agreed with him.
You did an experiment.
Observation is part of the experiment.
Exactly.
Well, he's saying that it's an observation. There's no independent variable. I've had to repeat myself like 3 times. Do you agree with him that it's an observation and there's no independent variable?
Just me, brother. Don't worry about
Observation is a part of the experiment. That is my answer.
What is the experiment layout? Can you please tell me?
Why? The tree.
It's observation. That's it. You're done. If you observe a tree, you observe a tree. Now, what do you want to know about the tree?
Attributing cause and
Robert, can you please stop changing the topic to the alleged observation? We've been talking about the experiment and the dependent and independent variable, and you keep saying it's an observation. Well, Grumman, who we were talking to before you joined, he says that an observation is part of the experiment. So you two are saying 2 different things. And if we're having a discussion here, if there's not sides or there's just people saying things, I could say that an observation is the prerequisite to an experiment. I could say that's the presupposition to an experiment. I could say that it's the conclusion of it. I could just add in things, right?
Then
but we
we
need to
agree.
be coherent.
Then we agree.
Okay, so do you agree that there is an experiment, Robert?
Yeah, you agree. You said the observation
Okay, so you once again ignore my question.
and his observation is part of the experiment. Observation.
Great.
That's it.
Great, thanks. In the experiment, what's the independent variable, Robert?
He was arguing against your point. You said you agree. It was kind of ridiculous. He was saying you could just say whatever.
If there is an observation and an experiment,
whatever.
what is the independent variable, Robert?
You just say whatever.
No, observation. I see. If you're trying to study lava, right? You observe lava, right? Right. So
Please stop obfuscating. You were asked a direct question.
Okay, go ahead. Let me not try to steer you into something so simple. Go ahead.
An
Please
observation
don't
can't make
troll.
conclusions
I'm
on cause
asking
and
you
effect.
for the experiment. Please don't troll and say, I'm trying to steer you into something so simple as if I don't understand. I'm asking you, the observation for the experiment that we're talking about has an independent and dependent variable. Robert, please, what is the independent variable? Please.
Your question is incoherent. I'm not sure why you're applying independent and dependent variables here. You made an observation of a rotating Earth. You're done.
It's not an experiment.
That's called being dogmatic, Robert.
No,
yes,
no,
I'm not.
Okay,
Robert's
I'm gonna
trolling.
answer.
It's
Okay,
an
I'm
experiment.
gonna
You're
answer
done.
this.
You made an observation. You're done. What are you talking about?
Robert, we can't have a coherent conversation if you're repeatedly obfuscating and avoiding. Like, these are just regular questions so we can move forward, and you're stultifying and stopping any progress.
You made an observation of a rotating type.
No, you made an observation of precession. You're attributing rotation to it.
This is just a
Without doing an
weird
experiment,
tactic.
which is unscientific.
Well,
I think we need moderation so the conversation can continue. We're getting stultified. We're getting stopped by this weird. No, observation.
This
We're
is
talking about the
stultification
experiment.
at its finest. Yeah.
Okay.
Jeremy, you wanna step in and mod because I wanna get in, so I don't wanna mod my own conversation either.
I'm just going to answer the
I'm done.
question
I'm done.
here.
I already made my point.
You didn't make any point, Robert. All you
Just
did
mute
was
the Jamaican guy.
derail.
Just mute the Jamaican guy. I think that'll solve everything. Okay, cool. Now we can talk like normal humans. All right, Grumman, you wanna have a nice back and forth? Just
Yeah,
you know?
sure. The
Alright, cool.
independent variable in a Foucault pendulum is the location that it is set up in. The dependent variable is the rate of precession.
So why would
which
you
is the-
attribute Earth rotation to this? Where's Earth rotation come in?
That's the reason for the
How
precession.
do you know? How do you know without
I mean, how do
experiment?
I know?
How do you know? You're just saying, okay, at different locations we have different precession rates. Great. Everybody
Yes.
would acknowledge that.
And
But that's
that
not
would
attributing a
yes,
cause.
and that would line up with what we would expect from a spinning globe Earth.
But you'd have to
So it's
test
an
that with an
assumption. It's an
experiment.
assumption.
Affirming the consequence.
If-
We're using
real
the
quick,
presupposition that it's moving to
if it
prove that it's
lines
moving.
up.
Real quick, guys, all they can do is measure the effect over and over again. They can, because the effect is precession change with latitude change. So all they can do is go to a new latitude and measure the effect, go to a new latitude. That's all they can do. They can't do anything past measuring the effect. They're just attributing things to the effect. You know, he's saying the independent variables latitude change. That's just part of the dependent variable. That's just, yeah, you change your latitude and you get a new precession. That's the thing. That's the effect.
So you presuppose the Earth
So
moves.
then, okay,
You
so
set out an
that's part of
experiment.
hold on.
And then you
If
use
that's
that
part of the
presupposition
independent,
to prove that the
dependent
Earth is
variable,
moving.
Gally, if latitude change is part of the dependent variable, then what would be the independent variable?
Whatever you're claiming the cause is of the precession. What do you think's causing the precession?
The
That's how this
rotation of
works.
the Earth.
That's how this works. You get a dependent variable in effect, and you're like, "Ooh, I wonder what's causing that," and you take a guess, like, you know, what do I think's causing that? And then you go and do the experiment on the thing you think is the cause.
Right, and we should see.
So, what do you think the cause is?
We should see.
Well,
the
bro, what do you
rate
think
of
the cause is
precession.
of the? What do you think the cause is of the precession?
I've said this.
He
I don't
thinks
know how
Earth
many times.
rotation. All right.
Earth,
So you know
Earth rotation. So Earth rotation. So now we go to do our experiment. Your independent variable is going to be Earth rotation,
so
not
you have to
something
control
else,
it.
not some other thing that you're not part of the effect. There's some other thing that's not that. You have to have that.
We could go over the basics real quick, Grumman. Just like what a scientific experiment is with the scientific method, right? You make an observation, form a hypothesis, test the independent and dependent variable, or you test the independent variable against the dependent variable, and you come to a conclusion, right? So your observation, right, is the precession. Hey, I noticed that this pendulum has a precession at different latitudes. Great. So then you go to different latitudes, right? You're like, oh wow, this precession changes it here. Awesome. Where's the independent variable?
You shouldn't expect pendulums to precess on a stationary Earth. You should expect them to precess on a rotating Earth, and you should expect
do
a
you know?
precession that is proportional. How do I know what?
What would on a stationary Earth? What would cause it to precess?
Well, that's a different question. There's other possibilities, right? Just like how
That's
you guys
shifting
think
the
it's a
burden of
possibility.
proof. Don't fall for fallacy. That's shifting the burden of proof. You're asking about a claim
Gally.
that they make. Don't
Gally,
interrupt
it's
me, Grumman.
not-
Grumman,
Gally.
do not
They
interrupt
did
me.
this.
Do
Yo, they
not.
did this all morning. Real quick, Gally.
Yeah,
They did this all
Grumman, that
morning
is
to us.
shifting the burden of proof. If I was debating someone on Christianity and Islam, and I said, I'm doing an internal critique on Islam, this is a problem. They go, oh, well, your Bible says this. That's shifting the burden of proof. That's a
That is
two-quote
not what I
fallacy.
said, Gally. I asked a question.
You just said on a
That's not.
stationary Earth. You just said on a stationary Earth, what makes
Yes,
the
that's a
pendulum move?
question.
Yeah, that's two quote K fallacy. You have the burden of proof. You made the claim. Stop doing what
No,
you're doing. It's fallacious.
Real quick, Gally, real quick. We did this all
Gally,
morning. I
do
had
you
him to the
not
point.
know
Hold on,
what
real quick, bro. Real quick.
fallacies are?
Dude,
ahead,
real
Jeremy.
quick. All morning
Just a
we had them. All morning we had them to the point to where, like, okay, we'll move on. I'll try to explain on a flat Earth. We could talk about this other thing, but let's just before moving forward, let's just admit you don't have any science for this thing you just claimed you had science on. There isn't any. They won't admit that. They'll just try to move forward without ever coming to that conclusion.
Jeremy, it's because we've explained to you what the variables would be, and then you keep going like, "Oh no, that's not a variable. That's not scientific."
You're not testing them at all.
Yes,
You don't
we
have
are.
Earth
I have
rotation.
different. I have
They're
different ideas
independent.
what could cause the precession, but I'm not making the claim. You're making the claim that Earth's rotation is what's causing precession. So you need to substantiate that with an experiment with control groups.
Yeah, it's substantiated with a gyroscope.
What?
Do the
That's
in an
You take a
experiment.
different
in an ex-
experiment. You take a different experiment to validate your presupposition of this first experiment, which assumes this
Gally, how do you
presupposition
think
from
a
a different
hypothesis
experiment.
works? Jesus Christ Almighty!
I really
A
don't appreciate you
hypothesis is
interrupting me, yelling.
hypothesizing the cause to an effect, which you'd have to then test to substantiate.
Yes,
The control
that's
group.
what a hypothesis is. It's you saying, "I think this is happening. Let me test it."
Yeah. So then what's your
I think
control
you'd be
group?
surprised about the people that do science in reality in this room, Grumman.
Can
I mean, Taylor,
jump in
the
real
main
quick?
problem is the independent, real quick, Beast. The main problem is the independent. Let Beast go next after I say this, but his main problem is the independent variable. He can't systematically and methodically manipulate the independent variable, which is supposed to be Earth rotating. Go ahead, Beast.
Right. Let's just go through it step by step, Grumman. Okay. In a scientific experiment, right? In the Foucault's pendulum, what is the cause and what is the effect? I'm asking you.
The cause?
Yeah. So the effect is Earth rotation, right?
Well, that should be the cause. Should, not would, but should.
Foucault's pendulum. So you're talking about the precession would be the
Yeah,
effect,
the precession would be the effect. Yeah,
and you're saying the cause is Earth rotation.
it should be.
Okay. So if the cause is Earth rotation, which the cause meaning it's the independent variable, correct?
Yes.
Which means you can change it.
Right.
How are you accounting for the independent variable? How did you control the rotation of Earth in order to test that it was the cause of the effect of the precession?
By moving latitudes.
But then
No, that is
latitudes is making
that's
precession.
the effect. That's just the effect. When you move the
Hypothesis would just
latitude and you
be
get
latitudes make precession. That would be your in that case, your hypothesis would be, oh, latitudes cause precession. That's all you can
No.
attribute. If you're saying the only thing you're
No.
manipulating is the latitude that affects the precession, the only cause you can then attribute is latitude because you're not testing Earth rotation.
Yo,
You
changing
are
latitude
aware
and
that
getting
there
a
is a
precession change is
measurable.
just the effect. That's all. That's all that is. Like you can't have that be your independent variable. That's the effect. You change latitude, you get a new precession. That's the effect.
Wouldn't you guys
You get
at
a
least
new
agree that
precession is the effect. You change latitudes is the cause.
Then
No, the
where's
effect
Earth
is getting.
rotation?
Hold on, real quick, Taylor. The effect is you get a new precession when you go to a new latitude. That's the effect. That is your effect in this. Your dependent variable. That is it. You get
No,
a new
no, it's
latitude when you
not.
go to. You get a new
No, it's
precession when you
not.
go to a new.
No,
Okay,
it's
what's the
not.
effect then? What is it then?
The effect is a new precession. The cause
Only
is
when you go
change
to
in
a new
latitude.
latitude. You only get a new precession when you go to a new latitude because
Yes,
that's
so
the
that will be
effect.
the independent variable because you
No,
cannot
that's the
control.
rotation.
No,
Dude,
you
your
cannot
effect,
control.
bro. Your effect is you get a new precession when you change
Yes,
latitude.
that's the dependent variable. Changing latitudes is the independent variable. You can't change the precession you get, but you can change your latitude.
So then you
No,
make
your
no
your
conclusions on
dependent
rotation.
variable. Your dependent variable is you get a new. You don't get a new precession from not changing latitudes. You get the same precession. You only get a new precession when you change latitudes. That's the effect. That's the phenomena you see.
So we'd have to say the latitude causes precession. That's all we tested for.
There you go.
Yeah, then there's that.
And at that latitude, what could cause a difference? What would we expect?
You'd have to
I
test
could
it.
come up with
that could
100
change?
stories that would I could come up with 100 stories right now that maybe could cause it to do that.
It's like
Well, I mean,
confirmation
If you
bias.
say that it's
They'd all be
emotion,
affirming the consequent. They'd all be affirming the
right?
consequent.
Exactly. If you say you know what it is other than latitude, it's firmly constant.
Just confirmation
if,
bias.
hang on, let me get in here.
save him.
Yeah, if there
Save
was
him, Grumman. I'm
there
sorry.
was
That
no
was dumb.
precession, right? If there was no precession, that would be a debunk of the rotating globe, right?
No, they just say, oh, they just changed the laws like general relativity and stuff like that. Like they
No,
have in the
if
past
there
whenever they
wasn't
found no
precession,
rotation.
that would
some
mean
kind
they
of
When they
were
do
still
find no
independent.
rotation, when they get a
Yeah,
no
some-
result, they just
Taylor.
change the laws of nature to explain why they get a no result.
I love
Yeah,
how
they
you guys
really do do that.
chastise.
Hang on.
No,
They
I love
do
how
do
you
that.
guys chastise us about making points that you guys didn't make, and then immediately do the exact same fucking thing.
Give me an example.
I'm sorry, Grumman. When did I attribute several positions to you that you didn't make? You said that I was a
Gally,
flat
I
earther
wasn't
who
talking
claimed
about you.
stop interrupting. If you don't stop interrupting, someone is going to moderate you. You claimed that I was a flat earther who didn't believe that rockets go to space. When did I ever say that? And if you can't substantiate it, you are doing the thing you're
Gally,
complaining
you
about.
have Earth is not a globe in your roles. It was an assumption that was backed by evidence.
Oh, you're assuming.
Earth
What
is not a
evidence?
pixie. Does that mean I believe it's flat? Oh, it's retarded.
You mean what evidence? I already said the evidence.
What
Earth
evidence
is
do
not
you
a
Right, so
say
you
about
globe in
admit to
your
rockets?
just
role.
lying. You admit to just lying about someone's position. That's fine. In your
You're straw
worldview, that's
manning it,
fine.
Grumman. But
In my worldview, it's not okay to strawman people and
There's
lie
a
about them.
difference between lying and assuming.
Well, they say when you when you
I've
assume, you
repeatedly
actually
told
make
you
an
it's
asset
not
of
the
you and
case.
me.
I've repeatedly
exactly.
told you that's not the case. So if you're engaging in bad faith and you want to say something's the case,
Gally's
you
sort of making an
interlocutors.
ass out of himself as he has
Once again,
many
you're
times.
interrupting me. We need moderation. I can't moderate you.
Yeah. Well, all right, Grumman. Do you see the text in chat?
Yeah, I see the text.
Okay. Do you see what it says about the independent variable? I bolded it for you so you can't miss it.
Factor that's manipulated or changed by the researcher, which would be the latitude.
All right. So you change the latitude, right? So the effect of changing the latitude is changing the precession. So what's the cause of the precession? Changing the latitude. That's all you figured out.
No, that's the reason for the change in the precession.
Right.
Then you have to figure out what causes the precession in the first place.
Exactly. That's where we're at, bro. You got it.
You don't have an experiment showing Earth's rotating.
And if
You
you have
haven't
the
tried it with
appeal,
Earth not rotating and then with Earth rotating. You haven't controlled that variable.
and you could believe that Earth's rotating and that you're on a spinning ball, that's fine, dude. It's just a belief, and it's just a dogmatic one. If you just assert it with no scientific backing, it's fine. You just have to be comfortable with that.
What I would love for you to explain is how a flat earther proved the Earth was rotating.
Okay, so you forfeit the previous point. Got it.
So you can see that the Foucault's pendulum doesn't prove Earth curve, right?
Earth rotation.
I mean Earth
Yeah.
rotation. Sorry.
Yes, it does. It proves what we would expect to see at different latitudes from the
Confirmation
rotation
bias.
of the Earth.
Yeah, it's like that Patrick meme. This is your wallet.
This is your wallet.
This is Earth rotation. Yep.
It's not a
So how
proper
did you-
experiment. It doesn't follow the scientific method.
How'd you test for it? Well, I didn't. So Earth's not rotating. Yes, it is.
You mean, dude, there are other tests that can be done to prove Earth is rotating, and then you
Which one
take
has an appropriate
that-
independent dependent variable?
You should have led with that one
Which
because that's what
one?
we
The
were trying to get to
gyroscope that
earlier.
I've mentioned so many
Okay,
times.
now let's move to the gyroscope. What is the independent variable in the gyroscope?
It's gonna be the same shit.
The location of the
Oh,
gyro.
same issues. Okay.
Let me put that on the scoreboard.
And also having it on.
Same problems.
Pendulum.
Come on, this is flat Earth
Big
globe Earth
zero.
101 right here.
Big zero for Foucault's pendulum. All right, what gyroscope?
Big zero.
Big zero. Hold on.
Which type of gyroscope, Grumman?
I'm gonna send a couple images in the chat.
There you go.
Let me ask you, what
And
gyroscope
mono.
experiment proves the Earth's rotation? Which gyroscope would you use?
I've used one that was on a P-51 Mustang.
What kind is that?
Already explained this one.
Is that a gyro? Are you talking about gyro compass or a ring laser gyroscope?
It's an aircraft gyro.
Is that gyro compass?
So ring laser?
No.
Actually, that's an
ring
older
laser is
airplane. I
not
think that's
something
just a
that-
mechanical gyro, isn't it?
What kind is it?
Yeah, it's a mechanical.
Wouldn't that be a gyro compass?
No, there's just mechanical gyros.
So this plane, you're telling me this gyro
There's a
didn't
video
have
that
the
demonstrates that.
didn't have the ventricular? No, wait. What are the name of the things that keep it upright?
Pendulous veins.
Pendulous veins. That's it. You're telling me this one didn't have that? Did this have pendulous veins? Well, he didn't know what drift was earlier, guys. So
Let me tell you, if you don't have
there's
one
two
with
different
pendulous
things.
veins, if you don't have one with
He's-
that, you should get one. Just
There's
saying.
two different things. There's precession and then there's drift. Drift is caused by mechanical errors, various things, issues with the gyroscope itself, how it was manufactured,
Yeah, I'm sending
how
the,
how fast it's spinning. I know he can hear
It
me.
also goes over the entire
How
method of
fast it's
setting up.
spinning. Yeah, bro, it's not cool, dude. So that
I
you have
love
precession, and you have drift. Like he claimed that he did some science on this before and he didn't know what drift was.
Oh, that's from Jesse Path of Light. So that's not yours. So you lied.
Buddy, I didn't say that I did this one.
Pretty
You
sure you
literally
did.
said you did it. You said it
No.
multiple times just now and earlier today. We
I
did
said
this
I've
morning.
done it myself. I didn't say this specific one. There's a difference.
Well, then why'd you mention it? We want to know the one you did yourself. Yeah, you just lied. That's all right, bro.
Yeah, we're about validating and justifying positions and using logic and whatnot. We're not about just making baseless
And
assertions.
here you
and
go,
whatnot.
assuming I'm lying, just because I censored
I didn't say
most
you're
of the
lying.
words.
I did. I'm gonna
I
go back
didn't
and
say
live
you're
stream.
Hey,
You're
Grumman,
scrambling, Grumman.
Yeah, that's just Grumman,
Okay,
brother.
it's Grumman, first off. Second off, I never said that video was mine.
All right, don't police my accent, first of all, Grumman.
Dude, it's not an accent to mispronounce a word that badly.
Ow. That's what an accent is. Different pronunciation.
No,
Yes.
no, that would be different languages.
No.
Oh man, I'd rather someone mispronounce my name than misrepresent several of my positions.
Are you saying
Kelly, you've also misrepresented me a couple times.
How?
So.
Prove it. Okay, so more dogmatic, baseless assertions. That's all you got. Weak.
And here you go with the name calling. Awesome.
He didn't call your
More
name. He said you're
tactics.
weak.
You said I misrepresented your
Literally,
position several times.
dumbass,
Please
you just
prove
called
it.
me weak. Like, holy shit.
He didn't
I
call
just-
you.
You said I've misrepresented your position several times. Please prove it. I prove that you've done it.
Hold on. I went back in the live stream, and you said I used one called a P-51 Mustang. That's what you said.
I
verbatim.
used one from a P-51 Mustang. I did not say that I videotaped it, and I did not say I'm going to send the video of me doing it. I said there is a video of a guy demonstrating how a mechanical gyro works. which should also be in the live stream.
Okay, we'll give you that one. But can you please give us the independent and dependent variable for the gyroscope that even backs up why you even brought them up?
Yeah, this is going to be the same issue as the Foucault's pendulum. Go ahead. Let's hit this with the independent dependent variables.
Days without Globridge.
I mean, this is why people don't really debate with you guys, because you always just
Hold
do
you to your
the-
position.
No.
Yeah.
No, it's not holding
Win
us
the
to our
debate.
position.
Genetic fallacy, stereotype fallacy. Please indicate where
The
anyone else has
insults,
misrepresented your position. You have repeatedly
Basically, you
misrepresented
just
people's
grind my
position.
fucking gears, is what you do.
All right, then get out, man. You just keep saying dogmatic, baseless assertions. You keep asserting things about people's positions. You don't substantiate anything. If you don't like the way people debate and ask you to substantiate and justify things, go away.
God.
I love you.
Listen, we're having fun, Grumman, but in reality, right? These are important things, right? Because it basically has. Okay, go ahead, Jeremy.
All right, go ahead. No, go ahead. Beast, my bad.
No.
Weight change with latitude, or sorry, weight change with latitude change. Foucault precession change with latitude change. The gyroscope. Like you just start ripping them off. There's all affirming the consequence. Like, well, if this happens, we expect this other thing to happen. So therefore, it must be this. You know what I'm saying? It's just all affirming the consequence. A textbook. If P, then Q. Q, therefore P. Well, if we see the weight change, if we see the Foucault pendulum precession change with a latitude change, then it's got to be Earth rotating. You know what I'm saying?
If we see it change in a way that we would expect if Earth was rotating, then it means Earth is rotating.
Confirmation
That
bias.
is a very detailed affirming the consequent fallacy. Yes, we know.
Well, let's actually go over that. Let's go over the affirming the consequence and give an example of it, because I think that would be helpful.
Jeremy,
We
how
eat
is an
cheeseburgers and
if-then
pizza.
statement
I got a
affirming
textbook
the
example.
consequence?
Textbook example.
Go ahead, Jeremy.
Textbook example.
How?
If I'm full, hold on. I'm going to give an example, just not with this, just the example they use in the textbooks for affirming the consequence. It's usually cheeseburgers and pizzas, right? They say if I've eaten 10 cheeseburgers, then I'm full, right? It's P then Q. Q therefore P. I'm full, therefore, did you eat 10 cheeseburgers or did I eat a pizza? You know what I'm saying? You can't just be like, oh, he's full, therefore this thing, it must be this other thing. You know what I'm saying?
That doesn't correlate, because
I know it doesn't correlate because it's fallacious. That's why
that's
no, there
point.
isn't.
If you don't isolate the cause, you can attribute it to any dynamic.
Now I can put it in terms. Of the Foucault pendulum, right? To the detail he did. I mean, let's hear your if-then statement. Go ahead, you do it, Grumman.
If the precession changes in a way that we would expect if Earth was spinning.
Two ifs.
No, that's not the right. You're doing it wrong.
Bacon, help him out.
Do the P's and Q's, Bacon, for him. Hook him up.
If Earth's rotating, then we should expect this precession based on the latitude. We see this precession based on the latitude, therefore Earth's rotating. That's what they're saying.
That's
they're doing,
affirming
which
the
is true.
consequence. It's affirming the consequence. Watch, I'll use the exact same thing, right?
Yeah, that's why this is not
a really good experiment.
That is not a
Even Bacon knows it. If Bacon's not arguing it, you got a problem.
Bacon what?
I was gonna say Bacon is a OG Glober. Like, he's on your side if you want to pick sides, right? I'm not on the side. I'm just trying to stick to arguments here. I just don't believe we're on a spinning water ball. That's just what I believe.
Which is,
okay, but I mean, at least
what?
Could you guys agree that we should expect the precession to be proportional
paradigm?
to the sign of the latitude if we were on a spinning globe?
I mean,
it depends on whatever effects.
Even though they don't,
I would say it would depend on what effects were happening. Maybe not. I mean, it might not happen on a globe. There may be
Can
another.
you give me one that was done at the equator, by the way?
Taylor, just talking all over Jeremy.
Yeah, I'm pretty
there
sure
may be other effects.
It was a simple question.
There may be other effects counteracting it, and you might not see that on a spinning globe. Who knows?
Like what? Just so I understand what kind of effects you're talking about.
I don't know. Some other effect that's counteracting that effect.
Such as what?
Like
some unknown variable. The reason why you guys say we can never
the
prove
burden.
science because there's unknown variables that you can never account.
Okay,
Jeremy, just because you're not affirming the consequent, now we have a problem. They want you to
Such
affirm the
as
consequent
fucking
too.
what?
Yeah, if we're gonna use that approach, we can never draw any predictions from anything, right? Because
Well, that's why you guys say we can't prove things in science because of that. Because there's unknown variables.
I wasn't
that could
asking
be
for proof of anything. Like I'm
Well,
strictly,
you can have more
it was a
evidence
simple
if you actually
question.
follow the
Okay, hang
scientific
on.
method.
It was a simple question. Like if I drop a pendulum, right? I'm not introducing any other effects here. I'm just dropping a pendulum to swing, if you work out the forces, the pendulum should go back and forth. That's it. That's what Newtonian tells you a pendulum should do. Now, if you do that on a spinning globe, you should not expect it. You should actually expect a precession, a pendulum that precesses.
Yep, there could be an ether drift. There could be invisible unicorns. I come up with about 100 things that could be stopping it from precessing on a globe. That could be
Assuming the
happening.
physics we know. Assuming simple physics.
You guys make up new physics every time you get something wrong. You make up new physics. What do you mean assuming the physics we know? You guys have done
Okay,
it.
here we go.
consistently
Here we go.
throughout history.
Misrepresenting. There it is.
That's not misrepresenting. You guys
None of us have
when
done
you-
that.
No, I'm talking
There you
about
go, doing exactly what
mainstream.
you chastised me for doing.
Right, so
Mainstream. Sorry, my bad. I just didn't phrase it right.
No, he's not
Mainstream-
attributing causes to
Hold on, guys.
effects.
Hold on, man. I'm talking mainstream physics has just changed physics because of to make observations and measurements fit their model. Mainstream physics, not you guys.
Yep.
I didn't mean you guys. You guys don't do anything. Duh.
Okay, if I drop a rock,
Jeremy-
should I expect it to hit the ground? The obvious answer is yes, right? I'm not saying I put a pogo in the path of the rock, so it's going to bounce up. I didn't introduce it. Obviously, the answer is just yes. If you want to introduce more stuff that makes the answer be no, sure. But if I'm not introducing anything else, I'm just dropping a rock. The obvious answer is I should expect it to fall to the ground. If I drop
Can
a
I jump
pendulum, I
in?
should expect it to go back and forth. If I drop a pendulum on a rotating platform, I should expect the pendulum to precess. I mean, it's as simple as that. We don't have to go to new physics or whatever that was. The answer should.
But you're not explaining why the rock's falling.
I know everyone else answered
besides the
yes, but
point.
they didn't realize that there could be some other effect that might not make it happen. Like that may not be 100% guaranteed on a globe.
Sure.
That the percent. Okay, sure. Okay, so we agree now. You were arguing with me that whole time, but now we agree.
Can I ask
Jeremy,
Bacon
so
a question next?
Jeremy, so what would cause it to not precess on a globe?
Wait, Beast,
Counter-rotating.
can I ask
Why?
Bacon a
Wait.
question?
Let me just answer it. Let me just answer it real quick. Counter-rotating ether wind.
Have
At the
you
exact.
proven-
No, I haven't. I'm just saying. You said what could be doing it. That's something that could be stopping hypothetical precession on a hypothetical globe.
Okay, precession isn't hypothetical.
I know, but we're playing in a hypothetical where what if we were on a globe and would the precession be guaranteed? That was Bacon's question, right?
Well, that's what I was going to ask
Bacon.
Bacon.
Wasn't on the scenario. Yeah.
Okay, but
was the question.
Hold on, Grumman, hold on, real quick.
You said
Bacon.
Go ahead.
Wait, Jeremy. God damn it.
Go ahead.
All
My
right.
bad.
Bacon. What would happen if you had a pendulum at the equator?
You would just go back and forth on a spinning globe or on a stationary globe.
It
Or
should
on a
just go back and
stationary
forth. Wait, how are you saying on a stationary Earth? What are you talking
Yeah,
about?
yeah, I'm saying on a stationary Earth, on a globe, on a stationary globe, on a rotating globe, all those should get a pendulum that just goes back and forth.
So
That'd be the
in every conception, you expect the pendulum to have no precession at the equator.
Yeah. So far, I have nothing. I don't have anything that would suggest me you should do anything else than just go back and forth.
Is there any video or documentation or anything of the sort that shows a pendulum not precessing at the equator?
Yeah, we've been asking
I
that
don't
for
know.
years. I can't believe you guys haven't done something yet.
I tried to ask
believe it's
earlier.
around.
The most boring Foucault's pendulum ever. It's one that doesn't precess.
So what? Science isn't always fun and exciting.
Wouldn't that be-
Sometimes it's boring.
Wouldn't that be the best
Yeah.
0 point reference to test to see if it's actually a 0 point?
I don't see
So
what
to
that
do
would
it at
be the best
90?
one. Like we have a clockwise in the northern hemisphere. So it's the other way around. Counterclockwise in the northern hemisphere and clockwise in the southern
Right.
hemisphere.
Just like the poles are important, wouldn't the equator be important?
Oh, that's another thing
I was
with it.
talking about the whole hemisphere as a whole, but
But do you know what I'm saying though? In
Sure.
terms of like 3 points that would be very important in terms of significant spots on the globe would be the equator and the two poles. How come no one's ever done
to me, no.
a
I mean,
pendulum
if
on
you-
the
45.
equator?
If you do
45
if you
would
do
be
it
the
on a
one,
couple of different points and in separate hemispheres and it matches the expected values for the latitude, I wouldn't. To me, that's it. I wouldn't need more than that. But if you're thinking unless we have the equator, we can't reach any conclusions, then
No, I'm just saying, isn't it a special spot? It's a very unique spot on
Very
Earth, right?
unique.
The celestial equator in the sky where it shows two counter-rotating star fields. You don't think that would be a significant spot to do
It's a
scientific research?
significant, very significant
be.
beast. Yeah. Let me just say this real quick, though. The Foucault pendulum is it's the Coriolis effect in action. That's the guy who made it, or he based it off the Coriolis effect. Foucault. Now that goes either clockwise or counterclockwise in the north. Which one is it?
let me think for a second.
Either way, hurricanes go the opposite direction, and they say that's also the Coriolis effect, but they go in the opposite direction as the Foucault pendulum in the same
Yes,
hemisphere.
pendulums and hurricanes are not the same thing. They don't work the same
It's the
way.
Coriolis effect.
Yeah,
Mm.
the
They're both
Coriolis
the
is
Coriolis
Jeremy, the
effect.
pendulum is clockwise in the north, counterclockwise in the south.
Yeah, and hurricane. So the pendulums are clockwise in the north, and hurricanes are counterclockwise in the north, but they're the same effect.
Yes, because Coriolis is not about being clockwise or counterclockwise. If you move something south to north in the northern hemisphere, the deflection is towards the right. That's the same for pendulums and for hurricanes. But hurricanes are air moving inwards. If you apply that to the motion, you get a counterclockwise motion. If you apply that to a pendulum, you get a clockwise motion. The exact same effect give you opposing
Different
rotation because
directions.
those are different motions. One is going back and forth. The other is just continuously falling towards the center of the hurricane.
Same
That's
effect.
actually
Same effect. Real quick. Same effect. Different directions. Also, they have a storm on Jupiter, I believe it is, that's actually going in the wrong direction for the rotation of Jupiter. Like it should be going a different way, but it's not. It's going. It should be going one way, but it's going the opposite way on
Are you
Jupiter.
I
talking
don't know much about
lateral
the
or
weather in
rotation?
Jupiter.
It's backwards on Jupiter. Your Coriolis effect thing is backwards on Jupiter.
Yeah, I'm not sure about that.
I have
But your argument.
I have a real quick that I want to jump in here
your
with.
argument
A
that
very important thing.
your argument is
The magnet. There's other things that can affect pendulums.
You're going to
okay?
change the subject. Let me
Magnetic
respond to him
fields can
first.
affect pendulums. Okay, so I can post a link to this. But even for non-conductive pendulums, magnetic effects can play a role in affecting pendulums. It's called eddy current damping. You should look it up. So whenever there's multiple causes to an effect or other things can influence it, you have to isolate those variables and test them independently.
Yeah, you should do Foucault in a Faraday cage inside of a vacuum. That'd be neat. It still won't prove anything.
On
but
the
it'd be neat to
equator.
see. It'd be neat to see.
Do that, and then it won't prove anything. Of course, we want to do that for you, knowing you're going to say it won't prove anything at the end.
We
Yeah,
see
you,
no
you,
doesn't
still,
prove
you,
anything.
dude,
That's a
you
very
can't
good
you can't
motivation.
do that. You can't say, please do this experiment, but it's not going to prove anything. That's not how that works.
No, I just said
He's
it would be neat.
highlighting
I
how
just said it would be
ridiculous
neat.
the
First of
experiment
all, it's not an experiment, and I just said it would be neat to see. You'd still be having and affirming the consequent fallacy, regardless if you did that or not.
Yeah, so it's not like, for example, I go to the equator to do the Foucault pendulum, show it doesn't process, and then Beasticle is going to be, okay, now I'm
I
good.
would
Obviously,
be,
that's not going to happen.
dude. Bacon, are you close to the equator? If you are,
Sometimes.
dude, bro, I'm telling you, if you can do that, that would be so cool. Actually, that would be actually
cool,
really
but
Yeah,
cool.
it's still
so cool.
affirming the
Just one guy saying so cool is not enough motivation.
I think it would be so cool
No.
too. So two guys saying it'd be so cool.
All right,
Yeah.
here's why I think it would be cool.
I think it'd be really cool too.
Let's try to get 4
yeah,
guys.
3 guys, 4 guys. All right, come on, someone else say it would be so cool.
Okay.
Bacon,
okay
And a girl.
okay, hold on. Take a
Pretty
shot every
really
time
cool.
someone says it's going to be so cool. We're going to be hammered by the
4
end.
guys and a girl.
It would be
All
awesome.
right, you got 4 guys. Locksmith chimed in.
And a
Now
girl.
you got to do it,
Right.
Bacon. Now you got to do it, bro. I know
Sure.
you can do it. Video
Yeah,
it. That
yeah.
would be actually awesome. All right, that would mean the equator is a very special place, no matter how you look at it from any paradigm. All right,
It already is a special place.
it is a special
has a
place,
name.
dude. The fucking sky splits in the middle of the sky and it has 2
That's
counter-rotating
what I'm
star
saying.
fields.
It already is. It already is a special place.
I'm just saying.
Actually, speaking of stars, I want to ask something. Why can someone in Australia not see Polaris?
This is the version at its finest.
There is an answer for that.
I would say it's due to the light. Me personally, I would say there's some kind of magnification or optical effect happening that's making that happen.
Magnification.
Magnification,
bunch of
kind of like Rob Skiba's thing when he made the sunset on the flat table.
Magnetic effect going
Okay.
straight up.
Well,
Like,
What was
I'm
the question?
talking,
hit.
I'm
Well, with
talking
that-
looking straight up.
Well, with that question, are we presuming that Polaris is a known distance away? What if it's a lot closer?
Oh my God! If they were at the same distance, Bacon. If the stars were at the distances the globe are say, Bacon, you're up.
What? What's that?
What would we see in the sky if the stars were at the distances you guys claim? How many stars would we see in the sky?
On a flat Earth?
Yeah.
1.
1 star. That'd be fucking crazy.
Wait,
It would be
is it because
overhead
of
for
light?
everyone.
It's because of the light and how far away it
Yeah,
is.
you unpack that?
Yeah, if
Yeah.
you put all stars
then-
light years above a flat surface, then they all become 1 star at the zenith of everybody. There is only
That's
deviation one.
wild. And you're talking about just straight trig and and scaling that out. There's no other effect, no atmosphere, nothing.
Even
Right?
with atmosphere, because the angle of incidence is 90 degrees, there is no refraction there.
Oh
Are you still working with infinity distance to the star?
No,
Oh, I said
90
light
like,
years.
light
That's pretty
years.
finite.
It's still pretty
90
far.
light years.
So if
Yeah,
you
that's
had the
infinitely smaller
distance,
than infinite.
That's parallel.
did you model this? Is that why you know?
No, this is just obvious.
All right, so
So would it be really bright or dark?
Just
Really
work out
bright,
like,
actually.
okay, so let's say there is think of Earth as a map just for illustration purposes. So you have 1 star above the edge of Antarctica on one side and another star at the other edge of Antarctica, and you put both of them 1 light year above the surface of the Earth. The angular size between them is less than what you can resolve, so they become 1 star, and those are the 2 furthest points on Earth. So every other star would be also merged into 1.
Huh.
He's got such a massive
Dude.
distance on it. That's what's causing it. He's assuming it's too far away. But yeah, I get it.
Jeremy.
Actually,
Oh, sorry. Go ahead, Taylor.
Hold on. Like, this is really cool. I just looked this up. What he said was true. That the Foucault's pendulum actually rotates different ways in the northern hemisphere than what the ways that hurricanes move. And also Jupiter. It has that great storm. And Jupiter's red spots in the southern hemisphere, and it rotates counterclockwise. Jupiter rotates the same direction as Earth. Okay, but in our southern hemisphere, the Coriolis effect, they say, is what causes the hurricanes to rotate clockwise. So why wouldn't we have, if they're both rotating on the same axis, them have the hurricanes have the same effect if it's due to Coriolis?
Yeah, I don't know about weather in Jupiter, but you shouldn't
telling
expect the.
It just doesn't make sense. I'm telling you, this is true. It's crazy. Go ahead.
Yeah, you shouldn't expect the rotation of hurricanes to match the pendulums, because then
No,
the force of Coriolis would be working in the opposite direction in one compared to the other.
Okay, then why on Jupiter doesn't have the same
don't know about
hurricane
Jupiter.
rotating in the same direction in the southern hemisphere?
I have no idea.
That's pretty weird. That was a good point, Jeremy. Yeah, but you should look up eddy current damping. It's another effect where the magnetic fields can actually affect precession rates of the pendulums. So there's other things that can be attributed to precession rate here on Earth.
Sure.
So then you can't say, oh yeah, rotation causes pendulum precession whenever other things can affect it as well. Same thing for the gyroscopes. You can have magnetic fields affect the gyroscopes as well. Precession.
Would the magnetic field that affects the pendulum also affect the compass, for example, in a noticeable way?
Well, that's an interesting question. So they say no, but the
there you go.
it would work in a little bit different mechanics, because the gyro compass works in a different mechanics. But rotating objects can create a magnetic field. This is called the Burnett effect. So in this case, you can have a magnetic field generation from a rotating object, and it deflect from the current magnetic field. So it'd be working a little bit different
What
mechanism,
rotating object?
but still be affected. Gyro compass?
I thought you were talking about the pendulum.
I thought you just asked about gyro compass though.
I don't think I mentioned that word.
Oh, okay. Sorry, then I misheard you.
No problem.
The pendulum, that's called eddy current damping.
Okay, how does that work?
Let me get this pulled up. Okay, magnetic fields can significantly affect pendulums, especially those made of conductive materials, but also whenever non-conductive materials as well. Eddy current damping, when a conductive one, such as one with copper paddle, swings through a magnetic field, changes the magnetic flux, induces eddy currents within the metal. But this can also happen in non-magnetic fields too, and I think that's from the Burnett effect, which is where rotating objects here on Earth can create a magnetic field, and it would be deflecting from it.
Yeah, I didn't understand at all how that works.
Well, look up the Burnett effect, and then maybe you'll understand more.
How do you spell that?
BERNET effect.
Right. I'm not finding anything related to physics here.
BERNET, Burnett effect.
Double T or one T?
It might be two T's at the end.
Oh, Barnett effect?
Okay, so yeah, Barnett effect. And so these eddy currents create their own magnetic field that opposes the motion of the pendulum, acting as a braking force and causing the pendulum to slow or stop much sooner than it would due to air resistance alone. So even non-conductive pendulum fibers can still be affected by ambient magnetic fields if the pendulum or its mass retains weak magnetization, resulting in additional torque and energy dissipation in sensitive experiments such as torsion pendulums. I'll send you the paper.
Can you
I'm going to
post
send
your
you the paper. Yes.
Keep posting the
I
live
was
chat.
just finishing my sentence first, but yes, I will send it to you.
Okay.
No problem.
Right, the pages I'm finding here don't mention pendulum.
It will mention rotating objects. Here's the one on the pendulum. I can post it in the live stream text.
Yeah, please.
Yeah, no problem. I just did. I can try to tag you in it too. If you're on the live stream text, you should see it though. I can DM it to you as well. I like when people DM me stuff. Here you go.
Is that true, Taylor? You never respond. Just kidding.
I try. I'll check it out. That doesn't mean I necessarily respond to.
Yeah, I don't know what what's a torsion pendulum.
I mean, we should understand the context of the articles we're reading before we think they're relevant.
Well, go read it, and then you'll understand.
Oh, you brought it as if it's relevant, and it could be.
Yeah, I tried to explain it to the best of my ability, but if there's like basic definitions you don't understand, like you can definitely look into it.
Oh, well, I've never seen this
Well,
torsion
if you do, you could just say it, what that is. Like, what is a high Q torsion pendulum? How that relates to Foucault?
Yeah, it's kind of a different pendulum, Taylor, just to be fair to the argument.
But I think the same principles would apply.
Oh. Okay, why? Well, what principles?
Basically just looking for precession when it's rotating.
No, what principles of the Burnett effect.
Yeah, I think the eddy current damping would also translate over, and the Burnett effects, which play a role in the eddy current damping.
What are eddy current damping?
I already kind of read it out earlier. Do you want me to read it again?
No, I wanted to explain me. If you're going to read, I'm going to again not understand anything. So can you just explain me?
Okay, so when a conductive pendulum, or this also applies to non-conductive ones too.
Okay, so why is
the magnetic
defined as a
field, like the
conductive pendulum?
magnetic field of the Earth, is the magnetic flux, and which induces eddy currents within the pendulum. Okay, and so this will basically oppose. Okay, so this eddy current will create its own magnetic field that opposes the motion of the pendulum, acting as a braking force and causing the pendulum to slow down or stop much
Right,
sooner
so you
than it
would
would
slow
due
it
to air
down, not make it
resistance alone.
precess, right? Like you basically, that's the same thing as if you move copper through a magnetic field, right? It just creates
But the
resistance against the
repulsion,
motion and it hits it up. How is that going to cause precession on the pendulum? And if you're like
right?
a
So the
focused
braking
pendulum, hang on
force.
just a second. Let me just make a point here. Focused pendulum is very, very sensitive. If you need a very tall pendulum because in order for you to be able to get like a degree of precession, you have to make it swing for a long time, right? So if you have something slowing it down, it's going to stop really quickly. You don't have that. Well, so if you're trying to bring eddy currents into pendulums, then they're just going to stop. Then that's obviously not the case where we do have the pendulum swinging like for almost an hour. So I don't think this really relates to the
so
focused pendulum. It doesn't seem to.
yeah, so the braking in a sense is going to be affected by the magnetic field in whichever way the magnetic field is moving. So it basically in the pendulums they'll have a motor that continues it moving, but depending on which way it's repelling the current magnetic field, that will cause it to precess one way or another.
Wait, what's rotating? You said. Like, we're just dropping a pendulum here. We're not talking about like doing any magnetic machinery around it.
No magnetic machinery. This is even for non-magnetic machinery.
Okay, so why is it defined? Because when you start reading, you said like for conductive materials, but it also applies for non-conductive. Well, if it also applies for non-conductive, why is it being defined as in terms of conductive material? What is the difference between
let me
conductive
answer.
and non-conductive?
So even non-conductive materials can actually create a magnetic field if they're rotated. This is called the Burnett effect.
Okay. Yeah, I'm trying to see how. I mean, you brought that is okay. This could be the cause of a precession of pendulums. I don't think what you're bringing actually supports that idea. Doesn't
Why?
seem that that's the case. Well, for what I just mentioned, like eddy currents, for example, that would just slow down the pendulum. I'm not seeing how you're going to get the pendulum to precess without slowing down.
Okay, so the eddy currents can basically affect the pendulum's rotation by causing magnetic damping. So the damping actually reduces the amplitude of the oscillation and slows or alters the natural precession motion, leading to energy loss and changes up the pendulum's behavior and the precession rate over time.
Yeah, when you read, I don't understand anything because like I lost you in the first words and I tried to question you about it and you just kept reading. So what's the
I'm just
rotation
reading
of
like
the
the
pendulum we're talking about?
definitions of it. But if there's like particular words that you don't understand,
No, wait,
like
what? I don't think this actually relates to the Foucault tension theory.
I think it does. Anything that's rotating can generate a magnetic field and basically reflect or deflect off of the current magnetic field present.
What is rotating?
Anything rotating? Are pendulums rotating and spinning around?
Yeah, the pendulum's going back and forth. There's no rotation. What are you talking about?
Okay. Well, in the paper that I sent you, basically, whenever things are moving, they're creating some sort of eddy current that can reflect the current magnetic fields present.
Yeah, that's the slowing down of the pendulum. That's not the pendulum processing.
Because it's creating its own magnetic field.
Right. If you have eddy currents on the way of the pendulum, then the pendulum stops. Right. Because it's going to resist motion.
Isn't the pendulum you're referencing for rotation have like a motor in it that keeps it going?
I'm just talking about dropping a pendulum. I'm talking about the type of experiment that people do like with
like a non-motorized one?
Yeah.
Okay, so go ahead.
I was gonna say I got something for you that's actually interesting here. This is according to a journal of experimental and theoretical physics conducted by the American Physical Society. So hang tight. Let me get you the page because it's probably a Google book showing, right?
For me or for that?
For you.
I'm gonna have to make something here.
Huh? Well, if you need a page or whatever.
I won't have the time to read this. Well, I can try to read it later, but don't expect me to read it now.
Well, not read all of it. Just right there where it says, nevertheless, the pendulum behaved as if it had two periods. Furthermore, it always started rotating clockwise, never counterclockwise. This fact remained a puzzle until another wire was substituted for the wire which I had been using. The two wires was cut from the same piece, and we were certainly as nearly alike as two wires could be. Yet the pendulum now invariably started rotating counterclockwise, never clockwise. So
yeah, I have no idea what the surrounding context is here.
Well, there's basically just talking about the elliptical path.
That basically wires. What are those wires about? Do we have some electronics here? I don't know. Like this is the middle of page 249, right? There is some context behind this. So anyway, I'm gonna have to leave. I'm getting hungry.
Another cool one is the crane effect. This was actually done on Foucault's pendulum. So magnetic fields can interact with any magnetic materials or residual magnetization in the pendulum bob or suspension fiber, causing additional torques that can alter the pendulum's precession or alter oscillation. An effect called the crane effect. They can actually use control magnets to try to cancel the intrinsic precession in a Foucault's pendulum. That's CRANE effect. So basically, my only point is that magnetization can affect precession rate in multiple different types of experiments that they say proves Earth's rotation. So this is just something at the very least you'd have to take into account as as another variable that can influence the effect.
Have you ever seen a pendulum precess or swing or anything?
I personally haven't.
I have.
What have you seen? What did you see?
It just basically you just let it go for a while, and then it'll start to have like a tiny well, maybe it's based on the latitude. I don't know, but I did it in my school, and it basically just makes like a small precession. But in order to determine the precession, like the rate, right, it has to be over an hour. We just had the shitty school ones. It didn't keep going for an hour. Like we had to keep doing it. But there is a precession though, right? Regardless of how much it is, if it is latitude dependent, if people are actually doing it across the world doing it, you know what I mean? I don't know.
What do you think the precession is? What do you think it means?
It's a good question. I don't know. I'm not going
That's
to
where a lot
attribute
of
it.
people get confused, right? They think, a lot of people, when they hear that, they think the pendulum precesses, right? That's the impression most people have, right?
Right.
Okay, but that's not the case. The whole idea of this thing is that the pendulum has to swing back and forth. That's the whole idea.
Right, and that the Earth is underneath them. Ah, that's right.
You get it? That's the whole magic trick, right? So if you say pendulum precession, what you're actually saying is the Earth is spinning. I want you to realize that in their brain, right?
Yep.
Yeah, I'm just trying to keep up.
I'll stream it.
Yeah, stream it. It's worth it. This is like comical.
We watched this live, and it was just like so ridiculous, dude.
Is this the one that went into the water and blew up?
No. This is a different one, but this one's just as bad. It's always this view. Every single Falcon launch, it's always this view. And then they never actually just keep the camera there. Oh, look at this. Look at the smoke, dude.
Yeah, check out the smoke and how it lands and tilts.
Yeah, that's
right here,
dust.
right there. That's fake as shit, right there. That's like sci-fi
gets better.
original. That's sci-fi original right there. Look at
Okay,
this.
what's fake about it?
No, that's not the one, bro. No,
That's still the one. That's still one of them.
It's still one of them, but that's not.
Okay, dude, what's fake about it? Can you explain?
Which one was the one that landed in the water?
You're making a claim that's fake. Can you explain?
Can you explain what's not fake about that?
There we go. Reversal of the burden of proof.
You just got reverse.
Stage 1 landing confirmed.
This is
Well,
ridiculous.
we
All right,
can
where's
say
the other
easily
one?
to you. Why is it? How does it look real to you?
Are you gonna
Oh, this is
answer
the one.
question as to how it looks
Okay,
fake, or
this is supposed to be real, right? This one right here, they just happen to have a buoy cam and it lands perfectly right next to it too. Come on. What the heck, bro? Are you kidding me?
Where does it land? In the water?
Yeah,
What is that?
it's in
You
the
think
Indian
that's
Ocean.
real?
That's the one, bro. That's the one. Yeah. Where's the pad?
What is
Yeah,
this?
what makes
What is
it
that?
what makes it fake?
How come
Look at that,
the
man.
water is smoking?
Bro,
Yes, dude. Did you just point out water boiling under the heat of a rocket engine to say it's fake?
you really think this is real footage, bro?
What
That's
makes it
okay.
not?
You can believe that it's real footage. It's all right.
Yeah, it's alright, bud.
Dude, I'm gonna keep believing it's real footage until you definitively prove that it's not.
We'll
Okay,
watch
here's
it one
something
more
to think
time.
about. What's the velocity of the gas leaving the nozzle? Because if I'm not
Really
mistaken,
fast.
it's only. Can you quantify it? Is it about 5,000, 6,000 miles an hour? So how heavy is that rocket?
It's supersonic.
Yo.
That
Isn't it
rocket
supposed to land on
is
a pad,
not.
first
That
of all?
rocket is at that point in time a hollow stainless steel tube because it's out of propellant. It's a suicide.
What's filming it
burn.
right here? You got where's the camera in this shot?
It's a buoy.
That's not a buoy. This is not a buoy view, bro. What are you talking about?
Oh, I thought you were talking about the other one.
Well, what is
would
this
be-
real or not?
This would be a drone.
Isn't it supposed to land on a pad?
No, that's Falcon. I explained to you that they're doing this on purpose. With
That's alright,
Starship.
man.
So
Listen, I
they're
like sci-fi
purposely
too.
landing it in water. This one is that the claim?
Yes, that's the point because they're not recovering it.
Okay, all right, okay.
Now, I would like you to explain what the smoke and whatever. What do you what?
Well,
Why is that
boiling
a point
water
of
gives off
contention?
If you
steam,
need
not smoke.
explanation
So
for
that's
that, bro, I mean, I don't know what to tell you.
Yeah, the stuff that you saw was steam.
really. It didn't look like steam. It looked like smoke.
It's
That was the
supposed to be
fakest thing
steam.
That's the
Buddy,
Yeah.
fakest
do
thing
you
I've
know
ever
what?
seen.
Do you know what thick steam looks like? Like, have you ever been in like a boiler room or seen a boiler room?
That can't
Listen,
have been real. That cannot have been real.
that's
I mean,
claimed to be real.
No. That must have been some kind of like CGI
No, that's
reconstruction.
no,
something
that's
No.
like
that's real
He's-
footage.
He's claiming it's real, and they're
No,
claiming
no.
it's real. Yeah, dude.
That's
The
not
problem
Locksmith.
is,
Locksmith, I just want you to know that steam does look like that when it's thick.
Okay. Alright.
I
No, I learned a lot from
Yikes.
that. There's a lot of good CGI technique that can be improved. I think it was a very good learning experience for everybody.
I agree. Yeah.
Yeah.
Can't wait
Okay,
to see what
again.
ChatGPT 6 comes out with.
Again, still not explaining how it's fake.
We're
I
just
still
not
don't understand
persuaded.
why would they soft land the rocket and just put it in the water? Did they give an explanation for that, or?
Because it's an experimental system. They're testing their ability to land it on missions where they actually do plan to recover it.
In the water? Does it float? I'm trying to understand the thing. Does that?
Yes,
Would it
yes,
sink?
it does, but it also
Floats? Do you
It's
know? I
almost
mean,
as
I'm
good as this.
asking. I'm just.
You guys remember this one from India?
Hey, dude, you gonna stay on one topic
No,
here?
no,
or
no, no! Don't
gonna
play
keep-
the India one, man. No one can handle that.
I don't think anyone can handle that one. All
Hey,
right.
don't pick on the Indians.
That's definitely
Okay?
not supposed to be real. The Indian one. What?
Yeah,
Don't
that
claim
wasn't
it's real,
claimed
did
to
they?
be. That wasn't claimed to be real footage. It was
Yeah,
a
there you go.
telemetry animation.
Yeah, and they're all clapping and stuff. It's hilarious.
Yeah.
Yeah, that's
Clapping and
simulation.
Usually to
acknowledging.
fool
That was
people.
made by simulation. Then they're all clapping as they watch the simulation. They could have all clapped hours ago or maybe days ago when the simulation was made. They didn't need to wait to clap. They
Yeah,
don't need to
dude.
wait
How
for
would you
things
guys
to
feel
have
Just play it
if
actually
like
over and over and
happened
clap
to
every
play the
time.
simulation.
Just
yeah,
keep
how would
playing
you
it,
how would
clapping
you
at it.
feel, dude, if you had to go on a dangerous mission and somebody just played a cartoon of you instead of actually watching to make sure you were safe and just clapped at the cartoon of you being okay? That's fucked
Depends on
up.
how
Well,
badass
that's
the
an
cartoon
unmanned
depiction
probe.
is. If
There's
the
a
cartoon
difference.
depiction is cool, I'm fine with it.
Hey, Locksmith, can you look in the live stream text? Can you tell me, is this
What is this,
smoke or is this
steam, bro?
steam?
You don't think they got CGI for that? Like, come on.
That looks real.
I'm just not persuaded. Let me see. What do we have?
Can't tell with AI these
What
days.
I know, that's true.
do we have?
Yes, actually, you can. You can
It looks fake.
quite.
Yeah, that looks
You can.
nothing like the steam in the video.
Doesn't even matter. It's not
Anyways.
relevant. It's okay, dude. You can want to believe that. It's fine.
Yeah,
No,
you
Dude,
either
there's
it's
say it
letters.
or
fake.
you
There's
You
don't.
can't see them in
letters.
the
There's like
video.
I
letters
have
inside of
beliefs.
the steam. That's how you know it's not real. There's letters in there. I can see them.
I mean, how is
Well,
someone
here,
actually defending that? Like,
Yeah,
that's
you
so
have beliefs.
ridiculous.
I have beliefs. Essie has beliefs.
right.
Blob has beliefs. Everyone has beliefs. You know, it's fine.
No, dude, here's the thing. Stuff that you can visually track yourself, watch yourself,
Here, wait.
isn't
If you're
fake.
Are you
persuaded by
dividing what
pretty
I'm thinking?
pictures and
What are you saying?
videos, that's it.
Just saying, it's a belief, right? You have a belief that this thing is real. I don't have that belief.
Let's.
Have you
So
watched a rocket launch in person?
I haven't.
Okay, then how do you know it's fake?
How do
It's
you
my
know it's
belief.
real?
We're not
It's
saying
my
all
belief.
No,
rocket
it
launches.
is very relevant.
We're not saying all rocket launches are fake. You
Yeah,
can
it's
watch a
not the
rocket go
contention.
off. Yeah. People do it all the time.
Yeah,
Check this out,
rocket
though.
launch is no problem.
No, what I
Let's go.
mean is you can watch the landing live. That's how people watch the SpaceX stuff. You can watch them come in person.
Do you trust Guardian News as a source, Grumman?
I mean,
You gonna answer
Oh,
the
yeah.
question or?
You watching this? This is supposed to be the real quote unquote footage for India. Oh, you stopped watching the stream. What are you doing?
I'm waiting for you to answer my question.
What was your question?
Rambling.
How
What was the
do
question?
you know that it's fake if you haven't watched it in person?
A rocket launch in
That's
person.
all. How do we
Well,
know it's real? We haven't watched it in
the bur-
person.
yeah, the burden of proof is always on the one making the claim that
Look at that,
that it is something. So,
What was that? It looks like they just moved a fucking sandbox from the bottom up. Look at this, dude. This is supposed to be at landing. That is some bad Bollywood right there, bro. If you ask me.
Habibi, I do not like that video.
Oh.
But Grumman, to answer your question, if I showed you a clip from Madden, and I said, how do you know that this is fake if you haven't been at a football game? Do you think that's a good way to come to truth?
Gally, that's a fucking game. We're talking about actual
Exactly.
like live feed in a video.
I get that you're
Okay? And you
presupposing the
can
thing is
match it
real
up.
that you're trying to prove, and you have error in this
Gally,
way.
Gally,
I
I've
get that you're
watched a rocket launch live.
presupposing.
I've felt the sound waves. Like you can feel them.
I've
Okay.
been to football games live. If I showed you a clip of Madden that I'm not presupposing is real, and I said, how do you know this isn't real if you haven't been to a football game? Do you think that is a good way to get to truth? Do you not understand the analogy?
Gally, you're comparing a game, right?
To?
Like a video game
I'm comparing it to what?
to actual footage
Point
that you
proven.
can
You are
compare.
presupposing that
No,
it's
Gally,
real
Gally,
to
no.
prove that
You
it's
can
real. You just
compare it
proved my
to
point.
footage taken by other people.
You just proved my point.
That
You're
is also what I'm saying.
presupposing that it's real to
Yeah.
dude, affirming the consequence. Like, come on, man.
Gally,
Dude,
no.
where's that dude again? I need to save that for later.
Gally, if
Dude,
I'm
you
watching
never heard of an
a live
analogy,
stream,
Grumman?
if I'm
I'll post in the chat, but
watching a
only if you
live
say
stream,
dude, affirming the
right?
consequence piece. You have to
While
say it like
also watching the launch live, and the launch that I'm watching live looks exactly like it does on the live stream. What does that say about the live stream?
I appreciate your concern about my belief, but you cannot presuppose something to be real to then prove
Gally,
that it's
answer
real.
my question. If
I
the
appreciate your
rocket that I am
concern for
Gally,
my
answer
belief.
the question.
No, thank
Answer the
you.
question.
No.
Why are you not answering the question?
No. You said
Why
no
do I
thank
have
you.
to answer your question?
Because I'm asking you how you think it's fake if you can watch it live.
I don't consent. In my worldview, if I don't consent to answering a question, I don't have to answer it.
Live stream video matches the YouTube video. That's the
footage.
conclusion. So what?
The
No, what
footage
I'm
could be
saying
fake,
is
dude. I mean, the thing is,
no.
no, because there's look. Listen, as far as I know,
If
well,
the footage
no
was
flat
fake,
no serious
what?
flyer that I've ever listened to denies that things get shot up into the air, right? So they could do both, right? They could shoot
Okay.
fake footage and fire something
Okay.
up into the sky.
What I'm saying is the footage that you see matches what you can see if you are actually standing there.
Right,
So
but
what?
I'm just saying the footage I just watched of that thing landing looked really fake to me, right?
So wait, Grummy Bear, are you
Even
saying
if-
that you are 100% certain that the footage is not fake?
And how do you know there's people on that rocket that you're watching from however
I'm
many
not
miles
saying
away?
I'm not saying there are people on the rocket.
Yeah, there was no
Are you
people on the rocket.
100% certain that the footage is not fake, Grummy Bear?
You gonna
Are you 100%?
actually be yes.
Okay.
Okay, so if you're 100% certain, you've abandoned science, and what you are
And
in
you
is
can
called dogmatism.
Gally, you can verify this yourself. As I've said before.
Can you name
All-
one scientific experiment that proves anything with 100% certainty?
Why are we asking different questions now?
Because you said you know with 100% certainty you've abandoned scientific claims.
Galley,
That's a good
why are we
point.
asking different questions? We're talking about rocketry.
You said you know with 100% certainty that the footage isn't fake. I can't argue with a dogmatist. It's the same thing as me saying that God says the footage is fake and you can't disprove it because it's unfalsifiable.
Galley,
That's a good analogy.
the footage is real because you can go there
Because it's
in
real?
person and see it match up. This
You
is
can
what I'm trying to
see
get
it.
through your head.
You're telling me that you presuppose it's real and then you proved it by presupposing it's real. That's okay.
That's not at all what I'm saying.
In my worldview, circular reasoning isn't actually that bad. I can work with it. I could prove to you that you are using circular reasoning.
Well, I'm not, so good luck with that.
Could I
All you
could I
see is a
try? Would
rocket
you answer
go
a
up,
question and then we could
disappear.
figure out
Wait,
if you
wait.
are?
Let's let Galley try to prove that.
Could I try? Grumman?
Sure, go ahead.
Okay, so what reasoning do you have that your reasoning is valid?
You mean what reasoning do I have that my reasoning is valid?
Yeah, so if I asked you, how do you know your reason's valid? Your reasoning, what would you answer? What say you?
Why would other footage or my own eyes line up with the footage that you're saying is fake?
I thought you said that you were going to answer my question so that I could prove that you're using circular reasoning, and then you asked me a question in response to my question.
That was me answering your question because that's the thing that you said I was doing circular reasoning on. Or did you already forget?
Nah, you just want to do it, Galley. Not worth it. You
Yeah,
don't even want to
this is
answer simple
tactical. What
questions.
you're is a red herring.
I
Wait,
asked-
Grumman, have you ever seen a magic trick? Have you ever heard of a magic trick?
I'd like him to just answer the question that he was asked. It's
Okay, you refused.
why do
Galley.
you why do
No,
you
no, no, no,
think
no, 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 no.
you said that you would
refused to
answer the
one of
question?
my
If you wanna
questions,
forfeit
and then expect
the
me to answer one
question,
of yours,
you said that you would answer the question, and now you're not.
which I also already did answer by explaining to you what my reasoning was.
Okay,
you
sure.
didn't.
You say that. Does anyone in this room think that he answered my question, which was, what reason do you have to think your reasoning is valid, or how do you know your reasoning is valid? And he said, well, I think that the blah, 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 blah. I want to know about your reasoning. So how do you know that your reasoning is valid? If anyone in the room thinks he answered it, he doesn't have to answer it. Does
How
anyone
do I
think that?
think my reasoning is valid? Because
How
I
do you know?
was there and I saw it.
No, I'm asking about your epistemology. So you have this thing called reasoning. You use it to come to conclusions. You make justifications, you justify your arguments. What reason do you have to
Galley,
think
are
your
you-
reasoning is valid?
To be honest, he felt it as well as observed it, and that is a second sense. And I think that is worth talking
Yeah.
about if you're going to grind.
Whoa.
If you're going to grind the fuck on
Dan,
the observation.
don't interrupt, dude. Why are you interrupting?
Oh, because
Yeah, you're
you
giving
guys
him a
were going to
huge
go
out.
going in
I'd like him
circles.
to
We were
answer the
stopped.
question, and I don't want to obfuscate. I just want him to answer, why does he think his reasoning is valid? So in other words, what reason does he have to think his reasoning in general is valid reasoning?
Because I was there, I saw it, and I felt it. So
you
the
have
reasoning...
this thing called reasoning. You use it to come to conclusions
Galley,
about
I
things
know what
in general.
reasoning is.
Okay,
So
how
then
do you know your
then
reasoning is valid? That's all he's asking.
He can't answer it.
The reasoning of what? That the rocket launch is real?
No. Forget about the rocket launch for a second.
I guess.
No,
Forget about the rocket
I think he's
launch.
not understanding it. So you have this thing called reasoning, right? You use that to form conclusions about things. You make arguments, you reason, you use your reasoning. Why do you presuppose that your reasoning is valid? What backs it? What is your grounding to back your reasoning?
My feelings?
I mean, that is an answer.
So you have reasoning, and it's backed by your feelings.
Oh.
But what if I have different feelings about the same reasoning that you use?
then all of a sudden your reasoning is not valid.
Okay.
Right? Like I feel like that was fake. You feel like that was real. High five, bro.
But even then, that's a reason, so you're still presupposing that your reason, which is your feelings, is valid. So I'm still asking you, I know this sounds like a trick question, but the thing is, you have a reason to suppose that your reasoning is valid, which means you're being circular, and a lot of people are circular. There's three parts of the Munchausen's trilemma. There's circular reasoning, there is infinite regress, and there's a dogmatic argument. So if you're doing one of these three things, you'd be making a fallacious argument.
And where in I've watched a rocket launch live is there a fallacious argument?
Because you are presupposing that it's real, and then using that presupposition within your
I'm
argument to prove.
presupposing that something I
know you have
was
to interrupt
standing
me.
there and
I know.
heard, felt, and saw is real. Just let that marinate for a sec.
We're talking about the
I
footage.
was there.
We're talking
I
about
was
the footage.
3 miles away from the launch.
We're talking about the footage.
The
You were in the
footage
Indian
that-
Ocean with the buoy.
Yeah, you
no,
were
I'm
next to that
talking about
buoy.
the Falcon
What?
9. I'm talking about the Falcon.
We're talking about
Yeah,
the
that wasn't-
footage that we've been talking about that the gentleman streamed for us. So you said you're 100% certain that the footage is real. So I'm asking you, how did you get to that conclusion without presupposing that it was real within your argumentation?
Because you can also track them. As people
That doesn't
have.
prove the footage is real.
The
You were in the
footage
Indian
that-
Ocean with the buoy.
Yeah, you
no,
were
I'm
next to that
talking about
buoy.
the Falcon
What?
9. I'm talking about the Falcon.
We're talking about
Yeah,
the
that wasn't-
footage that we've been talking about that the gentleman streamed for us. So you said you're 100% certain that the footage is real. So I'm asking you, how did you get to that conclusion without presupposing that it was real within your argumentation?
Because you can also track them. As people
That doesn't
have.
prove the footage is real.
Well, it proves the rocket is where it was when the footage showed that it was there.
Yeah, that's according
Okay,
to their
so
data, though. I mean,
this
the thing
falls
is, what you
into-
No, that's not according to
No,
their data. That's according to civilian
listen,
data.
friend, listen. You have to concede that they could do both. They can launch the rocket, and the footage could be fake, right?
How?
I
No,
would
how
agree
would
with you that many people have seen these launches, right? Witzer, he lives in Florida. He's seen plenty of those launches. Nobody's denying that these launches happen. You seem to be confused about this. Nobody's denying the launch happened. And you're saying, well, it looked the same as it looked on the footage, but the footage still could be fake. Like we could
How?
take an actor or somebody that looked a bit like Tom Cruise and make him look exactly like Tom Cruise, but it's not Tom Cruise.
That's not the
You've
same
seen
thing.
modern CGI, right?
You've seen modern CGI. Compared to those videos, modern CGI sucks. Like,
That looks-
objectively
dude, they look
sucks.
fake. Everybody in here thinks he looks fake.
Yeah, the
Yeah,
thing
you
is,
ever seen
you
Energy
believe
Star?
something. You believe
And you
something
haven't
with
explained
100%
why.
certainty. If you believe something with 100% certainty, you are throwing out the scientific method. You are not using inductive reasoning to believe it to a certain degree of
Gally,
certainty.
you believe
Please
100% that
stop
it's not
interrupting
real.
me
So
for the last time.
you might
Stop.
not want to do that
What?
argument.
Stop
Alright.
interrupting me. Every time I speak, you interrupt me in the middle of a point. It's very frustrating. I forgot what I was saying. Please don't interrupt in the future.
Scientific method. He's 100% certain.
Right. So you're abandoning the scientific method if you're saying you're 100% certain about something. You haven't proved it to a degree of certainty. You're saying you're 100% certain. That makes you a dogmatist. That's a
Okay,
dogmatic
are
claim.
you, Gally, are you 100% certain that it's fake?
Tu quoque. Shifting the burden of proof.
Answer
Absurdity.
the question.
No.
So, why aren't you answering the question?
He said
He
no.
just said no.
Because as soon as you get to a point where you're supposed to concede and say that, okay, you're right, you just shift the burden. You ask a loaded question, or you make a claim about your interlocutor, or you ask a question about their model or their beliefs. What this is an internal critique of a claim that you made that you're 100% certain. And then you go, oh, what about what you believe? What about what you think? That's called a tu quoque fallacy.
Gally, because you made the same claim in the opposite direction.
When?
Exactly. That's the point.
When?
No, he didn't. Actually, he didn't.
When?
Well, the thing is, I did. I could say, look, I feel it's fake. It looks fake. But you're doing the same thing. You're going, I think it's real. That's the same thing.
But the
But he's saying
difference
that
is
I
he said
Wait, when did he
100%.
say that? When did Gally
Sorry,
say that?
Gally.
Hold on to
All
your
right, sorry.
statement.
Go ahead, Gally.
I made a joke about it. I said, we learned a lot about CGI here, right?
So that's you implying that you think it is fake.
Is that me
You do
implying that I
realize
think
that.
it's 100% fake? Dude.
Did you actually just say doot in an argument?
Gally never
no.
said that. You said he said that, and he never said that, so you would be lying.
Oh,
Yeah,
all right.
this
Well,
is the fourth time tonight that you have attributed a position to me that I did not take. And every time that you do it, it's when you're getting destroyed. Your argumentation sucks, you get destroyed, and then you do a tu quoque
Gally.
fallacy and say, oh, well, what do
Gally,
you
here
believe?
you go. Here you go with the
There you go
insults.
interrupting me again.
Here you go with
He's
the
just
insults again.
recapping. He's just recapping the
I
conversation.
I didn't
he didn't say
insult you
you.
once during that, actually.
He didn't say you suck. He said your argument sucks. And listen,
ask you
bro.
guys
Yeah,
a
this is
question?
just
No, but
tactics anyway.
you
The
do know
gentleman is
that
using
is still
tactics
an
to
ad
avoid the
hominem.
point that he should have conceded several of these points, but instead, in a bad faith attempt to continue the discussion, he just changes it. He shifts the goalpost. He says, oh, well, what do you believe? Just because my belief should be a concession, I need to start attacking what you believe.
Yeah,
You
it is
said you
dogmatic
believe
to say
100%
100%
certain.
certainty.
Yes.
All right,
You're
watch this.
religious.
Kosho. Do you think that video is 100% real?
I think it's
100%
real, but
certain.
I wouldn't say 100%. But do you guys
There you
think that
go.
it's? Do you
That's
guys
it.
think that it's? You guys think it's absolutely fake?
Nobody said that.
No, I'm not.
I wouldn't
I
say.
know nobody said that. That's the point of
I
my
wouldn't say
question. was to-
absolutely. I'll give it a 99% chance.
Yeah.
Oh, I don't believe it's real. And
Do you
if
guys
someone
think
were
that
to
there's
claim that
there's a
it's
chance
real,
it
I
could
would
be real?
ask them to substantiate their claim.
Sure. So you think there's a chance that could be a real video? Then?
I've been fooled before. I'll give it a 1% benefit of the doubt.
No, of course there's the chance that it could be a real video. I'm not a dogmatist. I don't make claims for 100% certainty. Dude.
Well, then we're in
You're making
agreement.
fun of
And I
experts
agree.
when you
There's a
say that.
chance that video's real.
But Grumman, do you see how that conversation just went down? Kosho is a baller. I'm not a baller. But when you answer honestly and not try and think like you're going to get into a gotcha and all that shit, it's okay, dude. No one's going to actually reprimand you for answering honestly.
Except all of the times that people have.
Well, I'm
When have
sorry
I
that happened to
reprimanded
you.
you for
but-
answering honestly? Have I done that to you, Grumman?
I'm not saying you have. I'm saying it's happened.
Sweet. Yeah, I'm on your side. I only want to reprimand you when you answer dishonestly.
Right. But dude, look, there's Discord servers. You know what I mean? There's assholes and trolls everywhere. People like to talk about cosmology, including in this room, right? We may come to disagreements, but you got to realize that answering good faith, right, is just being honest about a question, and it's okay to say I don't know.
Okay, can we just back up?
Wait, let's back up because I know you've been to a rocket launch, but have you been to like a magic show? You ever seen a magician?
No.
You ever seen a
I
magician
haven't.
pull a rabbit out of a
That-
hat or
That's a
make a
good point.
canary disappear from the cage?
No, that doesn't. That
Does
doesn't
that
interest
mean
me.
magic's real?
Good point.
What's the correlation between someone doing what is literally called a magic trick and something that you can see, hear, and feel?
Well, they're
Videos to me
tricking your
are
senses to make you believe something happened that didn't actually happen.
How do you trick someone's senses into feeling the ground literally shake underneath them?
Who's denying the
Special
actual
sound
launch?
effects,
Nobody's denying the launch.
misdirection, sleight of hand.
But no one's denying the rocket launch itself. We're just talking about the
Earthquake
footage.
machines. They have earthquake
Yeah,
machines.
let's just
No
stick to the
one-
footage.
Yeah,
No
Well, he was
footage.
one-
saying
Oh,
the footage is real because he's seen it take off. He's seen the rocket launch.
Yes.
but you're attributing that though. Like, if you saw like a fist fight in real life and then went to the movie theaters and saw The Warrior, you wouldn't be like, "This is real because I saw a fist fight in real life. Therefore, this movie is real." You see what I'm saying? It's not an equivocation there.
I think he
That's
thinks you're
what he's trying to
talking
point
about
out.
like the rocket launch footage and not the footage that you streamed that we watched of the rocket landing in the water. Unless
That's
you were
the
on
one
that
we're all
buoy.
talking about.
Grummy
Okay,
Bear, were
but
you
you
on that
were,
buoy?
but you were also talking about the Falcon 9, which is something that people actually watch. That landing is something that people watch.
I was talking about the water thing that looked like CGI to me.
No. I'm talking
I'm
about
okay.
the other one.
I'm okay with being wrong about the Falcon 9 if it's real. That still looked a little fishy to me, but the one falling into the water next to the buoy, with this buoy cam, that was, to me, 99% sure that was fake. Let's just put it that way.
Okay, but you do realize that at what point does a rocket launch stop being real?
When I
the
see
point where
footage like that,
and they're floating in space, maybe
Okay,
where people
and
can't see it anymore, where no longer people can see what's happening, and they're switching to a different camera field other than what people can verify with their eyes.
except you can still see it. You can still track it.
here's the thing,
Did
right?
we
Once it
see 'em
gets
land
out
on
of
the moon?
your...
Yeah,
hold on
you
real
can
quick, too.
radar track it, or radio rather.
Listen, this is not proof, but it's correlative evidence, right? If you look at any rocket launch, pretty much ever from SpaceX, you have the same exact cuts in the footage from every single angle that, from the first one to the 9th one that we're at right now, or whatever. It's literally the exact same angles. As soon as it starts doing a parabolic arc in the sky, right, where it gets too far away from the ground camera, they cut, and they cut immediately to the same 2 frames side by side, right? One within like an aerial view looking at the bottom of the rocket, and then one looking at the rocket, like one side of the rocket, and it's just heating up, and it's in the middle of the screen, and it's just showing that same exact footage over and over again, every single rocket launch. There's no deviation, which means
Except there
it's
has
easy
been.
to fake, because in movie, in like green screen shit, you're gonna want to have continuity. So you're gonna use the same frames, right? The same exact shot in order to have that same continuity. If you faked it
Except
right
they-
the first time, you're gonna use the
except they
same frames
don't.
again the next time.
Except they don't. IFT-1 did not have any views from the ship. Okay, that was the first flight of Starship. IFT-2 didn't either because they lost contact with the ship. IFT-3 mostly had ground views.
IFT-1 is
And-
1, right? Or
Yeah,
first integrated flight
IFT
test?
Yes, first
Okay.
integrated.
Okay, well,
Didn't go very well.
You already said something incorrect, dude. There's a view from it on being on the rocket, but that's not what I'm saying. Like, here, let me show you.
I have a question about the tracking. Did you know you can track Santa Claus too?
No, I
I've
mean
tracked
like
Santa Claus.
No, I mean like
good point.
visually.
Visually tracking it.
The kids
Yeah,
really think it's real. They've seen Santa.
Yeah, no, it's called a telescope.
What does
You
it
know
Are
that-
you
look like?
saying you
Where does
said
it look
radar
like the
tracking? How
rocket
long
is
can you track
going
a
when it goes up?
on the
How do you
telescope?
track it visually?
Do you want me to send the video in the chat?
Yeah, show him go all the way up to space on the telescope, please. I want to
Do
see
you
it
also
anyway.
think
Go
that you
ahead.
can track a plane physically? And then at what point are you unable to tell where that plane like actually is with your telescope?
When it disappears from your field of vision.
So you think until it disappears from your field of vision, you can know where that plane actually is?
If you can see it and you know that it's an airplane.
But that's still you're still getting like a degree, right? You're like, oh, I think the plane's traveling at 500 miles an hour and it's roughly here. You don't know where, to a degree of certainty, but you don't know where it actually is. What if it speeds up or slows down?
Then
And they have.
Then you would see that.
Do you think you can see a acceleration or velocity change while watching something optically? Like that far away?
Yes.
Always?
Yes.
When the backdrop is all sky from all angles?
Yes.
Oops.
Videos in the chat.
All right, let's see what you got here. Okay, so do you see that parabolic arch?
Mm-hmm.
Okay. Watch that video right above the one you just posted. This is what I mean by it always cuts after the parabolic arching. I timestamped it for you. Now, if you look at the bottom left, it's saying the speed is increasing. Okay? It's supposed to be increasing, but it literally looks like he's angling down the camera and it's falling.
Oh, yeah.
It literally
That
looks like it's falling.
indicator at the indicator at the bottom left is an approximation. There was one where the rocket blew up, and after the
It was
rocket
still
blows
going?
up, yeah, the velocity and altitude was still going up. So that's just that's not claimed to be an actual representation of like the speed or the altitude.
Gotcha. Still, though, it always cuts right at that parabolic arch. There's no... I haven't seen one rocket launch footage, like video, where it shows a full view of it arching until it disappears out of sight. Always cuts as it's about to head back down. That's what I'm saying. That's what I see. Anyway, that's what I think. Might not be true. I don't care. We're spending millions of dollars, almost billions at this point. Can you get a freaking camera that just doesn't cut? Is that too hard to ask for?
Dude, you're watching a live stream. If you want
That's
a camera
the
that
excuse?
doesn't cut, as I was saying, if you want a camera that doesn't cut or a video that doesn't cut, they have that.
Like we're
Like the
spending
video
millions of hours on 100% certainty claim, which is unscientific, and I don't know why we would, try to figure out the logic of something that's illogical.
Live streams I've watched did cut to different views and fields of view, throughout the video. Just saying.
Before we
Wait,
try
I
to
want one that
one that I
doesn't cut
posted?
with the wide angle lens. Do you
Before
have
we try
one?
to falsify something, it has to be falsifiable. So Grummy Bear has to admit that he's not 100% certain. Otherwise, this is not
That's
a good
true.
faith discussion that can reach a
Hey,
conclusion.
Galley.
Good point.
That's a good point,
You gonna
actually.
you gonna not call me names, or you gonna?
What name did he call you?
He didn't call you any names. He
Wait,
just
I wanna
asked
know
if
what
you're
name.
going to retract your statement about being 100%
What
certain that
name did
that
he call
footage
you?
is
We'll call
real
you
or not.
names if you want.
What name?
He called him Grummy Bear.
Oh,
Did you
Grummy
say
Bear.
that?
That's a term of endearment.
That was
he
a
did
term
call
of
you a
endearment.
name. I retract my question.
No, I love giving my friends nicknames. I gave you a nickname.
Yeah.
But
That is a
this
term
is
of
a
endearment.
tactic, by the way. He does this often. This is probably the 15th time tonight, maybe the 20th, where I point out
Also,
something
if
that
you
he can't address, such as he made an unfalsifiable claim, and you all are tricked.
it doesn't work,
You're
does
trying
it?
to engage with an unfalsifiable claim. He knows it's unfalsifiable. He's 100% certain. So
Okay.
until he says it's falsifiable and he's not 100% certain, you can't engage in good faith. He's not engaging in good faith. This is a waste of time.
I'm
And
about
then he
to
goes,
post,
"Oh, you called me
I'm about
Gummy
to post
Bear."
something in the chat here.
Well, let's actually address what Gally said though, Grumman. Do you want to retract the statement of being 100% sure that that footage is real, or you want to retract that?
Yes.
Okay.
Let's go.
What percentage? What percentage are we at?
99.
It doesn't really matter. He at least
Nice.
retracted it.
No, you said 99. That's fine. All right.
Okay.
Satisfied, Gally?
Yeah, it's huge. It's massive. Thanks, man.
I love you, darling.
Okay.
It's called progress, not perfection, you know? And we're making it. Very proud of everyone in the room that just witnessed that and everyone that was a part of that. It was a big deal. Congratulations, everyone. We've made it.
Yep. Now you got to go look up what an independent variable is.
At least
I've
the
already-
Globers, like this is
Be all caught
a
up.
pro for the Globers. Being able to
Grumman
adjust
posted
your
something.
claims is actually good for them because some people like double down on wrong claims. That makes the Globers look worse.
Yeah, we gotta avoid dogmatism. And if people don't know what dogmatism is, that is when you merely reassert a precept and don't have defense for it without defending it. So that would be dogmatism. But Grumman, you posted this in the chat. I'm taking a
I
look
know
at
where
it.
that's from. I know where it's from.
Yeah, I do too. I can tell by
I
the
can tell
graphic.
by the font. Yeah.
The objective of a rocket launch is not only to reach space, but also to orbit the Earth. To achieve it, a spacecraft needs to gain a sufficient speed parallel to Earth's surface. When orbiting, a spacecraft has sufficient speed to counter Earth's gravity and does not need to continuously consume energy to stay in space. A rocket launched straight up will never orbit Earth. After it runs out of fuel, it will fall back to Earth like a rock. Now, what I was asking about was, how do you know where it actually is by just observing it optically? Because when something goes to a certain point in your field of view or a certain distance away, especially something that's making like a parabolic shape, it is really hard to tell where that thing actually is, especially even with just like airplanes, and they go up at like an angle and then they sort of stabilize out. This is making a parabolic shape. I don't know if airplanes make a parabolic shape like that, but airplanes are hard to know exactly where they are.
There is a point where I start relying on the radio.
Right.
Because I do bring a radio to I like to call it hijack the signals, although I don't think that's the official term.
I got you.
That is cool.
So there's a point where you don't actually visually see it anymore, and you have to rely on other ways.
Yes.
Right? Telemetry, radio communications, etc.
The radio.
Now, when you say the radio, you're talking about like a broadcast from Houston or Cape Canaveral, whatever station.
I'm
talking.
I'm talking about intercepting the signals that the rocket is sending. So is
that legal?
Basically, I don't know. It's actually why I refrain from doing it with NRO launches, because the NRO is probably not going to like me intercepting signals from a classified launch.
It's not going to be illegal or anything like that. If it was sensitive information, it would be encrypted.
That's true.
Well, that's another thing. A lot of NRO launches are encrypted, so when it's
don't
an
admit
NRO
anything.
launch, I
just trust me on that one, Grumman.
Yeah, but if you receive data from or signal from anything like GPS or whatever, it's any satellite, then that's on them to encrypt their information. I mean, it's going out to everywhere, all at once, right?
Holy shoot, is that Kosho?
I mean, there
That's
was an
called plain
instant.
sight doctrine, Kosho. Like if it's in
There,
plain sight, they're able to. Okay, Grumman.
There was an instant where a guy got in hot water because he used a high-power telescope. He was tracking satellites that were orbiting above, and he took a picture of one, and it turned out to be a classified NRO sat that, of course, they didn't want anyone to know the look of. And booyah, baby! Now we know the look of it. So the NRO was like, well, so that was a fiasco and a half.
Yeah, but they can't charge him with anything. He didn't do anything illegal.
Yeah,
That's also true. The NRO was just angry, and they actually tried to take the guy to court, and the judge was like, "Are you stupid? Like, do you have negative brain?"
That's an interesting photo from Northern Rebellion. Look at that. See that, Grumman?
Yeah, I see
That's
that.
interesting. Makes sense though.
You know, I mean, I probably shouldn't have said 100% certainty because I try to keep an open mind, best I can.
That's good. That's all we ask, bro. Because then if you can have an open conversation, then it's a beautiful thing. You might get to a conclusion. You might learn a couple things. I might learn a couple things. But if you have
No, I
100% certainty of something with a closed mind, it's like, what are we doing here?
Yeah, I mean, here's the thing. I came from debating on Twitter, which is
Oh,
basically Chernobyl.
Yeah, we've all been on
I have
Twitter. We probably
100%
did.
certainty.
We probably did like 50 weeks on Twitter, right, Beast? Or not 50 weeks, maybe like 40 something weeks
Yeah.
every Friday.
It's a rough one. It's definitely rough.
Yeah, no, and so this is a nice change to actually talk to people that are open-minded. Mind you, there are some people in this server, none of you guys in the call, but there are some people in this server like Shane and Alan, and that I've had, let's just say, experiences with, because Twitter.
But it did lead you over here, didn't it?
Yeah,
Oh,
I
were
mean,
you there for Flat Earth Fridays?
yeah, I was there for Flat Earth Fridays a lot.
That's awesome. I never saw you in there.
It's weird because, well, my name has always been the same as the one that I'm using now.
I think I joined around episode 78 or 79.
I think I was long gone by like episode 60.
You know, I was coming then. I'm just kidding.
I don't know why. For me, it just kind of got, because in Flat Earth Fridays it was run by people that weren't like, that didn't listen. So it just, after a while, and it was also very sporadic. So I was only on maybe 10 episodes. Maybe. And it never went anywhere. So eventually I was like, yeah, no, this is just me wasting my time at this point.
I like epistemics, logic, justification for argumentation, and I've been spending about 6 months, maybe 4+ hours a day, working on that with a tight group of really strong apologists. So that's where my primary focus is in any type of argumentation.
You mean
Sorry.
well endowed
Okay.
apologists?
I'm
Yeah,
I'm gonna
in like the classical
sorry.
sense of apologist.
Sorry, I'm gonna stay in the call. I'm gonna mute because I'm gonna be eating, and I don't think you guys want to hear me munching. So
Is it raw meat?
Well, it is meat, but it's not raw.
That's the next thing you got to learn.
Okay.
He's not kidding, by the way.
No, I know. I've thought about it. I'm gonna be honest. I've thought about it, but never actually gone through with it.
Well, you should try it.
Kosho says he hates sales, but I'm good at it. Sell me the globe, Kosho. I got a supply for globe proofs. I'm gonna sell it to you.
I want a refund.
Oh, Kosho's not there. Dang it. That's fine. Well, that was fun.
I'm actually
I had a good time.
Yeah, I'm actually gonna send an image that I made as a reference to the the making of the F-15 Eagle as a response to the Russians with what they called the most advanced fighter back in the 60s. So this was McDonnell Douglas immediately after. I don't know why I made this. Here is.
All right. What is that?
It's
An
an
F-22
F-15.
Eagle? It says
No, it's an
22 on the
F-15.
thing, right?
No, that's. Oh no, that's the Air Force part, like, because it's part of the National Guard. But no,
So you're
that's an
really
F-15.
you're into planes, huh?
Well, dude, have you seen my profile?
For sure. You know, there's this guy who has an account. You know, he's a jet fighter pilot for 25 years or something like that. Supposedly, you know, this is just anecdotal.
Oh no,
And
I'm nowhere near being a pilot like of that caliber.
right, but
I'm just
imagine a pilot of that caliber, right?
right.
Coming into the flat Earth conversation and realizing that, holy crap, I'm going 2,000 miles per hour over water, right? Like literally, on right above the water, trying to fly under radar or something like that, and realizing that he's not deviating from straight that fast. You know what I mean? Not having to angle down. I get what people say on the globe side. They say down is relative to the center of Earth, and it's perpendicular, you know, to your horizontal, etc. Whatever. I get all that. I just want you to think about that.
Oh yeah, no, I can think about that.
2,000 miles per hour, just flying over water.
Well, okay. It probably wasn't. Sorry. It probably wasn't 2,000 miles per hour, because 2,000 miles per hour at sea level would shred the wings off.
Right. Yeah, no, he didn't want to do this. I can't remember exact specifics, but he was like trying to hide from some type of radar or something like that. So he had to fly really close to the water. So any
Yeah, no,
move that went
flying low. It's either fly high or fly low. And because of radar nowadays, being that you can track the International Space Station with it, flying high isn't really an option.
All right. Well, Finn Gracie is posting the F-16 pilot testimonial. Said that's a good vid. Oh, that's a good one. There's a bunch of documents. I think I still have some of them. Not sure if it's some of them might be broken links. You might just have to Wayback Machine some of them, but
Dude,
81. Sorry.
I've been on the internet long enough that the amount of broken links that I've encountered, like someone is like, "Hey, click this," and it's like this link doesn't work, and it's like, it used to be really annoying, but after like the fifth time, it was like, damn. Okay. Never mind. Guess I'm not going there today. And if it is broken, which it's not, that would have been the, what, 200th time I've gotten a broken link? I don't know why I keep track of it, but because it's not broken, I'm still at 199.
Cool. You gotta. You might break it right now with the thing I just sent to you.
Yeah, never mind. That's 200. Hold on.
Some of them are old. This is old paper.
Okay, hold on. I'm gonna see. CIA.gov.
Yeah,
Okay,
some of
that
them are
one's
old,
not
brother.
broken. Army.mil. I thought that one was broken. I'm just clicking these links to be sure, because I'm already at 200 now, because I clicked one and it was busted up. All the Army mill ones are functioning. The second you get down to NASA, it's
Yeah, the reason why is because NASA revamped their website about 2 years ago, maybe a year
as
ago.
government agencies often do. The Air Force did the same thing, and we lost a bunch of shit from them. So
We'll Wayback Machine it though for sure.
yeah, so that's 200 already. We've hit 200. I'm gonna click another. Okay, that one works. Another